Hello students, very good evening, good morning, good afternoon, whenever you are watching this video. Now in today's class, I am going to start a very important chapter. Trust me, if you understand this chapter fully, then you didn't have any problem in alkyl, aryl, aldehyde, ketone, alcohol, phenol, ether, carboxylic acid, amines. Any chapter you will not find a single difficulty, that is my guarantee. From here, you are able to understand organic chemistry. And I will try, not guaranteed. I will see after making what will happen. I will try to make this video as one shot. If one shot I will complete, you can watch either in 2 times or 3 times, but definitely you will complete it. Okay? Now, up to now, what I have studied in organic chemistry, this is the preparation, that is the preparation. Now, my way of teaching is totally different. What is different, sir? In Grignard reagent, I have taught you one shot. Everything of Grignard reagent at one place. Similarly, qualitative, quantitative analysis, each and everything at one place. Similarly, hydrocarbon, I will teach you in such a way that you will realize how to learn, how to understand the topic. Sir, what you are saying, we are not getting it. Don't worry. Just see the way of my teaching. First of all, I will dictate you something about free radical. First, I am starting free radical mechanism. And I will not dictate you mechanism first. I will dictate you something different. Just see it very properly. A very good notes also I will provide. I will go a little bit slow. So if you want to study it fast, you can make it 1.5, 1.75 like that speed. But more than 1.5 is not good. You have already studied about free radical in chemical bonding. What do you mean by that, sir? Suppose I have written CS3 dot. And one place I will write CF3 dot. Leave dot. I will not write dot. Just see. Suppose I have written CS3 and I have written CF3. I will ask you what is the hybridization you will get. Hybridization. So to find the hybridization, we have to use the formula steric number. Sn means steric number. And those student has studied chemical bonding with me, I will teach you chemical bonding in different way also. Don't worry. Sir, what you are talking about? Just concentrate over here. Hydrocarbon. Hydro means, you already know basic things. Hydro means hydrogen. Sir, why you are teaching this? Just trust me. I want to give you a very good notes. Hydro means hydrogen and carbon means carbon. It means carbon means carbon. So this chapter basically contain a hydrogen and carbon containing compound. This chapter basically contain hydrogen and carbon containing compound. So the name of this chapter is hydrocarbon. In that chapter, first topic I am going to teach you, and the name of the topic is free radical mechanism. Before going with that topic, I will say you suppose one example I have written CH3 and another example I have written CF3. And I will tell you yes, my dear students, tell me what is the hybridization of CH3 and what is the hybridization of CF3. You will say, sir, I didn't know the formula to find hybridization. But I will tell you steric number is equals to surrounding atom plus lone pair. SA means side atom or surrounding atom. And LP means lone pair. Now, first I will say, okay sir, I am going to find for CH3. First question I will ask you, yes bachche, tell me what is the valence electron of carbon. Sir, valence electron of carbon is 4. Okay. And hydrogen has 1. How many bond hydrogen will form? 1 bond here, 1 bond here, 1 bond here. Now, if you will use the formula for steric number, what you will say? How many surrounding atom? Sir, 3 hydrogen plus lone pair I have written, but over here unpaired is there. So whenever side atom is less electronegative than central atom, carbon is central atom, Ca means central atom, and Sa means surrounding atom or side atom. Whenever central at side atom, SA means side atom. I will write each and everything. Sir, why you are writing? Just I am saying now, if you want to go slow or fast, there is an option in the YouTube you can do. CA means central atom. So whenever the side atom is less electronegative than surrounding atom, then unpaired is not considered inside hybridization or steric number. Does not consider inside steric number, and vice versa. Vice versa means if surrounding atom is more electronegative than central atom, then it will be considered. So steric number is coming 3. Hybridization is sp2. But if I will go with CF3, what you will say? Carbon has still 1, 2, 3, 4 valence electron. Fluorine forms always one bond. Here one bond, here one bond. Over here, if you will find the steric number, what you will say? Surrounding atom of CF3 is 3 fluorine is surrounding. Plus, this time unpaired is considered as a lone pair. It will come inside the hybridization, and their hybridization will become 4, and it is coming sp3. You know that sp2 means trigonal planar. This chapter is very important, so I will go a little bit slow. If you know something, then you will do 1.5x speed. And sp3 is tetrahedral. First question they will ask, ki in the CS3 one dot is left and in the CF3 one dot is left. Tell me where this dot is present. So you will say this dot is not going inside hybridization. This dot is not going inside hybridization. So this will present in pure p orbital because carbon has p orbital. But over here this CF3 dot is present inside sp3 hybridized orbital. Understood? Because that CF3 dot is taking part in the hybridization. So over here unpaired electron is present in sp3 orbital, but over here it is not present in hybrid orbital, it is present in pure p orbital. P. The first free radical, you have understood two types of free radical. One free radical in which side atom is more electronegative than surrounding, and one free radical is that side atom is less electronegative than surrounding, in which side atom is less electronegative than it will present in pure p, side atom is more electronegative than it will present in hybrid orbital, that is sp3. In this hydrocarbon chapter, we have to study about SCH3 dot. We didn't have to study about CF3 dot. This topic is not there in this chapter. Now, first you understand this part. Now, after this, as I will ask you, ki over here, you have a one formula, N is equals to number of unpaired electrons, and mm, that is also denoted as mu, and that is called magnetic moment. If I will ask you what is the magnetic moment formula, you will say N into N plus 2, where N is the number of unpaired electron and their unit is Bohr's magneton. So if I will tell you to find the magnetic moment for CS3 dot, so how many unpaired electron it has? Sir, only one unpaired electron it has. The structure you have already seen. Over here, if you will find magnetic moment, what you will get? Under root 1 into 1 plus 2 Bohr's magnetum. That is coming under root 3 Bohr's magnetum. That is coming 1.73 Bohr's magnetum. It means magnetic moment of CS3 dot is 1.73. And there is a rule. If magnetic moment is 0, that type of compound is known as diamagnetic, and that type of compound is colorless. Another formula is, another way of dictating is, if magnetic moment is not 0, anything 1, 2, 3, 4, 5, 6 negative to not coming, na, integers coming, not integer, natural number coming, then it will become paramagnetic. And whenever it is paramagnetic, it has some color, so we will call it as colorful. So from here we will write कि free radical, any free radical, especially I have taken CS3 dot, but any free radical if we will talk, what I will say, their magnetic moment is not zero, as well as if not zero, it means free radical are paramagnetic, and that is colorful. Acha. If I will check this free radical H and H, one dot, how many electron this carbon has? Sir, 1, 2, 3, 4, 5, 6 and 1, 7. It means free radical is only has 7 electron, so it is known as odd electron species. It has 7 electrons, so it is known as odd electron species. After dictating this, now I am going to write some important points regarding free radical. I hope you have understood. This chapter I will not do 2 to 3 times revision, otherwise you will get confused. Slowly I will teach. If you are not understanding anything, you will go back and see the things. Some important points, some properties of free radical. After dictating something about free radical, I am going to dictate you some important properties of free radical. What is that important properties? Slowly, sir, don't panic. I am also not panicking, and I will suggest you all also not to panic. If you need something very fastly, you can see in 1.5x speed. Don't say, sir, you are teaching slow. Handwriting, I will write very good. First important point I can write, and this chapter is very important, sir, trust me. Those who are able to understand this chapter, after that electrophilic aromatic substitution, for them organic chemistry became very easy. Now first important point, can I say it consists of one unpaired electron which makes it paramagnetic and colorful. Just now I have proved it also by doing it. But we have got magnetic moment is equals to 1.73 Bohr's magneton. H. Second and very important point is it is highly unstable, and it has zero activation energy. What do you mean by that? Suppose if you will boil water, so at least water needed to go to 100 degrees Celsius before it will evaporate. Similarly, everything needed some activation energy, but it has zero activation energy. First important question in advance has been asked. What is the activation energy of free radical? So it has zero activation energy, so that whenever you will draw the graph for potential energy versus reaction coordinate, their graph will coming like this. Previously potential energy is high, and suddenly it will become low because zero activation energy. It will not wait for anything to do. This is the graph. If potential zero activation energy, it means it will not need activation energy is there. Then we are drawing the graph like that. It is activation energy. We will not have to draw like that. Simple. This is the graph because it has zero activation energy. Third important point, can I say it is incomplete octet because one electron is not going to form a bond. So it is incomplete octet, and as well as odd electron species. I have written just now it has 7 electron. Fourth and very important point, that as it has zero activation energy, so whenever you will get 1 degree and 2 degree free radical, whenever you will get 1 degree and 2 degree free radical, it will always do combination reaction. It will always do combination reaction. Don't worry, I will write lots of example and I will dictate you. And whenever you have 3 degree, whenever you have 3 degree free radical, then it will always do disproportion reaction. What it will do? Disproportion reaction. Whenever it has 3 degree free radical, it will do disproportion reaction. As well as, next important point, what is 1 degree combination free radical? I will dictate everything, don't worry. Fifth important point, that it can also do rearrangement. Wait, sir, we have studied only carbocation rearrangement. No problem, not in our syllabus, not a part of syllabus. This topic we didn't have to study in JEE level, advanced level. So rearrangement is not there. But suppose they will ask advanced, so anything they will do, no, they will ask, can we do rearrangement in free radical? Don't say no, yes we can do. Acha. Sixth important point, we know that whenever free radical is there, the rate of reaction is always depends upon stability of free radical. And I have already dictated you GOC. So over there you can see the stability of free radical, how we will judge it. Understood this all point? Sure short, everyone? If not understood, see it again. If I will do revision, again they will get confused. But I am just saying you for simple way. First, two types of free radical. Whenever a side atom is less electronegative, then unpaired is not considered inside. More electronegative, it will considered. So whenever they will ask CS3 dot, where the dot will present? In the pure orbital. But CF3 dot, where the dot will present? In sp3 hybridized. In our syllabus, CS3 dot we have to study. Then I have find the magnetic moment under root n into n plus 2. I have put the formula and I will get the result. After that, I have dictated you whenever there is a magnetic moment 0, then we will say that compound is a diamagnetic. And whenever magnetic moment is not 0, that compound is a paramagnetic. And colorful, it is colorless. On that basis, we have seen free radical, that it is colorful because it is paramagnetic and colorful. 7 electron, odd electron species. First, it contains 1 unpaired electron. Second, it has 0 activation energy, highly unstable. Incomplete octet, odd electron species. Odd electron species means 7 electron. Odd electron species means 7 electron. 1 degree and 2 degree free radical will do combination reaction. And 3 degree free radical will do disproportion reaction. And it can also do rearrangement, but it is not in our syllabus. And rate of reaction is directly proportional to stability of free radical. I hope you have understood what I am trying to say. Sir, we didn't understood the fourth point. What do you mean by 1 degree will do combination, 2 degree will do combination, 3 degree will do disproportion? Don't worry. I will show you some questions regarding that. Now, if I will see the question that 1 and 2 degree will do combination and 3 degree will do disproportion, suppose some questions we have. Whenever they will give the question, always try to understood either written or not written, it is 2 mole. Whenever there is a question written or not written, always consider it as 2 mole. Written or not written, always consider it as 2 mole. Written or not written, always consider it as 2 mole. Automatically. Now, it is 1 degree, 2 degree, 3 degree. Sir, it is 1 degree. So it will become double. CS3 combination. It is 1 degree, 2 degree, 3 degree. Sir, it is 1 degree. So CS3, CH2. Then again CH2, CH3. Double it will break. This can also be drawn like this. 1, 2. 2 carbon. Then 1 extra bond. Then again 1, 2. It means whenever 4 carbon is coming, this 2 means this and this CH3, CH2, CH3, CH2. This is in the middle is an extra bond. Achha. Why I am dictating this? So you will not get confused how to draw it. First understood, second understood, yes sir. Third part, what you will do? Sir, it is also doing combination reaction, and after combination what it will become? 1, 2 is there, another 2 will come like this. Okay sir, directly double in that way. Achha, sir, this is also 1 degree. What I will do? 1 degree and 2 degree, both will do combination. There, then 1 extra bond, then after that this, and this is opposite. It means this is one part of 2 mole, and this is another part of 2 mole, and this is the bonding between them. So don't get confused in that. Over here, sir, over here it is also 1 degree. Either double bond is there, but it is coming on 1 degree na. Ha sir. Here, then after that one extra bond you will form, then again here. Understood? It means this is first original structure, this is second original structure, and this is the bond that is combining these two structure, this bond. Understanding? Acha, over here also benzene ring. Ha sir, it will also do combination reaction. Here again, here this is combination reaction. Acha sir, this much easy. Yes. Acha, in this part if I will do resonance also, here and here, what you will get? Double bond coming here, resonance coming here, and if you will do 2 mole considering, so it will also do combination. It will also do combination. So this product and this product is looking same, so I have not done the resonance. I have not done the resonance. See any difference in these two products? No sir, looking exactly same. So they are not doing resonance. I have not done the resonance. But if you will see there, what is the things? First you will say ki sir it is 1 degree. Okay sir, 1 degree will do combination, 2 degree will do combination. So first I will do the combination reaction. Here double bond, here. After that I will make one extra bond, that to combine both two, and then again I will come 1, 2, 3, and here double bond. This is coming combination, but someone will say, no sir, I want to do resonance over here, resonance over here. This will become dot, this will become dot, and because of making the dot, it will become another compound. How sir? Here double bond coming, now dot shifted here. Now once the dot shifted here, what is the another product you will get? Sir, this, and on the top side, this, double bond. Yani over here two different product coming, because allylic means benzene double bond pi sigma free radical will do resonance. So whenever it is doing resonance, you have to try to do the resonance. So this product is one product, this product is second product. After resonance, combination only doing. All are doing combination, but resonance possible, so you will draw the resonance also. Over here no need to draw, because in this structure both structure is looking same. So I have not done resonance, but over here both structure is not looking same, so I have done the resonance. Now this is good example. What is good example? Sir, it is 3 degrees sir. Up to now 1 degree and 2 degree coming. So 3 degree will do disproportion. 2 mole is there. So what you have to do? You have to take 1 mole and you have to take another mole. 1 mole has free radical, another mole has free radical. Now on the first mole, any one place, either this place or this place or this place, any one place you have to check hydrogen. Yes sir, this is the hydrogen, and do free radical from here. Dot and dot, and this dot combine together to form double bond, and this will come here. It means you will get the product. Here double bond, and here one hydrogen. If you will write hydrogen or not write, it will be as it is. Sir, everything I understood, but I didn't understood this 3 radical things. Don't worry, simple. If 3 radical is there, 3 degree is there, suppose here I will make double bond. So you will do one thing. First you will make one compound as it is, and then try to put double bond here or here, any one place. But while putting, check which double bond is more stable. Sir, this double bond is more stable because of more number of alpha hydrogen. So this is the 3 degree answer. No sir, not understood. Acha, okay. Suppose I will draw the structure like this. Here dot 3 degree. So one structure you will draw as it is. What is the given structure? As it is will be the one answer, without removing the free radical. Another will be double bond coming. As it is, draw the structure, and then where you will put the double bond, so this structure will become more stable here. Now understood? So 1 degree, 2 degree, direct combination. But 3 degree, one is alkane, one is alkene. 2 product will come in 3 degree. So I hope you understood about the basic part. So at the last, can I write, if we will have 1 degree and 2 degree free radical, it will do combination, and product has double carbon, then reactant. If reactant is 1 carbon, product has 2 carbon. Check every place. here 1 carbon, here 2 carbon, here 2 carbon, here 4 carbon, here 1 2 3 carbon, here 1 2 3 4 5 6 carbon, double coming. हाँ sir. But if it is 3 degree free radical, then it will do this proportion, and in this proportion you will get one product as same as it is alkane, and another product you are getting alkene, and especially those alkene that is highly stable alkene. Which alkene? Highly stable. How we are checking the highly stable alkene? By checking more number of alpha hydrogen, and that you have studied in hyperconjugation. So do you know what I will do right now? I will do all the reaction of whole organic chemistry I will teach which contain free radical mechanism. Understanding? First basic things I have dictated you about free radical. Now I am going to do all the reaction that contain free radical mechanism. So it will be very easy for you to understand this topic. This is question number 9th. This is question number 10th. Understanding, sir? Any confusion? Seriously, if you have confusion, see it again. I am saying this video is going to be more than 3 hours, 4 hours. I didn't know. Just now I have started and I am trying to complete it for all one shot. I am going to be successful or not, that I am also not sure. Yes, up to now you will revise. I am going to dictate you the next part. Now we will see. My teaching is first free radical. Don't get panic. If you will understand the way of my teaching organic chemistry, you started enjoying organic chemistry, trust me. Now after that I will dictate you all the reaction that contain free radical. Whole organic chemistry, sir. Whole. Arey sir, this is the very good idea. Okay. Now we are going to see the reactions of free radical. What we are going to see? The reactions of free radical. What are the reactions? What is their response? Everything we are going to see about free radical. And this chapter notes will be very good because it is one of the good. Those who wants to download these notes, they can see the comment, not description. Because I didn't know how to upload in description. Comment I am able to, so I am uploading over there. Now, first reaction we will have is urge reaction. What we will have? Urge reaction. In urge reaction, I will take sodium. I will take sodium as a metal. I am taking sodium as a metal. Sometime it is also written in the book. What is written? In presence of active metal sodium. What do you mean by that? Active metal? Active metal means those who will react, they will lose the electron. Now, what is happening in urge reaction? Na? First sodium will come, and you know that sodium will always release one electron. What it will release? One electron. And you have to take one alkyl halide. You already know R is alkyl and X is halide. Alkyl has a formula CnH2n plus 1. And halide is fluorine, chlorine, bromine, iodine. I will try. I will not take fluorine. I will try it because fluorine is not good. The chlorine, bromine or iodine I will take. So suppose I have taken alkyl halide. We know that electronegativity of halide is always more than electronegativity of alkyl. And in GOC I have dictated you first video, it will do heterolytic cleavage. Once it will do heterolytic cleavage, it will get minus, it will get plus. This cleavage is known as heterolytic cleavage. Heterolytic cleavage. So I am saying now, before coming to here, you have to be very good in GOC part. Heterolytic cleavage. Now, once the R plus will form, the electron from sodium will come, and they will say R plus bhaiya, take my electron, and it will take the electron, and it will become R dot plus X minus. Now, just now I have dictated you कि once the dot will form, if this dot is forming 1 degree and 2 degree, directly you will do combination, and with the combination it will become R and R, that it will become alkane. And if it is coming 3 degree, then you will do this, and just now I have dictated you how you will, question also I will dictate more, don't worry, and it will form one alkane and one alkene. Just now you have seen lots of example regarding that previously done sodium Wurtz reaction. This is happening in Wurtz reaction. Now some important points I am going to write about Wurtz reaction. And in chemistry, important points for organic chemistry is known as stereochemistry. Important point is known as stereochemistry. So don't get confused कि what do you mean by stereochemistry. So we are going to see stereochemistry for Wurtz reaction. We are going to see the stereochemistry for Wurtz reaction. What are the important points it has? Okay, sir, dictate us. We are waiting for that. Okay. And I am not putting any watermark like for my YouTube channel कि whenever you will download notes my name will come. No, I don't want to become that much popular. I just want your love, and once you will get selected, please give me one gift after your JEE exam. I will be very happy with that, and I will arrange that gift as my house for future purpose, to show off others. See, these are the students who qualified in JEE. Achha, sir. Now, first stereochemistry I will say कि in Wurtz reaction what is happening? Sir, free radical is formed. Free radical is the intermediate, and in GOC I have dictated you free radical, carbocation and carboanion is always coming intermediate. So if anybody is asking, rate of reaction is directly proportional to a stability of free radical. How much stable the free radical is, easily the reaction will happen. Okay. Second important point, if they will ask you कि we have Ri, Rbr, RCl and Rf, in which part Wurtz reaction is happen very fastly? So you will say in I, then in Br, then in Cl, then in F. Why? Because of leaving group. Because of leaving group. Iodine is easily leaves the alkyl. After that bromine, after that chlorine, and after that fluorine. This I am writing for free radical, but this is valid for each and everything. This is valid for each and everything. What do you mean by that? If SN1 coming, SN2 coming, E1 coming, E2 coming, free radical coming, anything coming, leaving group needed to be very good. And over here leaving group is iodine, then bromine, then chlorine, then fluorine is always in every cases. So this is the second important point. Third important point is that what is the metal you are taking, sir? Sir, we are taking metal. Sir, what you have written before that, that only making the point? Yes. So that you have a very good notes and very good understood. I am saying na कि we are able to do each and everything about hydrocarbon, but because for me hydrocarbon is one of the most important reaction, important chapter. Fourth important point कि if 1 degree and 2 degree, then it will do combination. Sir, how many times you will write? As much time as is possible. And if it is 3 degree, then it will do disproportion. Okay, sir, this point we understood it. Go with next point. Fifth important point, what you will see कि symmetrical alkane is formed. Symmetrical alkane is formed. Symmetrical alkane is formed, that is also known as even number of alkane is formed. Even number of alkane is formed. What do you mean by that? See, every example of free radical, how many carbon it has? See from starting. First has 1 carbon becoming what? 2. Second has 2 carbon becoming what? 4. It has 1, 2, 3. It will become 1, 2, 3, 4, 5, 6. Product is always even. Check. 1, 2, 3, 4, 5, 6, 7, 8. Product is always even number of carbon coming. Product is always even number of carbon coming in free radical mechanism. Always even number of carbon coming. Sixth important point, and it may be this will ask in the advance as a point. Does carboanion is also formed in carboanion is also formed in Wurtz reaction? Yes, sir. Carboanion can also be formed in Wurtz reaction. Can also be formed in Wurtz reaction. Sir, just now you have said free radical will form. Always free radical will form. But if theoretical question will come, you will say yes, carboanion can also form. How, sir? See, sorry. Whenever you are doing mechanism, one sodium is there. If I will take 2 sodium, the 2 electron will come, 2 electron will go. So R dot will become what? R minus. First it will become dot. 2 electron coming. It is written as R minus. Understanding? It means there is a possibility of carboanion. How? If 2 moles of sodium is there. If 2 moles of sodium is there. But you didn't have to make carboanion any time. If this theoretical question will come, then you will write. Practically always free radical. Okay. Acha, seventh important point, you will see every place CH4 not prepared. See, every place CH4 not prepared. Any place you will check. 1 carbon you will take, what it will become? 2 carbon, na sir. 1 carbon will become 2 carbon. So how you will form 1 carbon? Yani one problem coming, CH4 cannot be prepared in Wurtz reaction. Eighth important point coming, and that what I will do now, understood the point. First I have dictated free radical. After dictating free radical, I have dictated you the reaction of free radical, and first reaction is Wurtz reaction. In that, what is problem coming? First coming is CH4 not prepared. So next reaction I will dictate you how to prepare CH4. Oh, second important problem coming कि we are not able to produced odd number of carbon. If you will take 1, became 2, 2, 4, 3, 6, 4, 8, 8 means always you are forming symmetrical alkene and even number of carbon. You are not able to form odd number of carbon. It means first understood the way of teaching my organic chemistry. First I have dictated you that what is free radical. Then I have taken free radical first reaction, Wurtz reaction. In that Wurtz reaction we are facing 2 problems. First problem is that we are not able to produce CH4, and second problem is that we are not able to produce odd number of carbon. Then after that I will teach you which of the following will produce CH4 and which of the following will produce odd number of carbon. It will become very easy for you how I am teaching it. Understanding the point what I am trying to say? Yes sir, we are understanding. Now over here, if we will see Wurtz reaction, so Wurtz type lots of reaction is coming. What do you mean by that? It means first I have dictated you Wurtz reaction. Now I am going to dictate you next reaction, free radical only. I am not preparing CH4, not preparing odd number of carbon. That I will do later. First I will see which types of reaction is same as Wurtz, and then I will see some questions of Wurtz reaction. Then at last we will do CH4 preparation, then odd number of preparation carbon. Job done. Understanding, sirs? Acha sir, like that you will teach. Yes, my dear friends. Now next topic I am going to start Wurtz family. Wurtz reaction we have seen. Some of the scientists came and who is giving the reaction just like Wurtz has given. So I have named it as Wurtz family. See, what is the easy way to learn? And all Wurtz family, all will follow free radical mechanism. All will follow free radical mechanism. Means 1 degree and 2 degree combination. Sir, how many times we will write this? All the time. 3 degree disproportion. 1 degree, 2 degree combination, 3 degree disproportion it will do. Now I am going to write all the reaction that is coming in Wurtz family. So first of all, I will say, sir, Wurtz reaction. What the Urj sir has done? He has taken alkyl halide. He has taken alkyl halide in presence of sodium. Moles I will not write ki 2 mole here, 2 mole here. If not given also you have to understood it. In presence of little bit dry ether. Sometime question coming, why dry ether? See, understood. What is happening? Ki Na is breaking 1 electron, became Na plus and 1 electron. And Rx is breaking and becoming R plus X minus, and it is giving the electron, and because of that it is becoming R dot. Question is that why it is taking the electron? If he needs the electron, why it will not again combine and become this product? So we are using dry ether. What the dry ether will do? Suppose Et2O and Et2O, dry ether. R plus coming, it will solvate it. Plus is there, they will say don't worry. Suppose some girls is getting breakup, so some boys is coming and saying don't worry, I am your best friend, I will take care. Similarly, R has got breakup, and this Et2O has lone pair of electron. They will come over here and say don't worry, don't worry. So it will not again go with X and not X, yes, not that X. Now, so what we will write in a chemistry language, we are writing to solvate. Dry ether is used to solvate. This is the term we are using in Grignard reagent also you have seen. Okay sir. Welcome back to the topic. In Urj reaction, what you have seen, ki Rx will react with, here I will make one line so you will not get confused. Okay sir. Now over here what will happen, Rx is react with sodium in presence of dry ether. It will form R and R. NaX will form outside. That I will, what is the use of writing, that you know already. Precipitate is there, NaCl, NaBr, NaI, like that. Now Urj sir has written this reaction and not try for other things, and he will go in the pub with his girlfriend and enjoying the life. Yes, I have discovered. Yes, I have discovered. Whenever he is enjoying, at the same time one scientist came, and whose name is Fitting. He said कि सैया भैया मेरे, you have dictated alkyl halide, I will take aryl halide. pH means phenyl. You have taken sodium, I will also take sodium. You have taken dry ether, I will also take dry ether. But I will take little bit amount of heat. But I will take little bit amount of heat. So what happens? Like that you are forming alkyl, I will also form the biphenyl, and NaX will come. Now Urj sir started crying, Bhaiya, it is cheating. You have taken all my reaction after putting heat. You have taken the credit and you have given the name. Right now Urj sir has not stopped crying. At the same time one more scientist came, whose name is Uleman. He is saying that, Acha, Rx and sodium and PHX sodium, do one thing. I will use another part. What I will do? I will take PHX and copper, and I will get PH biphenyl plus CuX2 copper halide, because copper has 2 valency, to CuX2. Urj sir saying, Arey yaar, what rubbish is this? I am discovering something. Everyone is coming and ruining this and taking the all credit. Ab now still he has not stopped crying. At the same time one scientist came, Frankland, and he is saying, Bhaiya, you are playing with alkyl aryl, I will play with something. What I will play? Either you will take alkyl or you will take aryl. Take zinc as a metal. Take zinc as a metal. Dry ether everyone is using. Dry ether and heat everyone is using. Over here it is also using dry ether and heat. He is also using dry ether and heat. Zinc as a metal. You will take zinc as a metal, and then up to now Urj sir is doing for only alkyl. Urj sir is doing for only alkyl. Fitting is doing for only aryl. Uleman is also doing only aryl. But the scientist whose name is Frankland, he came and as he said, I will give you zinc metal, and that zinc metal is used for alkyl also, and ZnX2, and aryl also, PH and ZnX2. Now Urj sir taking the breakup with his girlfriend and started crying कि भैया, you all have cheated me. I have initiated the reaction. You are just changing the metal and you are taking the credit. Fitting has taken sodium, heat taken little bit, and aryl he discovered. Uleman has copper taken, again discovered aryl. Franklin are doing both the things, taking zinc. What I will do? and he will go into the depression. You said na, depression. He will go into the depression. At the same time, fitting sir came and say, sir, don't worry. You have only one name. I will give you one more name. I will not take your whole credit. I am your best friend. I will do one reaction, and that reaction is urge fitting. Means fitting sir has also not removed his own name, but he has given the credit for urge sir also regarding this. And in that credit, what he has said, he said, sir, you have taken alkyl, I have taken aryl. Both we are going to take alkyl also, and we are going to take aryl also in presence of 2 mole of sodium, every place 2 mole, and dry ether in presence of heat. So we will get PHR. PH means this, benzene ring with alkyl group. So this is the all reaction that will show urge family. It means what is the reaction you have seen in urge family? Sir, urge, sodium, alkyl, fitting, aryl, sodium plus heat, Ullmann, copper, Franklin, zinc, and urge fitting, alkyl and aryl both together with presence of sodium, and each and every reaction is doing free radical. Above all, urge family is doing free radical mechanism. And if all is doing free radical mechanism, so if R is 1 degree and 2 degree, then it will do combination, and aryl, pH is always 1 degree only, na? And 3 degree, it will do disproportion reaction. Now understood? Free radical we have done. Now after this we will some questions, and in free radical urge family we have found 2 problem. Problem number 7th, CH4 not prepared and odd number of carbon not prepared. After doing the questions, we will see the next reaction to prepare odd number of carbon. But before that, some student will say, sir, why you are not doing like this? You will do like this. What I will do, sir? You will do one thing. 1, 2, 3. Propane you will take. 1, 2, 3, 4. Over here Cl you will take. Over here Cl you will take. And try to produce in presence of sodium, dry ether and heat. Odd number to coming na sir. Here it will go free radical coming, here it will go free radical coming, not like this, it will go homolytic cleavage it will do. So try to do like that. Here dot will come, here dot will come, and this dot, 1, 2, 3. After that one bond, then 1, 2, 3, 4. Odd number to coming na sir. This is the bond. Odd number to coming na sir. What is the problem? Over here you are getting the odd number sir. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. One extra I have made. I will erase it and I will dictate you. 1, 2, 3, 1, 2, 3. This coming 1, 2, 3. Then one extra bond. Then 1, 2, 3, 4. 1, 2, 3, 4. How many carbon coming, sir? Sir, 1, 2, 3, 4, 5, 6, 7. Sir, odd number to prepare, sir. You have written 8th number point. Ki we are not able to prepare odd number of carbon. Hi, sir. How, sir? Over here to prepare, na? You have taken, na? You are saying, na, ki whenever you are taking CS3, you are taking 2 mole. Instead of 2 mole, I have taken 1 mole this, 1 mole this. I have not taken one thing 2 moles. I have taken 2 things 2 moles. What is the problem coming? This product to coming. No problem. No problem. But this is 1 mole also. 1 mole means 6.022 into 10 to power 23 atom. So 3 product will come. It itself doing combination. 1, 2, 3. 1, 2, 3. 1 product will come here. From here 1, 2, 3, 4. 1, 2, 3, 4. It means 1 product this, 1 product this, and 3 different product coming. Suppose you will take only this 2 mole Cl. So what you will get? 1, 2, 1, 2. This you are getting. How many times you are getting? You are getting only this part. Na? You are not getting anything extra. Na? But over here, there is a possibility you will get 3 different products. And these three different, why? Because 1 mole doesn't means 1 piece. 1 mole means 6.022 into the power 23 atoms. Lots of pieces are there. So there some atom will attach with themselves and forming this. There some atom will attach with themselves forming this. And these two is combining forming this. It means in this case you are getting mixed product. What you are getting? Mixed product. 2 to 3 things. And it will give very bad yield. It will give very bad yield. Bad yield means bad quantity. Very less quantity, each and everything will come. So I have written one point now over here. Symmetrical alkane is formed. Always symmetrical alkane is formed. Unsymmetrical odd number, don't try to form it. If you are taking this, take only this of 2 mole. If you are taking this, take this only as 2 mole. It means I am saying that if you have taken 1, 2, 3 here Cl, so another also you will take 1, 2, 3 here Cl. This and this must be same in presence of sodium and dry ether. If you will change these two, 1, 2, 3, 1, 2, 3, 6. If you will change these two, then answer is not good and that will not valid for Urge reaction. So odd number of carbon cannot be prepared. Now I hope you understood something. Yes sir. Now we are going to do some questions. Then we will see how to produce CH4 and how to produce odd number of carbon with good yield, because these two things not coming in the Urge family. Okay sirs? Okay sirs. Now we will see some example regarding Urge family. First question. CH3 dot NaCl, it will do homolytic cleavage dot matlab heterolytic sodium matlab happens mechanism I will not dictate, one I will dictating. It will become minus, it will become plus, sodium is giving Na plus 1 electron, it will become dot. So overall we are getting CH3 dot yani 1 degree. So what we will get? CH3. Second question. Dot will come here. How? I have dictated. That much time I will not dictate to make you confused. What you will get? CH3, CH2, CH2, CH3. Third, here you will get dot. So 2 degree will do combination. Here you will get dot. 2 Cl is there. Understood? Good question. Here you will get dot. Here you will get dot. And dot combine together to form triple bond. Combination, अब don't say combination. 1 dot will come, then combination. 2 dot combine together to form 1 extra bond. Over here again. 1 dot here, 1 dot here. What I will get? Say fast. Aromatic compound here. Benzene ring. Here again. 1 dot here, 1 dot here. Single bond will become double bond. This. Acha, 1 dot here, 1 dot here. And you will form this. And it will be not the answer. Sir, just now you are doing and saying no. Why? Because when you will see it, it is anti-aromatic. Resonance. Pi sigma. And how many pi electron? 1, 2, 3, 4. And we know that 4 electron is anti-aromatic and anti-aromatic is highly unstable. Understanding? So this is not the product. What is the product coming? Combination. 1 here, 2 mole we have to take. Another mole will come, combine together. And it will form this. It will do combination. Means what is happening? 1 dot here. 1 dot here. Another compound will come. 1 dot here. And these 2 dot combine together to do combination reaction. And this is the product coming. That also you have to check. Now this is advanced question. And this one mains question also came. According to option you will take. If here 1 dot will come. Here 1 dot will come, here 1 dot will come. And these two combine together to form this. But if this is not the option, so which one is good living group? Sir, bromine is good living group. So you will make only dot in the side of bromine and another one, chlorine here, this dot combine to form this. So either this product will come for this or this product will come. So which option I will take? If this is the option, without checking you will take. If this option is not there, then go with this option. Suppose over here it will form dot. Understanding the dot. O ray, then O ray. Done. Double. Over here it will form dot, it will form dot, two dot coming, and cyclopropane dot dot combined together to form cyclopropane. Over here pH, copper, zinc, anything I will take, any urge family I will take. Suppose 12th number question, कभी कभी मेरे दिल में ख्याल. Now this, suppose over here you have taken Na dry ether. What will happen? Over here this dot is 3 degree. What you will do? 1 as it is. Instead of that I will write good type. This is also correct. And 1 will be like this double bond. But this structure will be not written like this. This will be written like this to look good. What will happen? Over same, both are same. Dot will come, 1 will be as it is and 1 will be like this double bond. Either written like that, you will form this or you form this. So I hope you understand all the questions that I have dictated. So any problem in the first question, sir? No, double happened. Second question, no. Third question, no. Fourth question, 2 dot coming, that 2 dot combined to form 1 bond, not doing double. So I have given all the example. Over here, aromaticity will come after 2 chlorine. 2 chlorine, single bond will become double bond. 2 chlorine, again double bond, but problem is that here anti-aromatic coming, so we will do combination reaction. Over here, 2 dot combine, if answer is this, not, then you will remove Br, because Br is good leaving group as compared to Cl. Combination reaction. Over here 2 dot, 1 dot here, 1 dot here, combined to prepare cyclopropane. Over here pH 3 degree, 1 alkane, 1 disproportionation reaction. So I hope you understand all the bakwas what I am doing regarding urge family. So in 1 hour we have completed urge family. Now over here, what are the problem we are getting in urge family, sir? Problem in urge family, sir. First problem is CH4 cannot be prepared. First problem is CH4 cannot be prepared. What is the second problem? So second problem is odd number of carbon cannot be prepared. These two problem is coming. What I will do? So I am going to sort out the problem to produce CH4. Then I will sort out the problem to produce odd number of carbon. Understood the way of my teaching? Sir. Understood, sir. Now, next reaction we are going to see, and the name of the reaction is soda lime decarboxylation. It means first I have dictated you what is free radical. On that free radical I have dictated you about urge family. And after urge family we are getting two problems. So we are going to sort that two problems. CH4 how to prepare and odd number of alkane how to prepare. Once we will sort out these two problems, then again we will come with the topic. Understanding the logic? Sir. Good way to understand. Okay. Soda lime. What do you mean by soda? Soda means caustic soda. Caustic soda. Lime means quick lime. Lime means quick lime. अब in caustic soda your mother is using at home for making the kachori, khasta English what I will say, easy to eat. Khasta I didn't know much. You are making that soda you are using in Italy like that, caustic soda. And quick lime is CaO. Now soda lime, soda means caustic soda, lime means quick lime, and decarboxylation means removal of carbon dioxide. Removal of carbon dioxide. Removal of carbon dioxide. And this is used to prepare CH4. Not only CH4, but one of the product will come CH4 because we are facing problem in producing CH4. So we are going to sort out the problem to produce CH4. Understood? Soda means caustic soda. Lime means quick lime. Decarboxylation means removal of carbon dioxide. Now, first, some important point, then I will teach what is happening inside the reaction. First, I will teach it only. Leave. What you will do? First, you will take any acid CH3COOH. It will react with what? NaOH, it will form CH3COONA. It means in quick lime, soda lime decarboxylation, what is the reagent you are using? You are using the reagent, not reactant. What is the reactant you are using? Reactant or reactant is also called substrate. So don't get confused. Reactant is also called substrate. Substrate we are using means reagent is caustic soda and quick lime. And substrate or reactant is what? Is sodium salt of carboxylic acid. What is the substrate or reactant? Sodium salt of carboxylic acid. Now I will take sodium salt of carboxylic acid, and that sodium salt of carboxylic acid CH3COONA I will react with NaOH, soda lime, that is CaO, and after reacting what will happen? Carbon dioxide will go from here and sodium is also here. These two combined and forming Na2CO3, and this CS3 will get one hydrogen. How? I will dictate that also, don't worry. And it will form CH4. It means what is happening? CH3 minus is coming, and CH3 minus will get H plus and form CH4. Means first important point what I will write, कि sir over here intermediate is not free radical. Sir, you said I will teach all free radical together. The bachche I am teaching free radical, we are getting one problem. So we have just switched the topic. कि CH4 not prepare, first I will prepare CH4. Odd number not coming, I will prepare that, and then we will go with the again free radical. Acha sir, it means first important point you will write कि over here the intermediate is carboanion, and carboanion intermediate means their rate is directly proportional to stability of carboanion. Previously stability of free radical, rate of reaction is directly proportional to stability of carboanion. Second important point I will write, it is known as, the name of this reaction is soda lime decarboxylation. Third reaction and question also I will do on that basis, don't worry. Third name is that in this part there is a removal of carbon dioxide. Fourth important point, it is also known as awkward degradation. Means soda lime decarboxylation is also known as awkward degradation. And fifth and very very important point, directly they are asking in the JEE exam, कि over here NaOH and CaO you are using, so you have to use 3 mole of NaOH and 1 mole of CaO. Instead of dictating their mechanism, I am dictating important point from where you are able to solve the question very easily. Understood? Don't go that much moe type. Just understood what is going on. We are focusing on qualifying in JEE, not to become PhD student. Understood? It means first CH3 minus is produced. It means intermediate is carboanion and stability is directly proportional to stability of carboanion. Over here removal of CO2, and it is known as awkward degradation. And very important point, कि NaOH and CaO is 3:1 mole. Means 3 mole of NaOH, 3 mole of NaOH and 1 mole of CaO is used in soda lime decarboxylation. That's it. Understood the point? Ha sir, now understood. Okay then. Now next important point you will write, and very important, that you will say कि we are able to prepare over here methane. How? See, first reaction only I have prepared methane. Problem coming. So methane, that is CH4, can also be prepared. So by the help of Urge reaction we are able to prepare even number, and by the help of soda lime decarboxylation, methane not coming, we have prepared it. Now we are going to see line by line question over here. Understood? I am going to write some questions and we will see it very properly. Suppose first question I have written that we have CH double bond CH and here Cl in presence of Na and dry ether. Sir, this is the Urj reaction you are talking. Yes, this will go, dot will come and you are getting CH triple bond CH. But in presence of this Cl, I have taken CH double bond CH, COONA, and I have used soda lime decarboxylation NaOH plus CaO. So in this part what is happening? This will go, minus will come, this will go, minus will come, and this minus will take hydrogen, this minus will take hydrogen. So it will become CH2 double bond CH2. Understanding? It means bond will not increase, hydrogen will come. Same thing happening na. Hydrogen is coming na 2 minus. The 2 minus, that 2 minus both will get hydrogen. Understanding everyone? Suppose C part. I have taken CH2Cl and CH2Cl and I am using over here NaZn heat. What I will do? Free radical CH2 double bond CH2. But in soda lime decarboxylation, Cl is there, but over here COONA, CH2 COONA will come. Cl will not come. So you have to see what is the reactant according to that. And arrow they will write NaOH plus CaO. What will happen? This will go, minus will come, this will go, minus will come, this minus will take hydrogen, this minus will take hydrogen, and you are getting CH3. Understanding what I am trying to say? Ha sir, understanding. Suppose D part, E part. I have taken benzene ring and over here COONA, over here COONA, over here COONA. What you will say? Ki sir, this will go, minus will come, this will go, minus will come, this will go, minus will come, and each and every place will take hydrogen, and in bond line structure no need to represent hydrogen. So this is soda lime decarboxylation. Understanding? Over here, it means whenever you are seeing soda lime decarboxylation, anything you can prepare. How? If you will take CH3COONA, FG. If you will take CH3CH2COONA. Acha, GH. If you will take CH3CH2CH2COONA. What you are doing? Every time CONA removing, and in every place you are using the one reagent, that is NaOH plus CaO. First is giving us CH4, one extra hydrogen coming. Second is giving CH3, CH2, CH2 will become CH3. This is coming CH3, CH2, CH2 will become CH3. This is happening na, minus, this minus. It means CONA you are removing. So what you will say? Over here you are able to prepare, you are able to prepare odd number of carbon as well as even number of carbon as well as CH4. See, first reaction you are getting CH4. Second reaction you are getting even number. Third reaction you are getting odd number. It means what you will take before CONA, everything after removing CONA, you will get the final product. It means the soda lime decarboxylation has sorted out two problems. One problem CH4, another problem odd number of carbon. Both problem has been sorted out. Two problem coming, both problem has been sorted out by soda lime decarboxylation. They are important points. You will see it once again. Example you will see, and everything is going to be clear. Understood the point? Now, after that, once the soda lime decarboxylation completed, suppose they will give us one question. Now, in this question, they are asking which of the following will give more rate soda lime decarboxylation. What you will say? Sir, here it will break, became minus. Here it will break, became minus. Here it will break, became minus. This minus is on triple bond. This minus is on double bond. This minus is on single bond. And we know that triple bond is sp, double bond is sp2, single bond is sp3. So it has rate. Negative charge is more electron. Negative charge is more stable on more electronegative atom. So C has more rate than B than A. Understood? Why? Because soda lime bicarbonate. And what is the product coming if you will use NaOH plus CaO? It will become CS3, CH3. Over here, same NaOH CaO, sir, CH2, double bond, one hydrogen will come, CH2. It will become same, sir, reagent, CH, triple bond, CH, one hydrogen coming, CO2, Na2, CO3 will go outside. Understood the point? So this is all about soda lime decarboxylation. Now, understood point, everyone? First, I have dictated hydrocarbon. After dictating hydrocarbon, I have dictated you hydrocarbon. I have dictated you free radical mechanism. After dictating free radical, I have taken those reaction that will use free radical Urge reaction. After taking Urge reaction, we got two problem. That CH4 not prepare, odd number not prepare. Then I have sorted out that two problem with soda lime decarboxylation. In soda lime decarboxylation, what is the reagent you are using? RCOONA. What you are using the reagent? RCOONA. We are gone. Here you are using what is the reagent? RCONA. Now one more reaction is there who will use RCOONA. So I am going to complete that reaction after that. Not getting confused? Understood? Sir, listen. What I am saying, first I have dictated you free radical. After dictating free radical, I have dictated you Urge family. Because Urge family will follow free radical. After Urge family, we have got two problem and we are sorting it out. After sorting out the problem, we have seen कि whatever be the substrate or reactant you are using in the case of soda lime decarboxylation, same reagent we will use in Kolbe electrolysis. So I am going to study that topic, Kolbe's electrolysis. And two Kolbe reaction is there. Electrolysis. Two Kolbe reaction. One coming Kolbe reaction that I will teach you in alcohol, phenol and ether. And one is coming Kolbe electrolysis. Both are different. If they will ask Kolbe electrolysis, that is different. Kolbe reaction, that is different. So see electrolysis written or reaction written. Why I am teaching you Kolbe electrolysis? Because first important point, it will follow free radical mechanism. First important point, because we have started this topic according to free radical only. Urge family, free radical, but suddenly problem came, then I will go with soda lime decarboxylation. But again, I told you I will return back to free radical. And second important point, over here the reactant you can say, or substrate you can say, both we are using as RCOONA. It means over here also we are using, but we are using sodium salt of carboxylic acid. It means whatever be the reagent we are using in soda lime decarboxylation, same reagent, and we are studying free radical, so we will follow both, and we are doing it so that our rhythm will not break. We will go line by line and we will understood each and everything. Understanding what I am trying to say. So don't get confused. I will make this topic very easy if you will understood and try to know what I am trying to say this. Now, in 10th class, you have studied about electrolysis. What you are doing, you have taken one water container. In that water container, you have made two hole. In that two hole, you have fixed rubber stopper. In that rubber stopper, you have put one electrode and you have put inverted tube. Connected this with one battery. Faraday electrolysis of water. That test tube, one test tube will contain this will contain water. You will put few drop of H2SO4. Then both test tube will get bubbles. And if you will put burning candle, if burning candle will comes as a pop-up sound, hydrogen gas. If burning candle will not coming as a pop-up sound, oxygen gas. That you have studied, na? Ha, sir, we have studied that. It means over there in electrolysis, what you are using? Electricity you are using. After using electricity, second thing, what you are getting? You are getting one anion and one cation. Hydrogen plus, it will go on anion, cation, and oxygen minus, it will go on anion. Means electrolysis means electricity. It means, understood, don't get confused. Why I have teaching you Kolbe electrolysis? Because first we have started free radical mechanism and we are studying free radical. So I am continuing this free radical after soda lime decarboxylation. Soda lime decarboxylation, why you have taught? Because in free radical of Urge family we are not able to prepare CH4 and odd, so soda lime has sorted out that. After that, why you are teaching Kolbe? Because I want to return back to free radical mechanism, as well as same reactant we are using in the case of soda lime and same reactant we are using in the case of Kolbe electrolysis. Now, whenever I am writing electrolysis, means electricity will use. If electricity will use, when someone is anode, someone will cathode, anion will go to anode, cation will go to cathode, means you know that whenever any place I am writing anode, it means it is positive. If I am writing cathode, it means it is negative. If I am writing cation, it means it is positive. Whenever I am writing anion, it means it is negative. Cation, anode positive, anion negative. Cathode negative, cation positive. So if I will do electrolysis, so some cation will form, some anion will form, and cation will go to which part? Positive will go to negative. It means cation will go to cathode and anion will go to anode. Why I am studying this? Because we know that electrolysis, and in electrolysis some cation, cathode, anion, anode will be there. So cation C will go to C, and cation will go to cathode and anion will go to anode, because cation is positive and cathode is negative. The positive will go to negative, anion is negative, anode is positive, the negative will go to positive. Understood this part? In this part, what is the reactant you are using? CH3CO and matlab RCO and a sodium salt of carboxylic acid. Achha. What happens? Understood now. First of all, we will come at anode. Electrolysis is there, means anode cathode must be there. Now, first I am taking the topic anode. In anode, what happens? First I have taken RCOONA, so O minus. What we have? RCOONA, so we know that RC double bond O, Na minus plus, so I have taken RCOONA. Now, what will happen here? Understood the point very properly. This part they will do free radical. This part they will do free radical. Now after doing free radical, it will get one electron, and after getting it, R will become dot. Understood the point very properly. And carbon dioxide is going outside. What is like that? How it is happening, sir? Just wait. I will dictate you. Don't worry about it. What happens? This will come here. It is forming this, and it will take one electron. How? Not like this. Understood what I am saying? This is total carbon dioxide. It will go outside. More electronegative. This will do resonance. What happens? From here, carbon dioxide will go outside, and it will become plus. Someone will give him one electron over here, and it will become R dot. Main important point ki what is forming? R dot. First important point over here, ki reactant is sodium salt of carboxylic acid. Second important point is that anion will go to anode, cation will go to cathode. What happens at anode? Anode needs negative charge, and carbon dioxide has negative charge. Carbon dioxide has negative charge. So this reaction happens at anode. Now carbon dioxide will go, R dot is coming. R dot, if it is 1 degree and 2 degree, it will do combination, because dot. Same thing not happens in the case of soda lime, because over there no dot. Over there minus sign is there. It is possible only for dot. And if it is 3 degree, it will do disproportion. I will do some questions also, don't worry. Disproportion. Now at cathode what happens? Anode to done. Acha sir. At cathode, what is the reaction happening, sir? So at cathode what happens? Ki water is there. You are doing this reaction in presence of water. So what will happen? Because electrolysis, name is only electrolysis. Electrolysis you are doing electricity they giving, but water also there. Electrolysis means addition of water also. What happens? Over here OH minus will go, H plus will come, and it will form half H2. Why? Only one hydrogen is there, that will form half mole of H2, and Na plus coming from here na, that will react with OH minus, means what you will say. First important point, understood what is happening over here. At anode, carbon dioxide and free radical is forming. Carbon dioxide will be as it is, free radical will be converting 1 degree, 2 degree combination and 3 degree disproportion. And at cathode, which gas is coming? Hydrogen gas is coming. It means I am going to write each and everything very properly as an important point. See it once, fast. Seen this? Sir, seen. Little bit. Understood, sir. It means at anode, carbon dioxide and free radical, and at cathode, half H2O coming, hydrogen gas is coming. Now I am going to write slowly the important point. Just understood. Some important points of Kolbe electrolysis. Then I will do questions and I will make you confident on that also. Don't worry. Some important points. What are the important points, sir? See, everyone. First, which mechanism we will follow? Sir, we are following over here. First point, we are following free radical mechanism. First important point is free radical mechanism. Second important point, which gas is released as carbon dioxide? Which gas is released as anode? Sir, this point I never forgot. Carbon dioxide gas evolve at anode. How you will check this gas is carbon dioxide? They will passes through lime water. What is the formula for lime water? Lime water is also called, class 10th we have studied this, everyone, slacked lime. Slacked lime formula is CaOH whole twice. When you will pass carbon dioxide with this, it will form CaCO3. And if you will pass more excess carbon dioxide and water, it will form CaHCO3 whole twice, and that is insoluble in water. Means what I am dictating, I will go back. Carbon dioxide gas evolve at anode, passes through lime water, turns lime water into milky white. And you have studied in class 10th. Lime water convert to milky white in the presence of carbon dioxide. So at second point, carbon dioxide gas is evolved at anode. And one more point you will understood कि whenever you have carbon number 1 to carbon number 4 like CH4, C2H6, C3H8, C4H10, these four there na, these are gases. These are gaseous in nature. But if you will have 5 carbon to 17 carbon alkane, then this is liquid in nature. And whenever you have 17 to so on, all the carbon are solid in nature. So you can write the carbon dioxide gases evolve at anode, as well as if this carbon is one carbon CH3 dot or C2H6 dot, we will do combination. Suppose over here CH3 dot, it will form CH3. After doing combination, it will form 2 carbon, and this is also gas. So there is a chance that another gas will also produced over here. Carbon dioxide to coming, if the carbon is 1 to 4, it means third important point, the alkane formed may be gas at anode. If it is C3H8 or C4H10 or C2H6, anything is there. What are the things formed? Sir, over here again combined free radical, so CH4 to not coming as a gas. Sir, it may be that double carbon will come, CH3 come. Acha sir, CH3, CH2, CH3, that will also not come. But there is a chance कि CH3, CH2, CH2, CH3 because free radical is always giving even number of carbon. So there is a chance that C2H6 as a gas will come at anode or C4H10 will come as a gas as anode, but carbon dioxide to always releasing. So the alkane may be gas at anode, not gas, no problem, but up to 4 carbon there is a chance of gas. Fourth important point, which gas is released at cathode? So you will say, sir, H2 gas evolve at cathode. They are asking the question like this, which gas is released at anode, which gas is released as cathode. Acha. Fifth important point, whenever you are doing the reaction, what you are getting over here, see, at last you are getting NaOH. And if you will see the solution is basic or acidic? Sir, basic. Yani overall solution is basic in nature because NaOH is coming in the last. If overall solution is basic, then pH is increasing or decreasing? Sir, increasing because pH 1, 2, 3, 4, 5, 6 is acidic, 7 is neutral, 8, 9, 10 to basic, to 8, 9, 10, 11, 12, 13, 14 coming and pH increasing. Seventh important point कि sir, soda lime decarboxylation has helped us to prepare odd number as well as CH4, but over here again we are not able to prepare. CH4 cannot be prepared. Same problem as we have got in Urge family, and also odd number of carbon cannot be prepared. Odd number of carbon cannot be prepared. But why you have taught this, sir? Because just now we have completed the soda lime same reactant. So I have taken second important point कि sir, same reactant as well as free radical, and we are continuing free radical mechanism. So I hope slowly you are understanding hydrocarbon and not feeling bored. Now we are going to see some questions on this basis. If we will see some questions over here, what we will get? Sir, over here Kolbe electrolysis means free radical. Free radical means 1 degree combination. Acha, soda lime decarboxylation, no, carbo anion minus. It means what it will form? It will form CH4 methane. Over here Kolbe electrolysis, free radical, CH3 double bond. I have written over here more CH, H is 2 only. H is 2 only. Don't get confused if I am writing my mistake, but I will try not to write. So what it will get? CH2 double bond CH2. But if it is soda lime decarboxylation, CH3 single bond CH3, because minus is coming and minus will take hydrogen. Kolbe electrolysis dot CH triple bond CH. But soda lime CH2 double bond CH2. Over here we can't use soda lime because soda lime at least one to needed na hydrogen carbo anion to form na. So over here NaOH plus CaO you can't use, but Kolbe you will use. What you will get? You will get hydrogen gas at cathode and carbon dioxide gas at anode. No alkane is formed. No alkane is formed, only carbon dioxide and hydrogen gas. Acha, in Kolbe electrolysis instead of CONA, sometime if SO3Na given also, don't get confused. Over here again you will get the same thing. Free radical will do CH3 single bond CH3 combination reaction. Over here it will break free radical, Kolbe electrolysis CH3 soda lime CH4. Understanding na? Not getting confused na? Acha sir. The question is done. Understood now? So see, first we have seen free radical. After seeing free radical, we have seen some questions on this basis. Then we have seen the free radical reaction, and that is Urge family. After seeing the Urge family, we are getting two problem, and to sort out that two problem, we have seen soda lime decarboxylation. After that, same type of reactant coming in soda lime decarboxylation as Kolbe electrolysis. So we have seen Kolbe electrolysis. Now, one problem we have solved already. One problem is odd number of carbon cannot be prepared in Urge family. Odd number of carbon is not prepared in Urge family and Kolbe electrolysis. But this problem has been sort out by first soda lime decarboxylation, soda lime decarboxylation. But there is one more reaction that will sort out this problem, so we have to study that reaction also, and that is called Core-House reaction. So we are going to, this problem has been sorted out by the another reagent, another reaction that is known as Core-House reaction. So we will study that. Means problem of getting odd number of carbon has been sorted out by soda lime decarboxylation, but one more reaction is there, they will sort out this problem also. So we will study that problem also. Understood how correlating, see, learning to there, but if you will correlate the topic slowly, you will understood each and everything regarding hydrocarbon, and it will become very easy. Once you will understood hydrocarbon, one shot 4 to 5 hour, how many hour I didn't know. After that I will give lots of JEE mains advanced question one topic, and I will dictate that. Don't worry about anything. Understood? Now we will have Core-House reaction. What we will have? Core-House reaction. Why? Logic understood, reason understood? Sir, because odd number of carbon you have sorted out the problem with soda lime decarboxylation. But you know that in this world lots of people is there to sort out the problem. Like that, I am here for you to sort out your problem. How much I am sorting out your problem, that I didn't know, but I am trying from my side. Some other is also trying. Lots of videos are there, you can watch. It may be that video looking much better than me, but trust me, on content purpose I can't give guarantee, because more talented teacher are there rather than me. But I am trying to make the topic funny and easy. Funny not in the sense of became joker in the class. Funny in the sense I will try to dictate you. Understood? First important point, see. First I will teach you Urge family. In that, free radical. Then Kolbe electrolysis, free radical. Soda lime, NaOH plus CaO, carboanion. And Core-House, also carboanion. It means two free radical reaction you have studied, Urge family and Kolbe electrolysis, and two carboanion reaction, that is Core-House and soda lime decarboxylation. And both reaction is used to sort out the problem of odd number of alkane, but soda lime is also used to sort out the problem of preparation of methane also. So over here what you will say, in this reaction the intermediate is also carboanion. If intermediate is carboanion, I will write the story after that. First see what is the reaction over here. First you have to take alkyl halide, and that alkyl halide, first reagent you have to react with lithium. Second reactant you have to react with copper halide. Copper halide. And third reagent you have to take as R-X, some other R-X. What will happen? It will give R. How? I will dictate you. It means what is happening over here, this R and this are combining together and form one product. Now I will see what is happening in this reaction. But important point, R and R dash will not be aryl compound. Any benzene compound is not there. That you have to learn definitely. R and R dash will always be alkyl only. Don't use any benzene ring over here. Not alkyl only we will use. Now see. What you have written the reaction we have to learn as it is. Yes. Now see the mechanism. What is mechanism means? Suppose you are eating the food, and now some food will give you vitamin, protein, carbohydrate. But I will tell you what is the how your digestive system will work and how it is doing to be happen inside the body. So that mechanism. First mechanism, what happens? You will take 2 mole of alkyl halide and you are reacting this with lithium. 2 mole of alkyl halide reacting with lithium. What happens? 1 mole of alkyl will form lithium alkyl and 1 mole of lithium will form LiX. After that, again you have to take 2 mole of RLi and you have to react that with Cu copper halide, CuX. What happens? It is forming a compound like this, R, Cu minus and R. If you will write this compound very properly, what you will get? R2CuLi, R2CuLi, and this reagent is known as Gilman's reagent. It means while doing the Corey-House reaction, in the intermediate we are getting one other scientist reagent that is known as Gilman's reagent. Then you will take this R2CuLi and react with R-X, and from this R and R dash will come. This is the mechanism happening inside it. First important point, carbanion, and whatever be the R and R dash, that will form. Understood? No problem in that. Now, a problem is there, see once again. Something is very fixed that you have to know. Now, over here we will going to write stereochemistry. If I will write important point someplace stereochemistry, both have the same meaning. Don't get confused, ki sir you are not written stereochemistry there. If I will remind, I will write stereochemistry or important point. Both have the same meaning in the chemistry part of organic chemistry. First important point, what is the intermediate? Sir, intermediate is carbanion. I have written in the first part. It means second important point, rate is directly proportional to stability of carbanion. Acha sir. Third important point, in this reaction Corey-House, we are getting one more important reagent, that is Gilman reagent, R2CuLi. So in this reaction of Corey-House, we are getting one important reagent. And what is that important reagent? Gilman's reagent in the between. And what is their formula? Sir, their formula is R2CuLi. We are getting one important reagent, and that reagent is Gilman's reagent. Again, over here you are not able to prepare CH4. CH4 cannot be prepared. Again, I will write some example. Don't worry about that. Now, fifth number, in this part you are able to form even, that is symmetrical, or odd, that is unsymmetrical. Both product can be obtained. In this part, both product can be obtained. Now we are going to see some questions. Then Corey-House also moe. Now we will see the question, not that much to worry. See, over here what is R? Over there what is R? Combine that. CS3, CS3. Leave other things. Over here what is R? Over here what is R? Combine that. CS3, CH2, CH3. Over here what is R? What is over here R? Combine that. CS3, CH2, CH2. After that CH2, CH3. Over here you are able to produce even number of carbon, odd number of carbon, 1, 2, 3, 4, 5, odd number of carbon, yani even and odd both will form. Over here you can't take HX, because in the reaction only I have written what? RX you have to take, and here also you have to take RX. So H not coming. Suppose someone will say, sir, RX over here, CH3S over here, it will combine and forming CH4, but the problem is that we are not able to take this. Understanding the point? So this is not a valid point. So again we are not able to produce CH4. What we are not able to produce? CH4. Same thing I have written. And CH4 how we will produce? By using bolo bhai, say soda lime decarboxylation. Yes, it means up to now whatever the reaction we have studied, in that odd number of carbon can be prepared by soda lime as well as Corey-House reaction. Even number of carbon can be prepared by Urge family and Kolbe electrolysis. Urge family and Kolbe electrolysis follow free radical mechanism. And soda lime decarboxylation and Corey-House reaction follow carbanion stability. Carbanion intermediate is carbanion. Soda lime decarboxylation will give CH4 as well as only one reaction over here we have studied that will give CH4 as well as odd number of carbon and even number of carbon. But Corey-House will give odd even, but CH4 it will not give. Understanding what is happening now. After this we have to study Grignard reagent. What we have to study? Grignard's reagent. And Grignard reagents, in this chapter I have dictated you each and everything very detailing in one video. If you will need, you will go to the channel and you will see Grignard reagent thumbnail. If you will say, sir, not getting, just now I have made only 10 videos, 11 videos, 12 videos. It is not possible to not get in the playlist or in the video section. You will get Grignard reagent and that you will see. But right now I am going to write some questions on Grignard reagent. What is Grignard reagent? What is the reaction? I will not dictate because that individual video I have already made. So I will waste the time. Understood the point? So I will write some questions over there. Now we will see the Grignard reagent reaction. Over here I have already dictated you कि RMgX is the Grignard reagent. Active hydrogen needed. So hydrogen will come, you know that it will break from here, it will become minus, it will become plus, it will give H plus, it will also give H plus. How? You will see in Grignard reagent and you will be able to understood. Over here you will get RH, over here also 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 you will get RH, but over here R and CH3. Over here H not coming, this will come CH3 plus. All the time, if CH3 alkane is not there, SH, COH, Nakuns, QHX I have dictated in the case of Grignard reagent. Please see. Everyone will see the Grignard reagent video because every chapter has Grignard reagent and I don't want to dictate every time Grignard reagent. And over here, this will become plus and it will become R, CH2, CH3. So this is all about Grignard reagent. A question I have written, how you are judging which one is give H or no. For that I have given the trick Nakuns QHX. Now, I personally believe I have already made the video of 1 hour 41 minutes and I am making this video on iPad. Problem is that if I will not upload this video to already 1 hour 41 minutes, it may be that video will getting disrupted or something bad, so I will have to cry. So I will stop over here. Tomorrow I will dictate you the remaining part of the hydrocarbon, means max to max 3 video I will complete all the things, but I hope up to now what I have dictated is very interesting and very good for you all. Please see it once again. If any confusion you can ask. Bye. Have a nice evening. Enjoy. Take care. Stay home. Stay safe. Hello students. Very good evening, good morning, good afternoon, whenever you are watching this video. Now, in the last class we have seen hydrocarbon part 1. Now this is our part 2. Now in the first class I have told you that I will try to complete hydrocarbon in one video, but after seeing that time is going to be 1 hour 42 minutes, so I have stopped that video in part 1. Now we are going to see the next part of the hydrocarbon, and again I am suggesting those who have not watched the first part, please leave this video. No use. Don't increase my views. I didn't need it. Just leave this video, no use of that. Now, next part I am going to see in hydrocarbon halogenation. Hydrogenation. Next part we are going to see is hydrogenation. What is hydrogenation? Up to Grignard reagent I have completed in the last class. Now we are going to see the next part of the topic, that is called hydrogenation. Hydrogenation means addition of hydrogen. And again I am saying, those who have not seen the first part, no need to see it, please. You will not get anything. It will become boring. Acha, addition of hydrogen. Where you will add hydrogen? In alkene as well as in alkyne. Means, just see it very properly. Topic is going to be very easy. Addition of hydrogen in alkene and alkyne. We have to add hydrogen in the case of alkene and alkyne. In this hydrogenation topic, we will use the reagent. What we will use? Reagent, and that reagent we will use hydrogen in presence of either nickel or platinum, palladium or platinum. We will take hydrogen in presence of nickel, platinum and palladium. If they will ask in which case the reaction will happen faster, rate will be faster, means addition of hydrogen rate will be faster in which case? So hydrogen in presence of platinum has more, then hydrogen in presence of palladium, then hydrogen in presence of nickel. Now see what is happening in this case now. Suppose you have taken one plate or something, you have taken bed sheet or bed. On that bed is made up of platinum, palladium or nickel. On that bed you will add hydrogen. What you will do? Suppose there is a plate. I will dictate you. This plate has, like that plate is there. Now on that plate you have put hydrogen, lots of hydrogen molecules you have put it. And over here you will take alkene or put it over there. What will happen? Hydrogen from here attach here. Or you will take the plate. You will take the plate over here, and on that plate you will put hydrogen molecules, and this is red color is hydrogen molecules and blue color is plates, plate or bed sheet, anything. And over here you have taken triple bond and you will try to attack hydrogen. So over here how many moles of hydrogen? 4 hydrogen will attack. Over here 2 hydrogen will attack. This is known as hydrogenation. Now you are putting this, what you are doing? You are putting the alkene or alkyne in front of the plate. That plate has distributed lots of hydrogen. So it will attack from the same side or opposite side? Same side. So hydrogenation is syn addition. Sir. Not understood. Again. I am saying that hydrogenation means addition of hydrogen in alkene and alkyne. Reagent we will use H2, nickel, platinum, palladium catalyst. In that H2 platinum is more than Panditayan Patna ki H2 platinum, then H2 palladium, then H2 nickel. This is the rate faster. What is the hydrogenation process basically? I have taken one bed sheet or I have taken one bed over here like this. This is our bed of either made up of platinum or nickel or palladium. On that bed I will put little bit amount of hydrogen and I will take the CH2 over there in front of them. Then whatever be the hydrogen they will attack over here. Over here how many hydrogen will attack? 2 hydrogen to make double bond as a single bond. Over here how many hydrogen will attack? 4 hydrogen to make a triple bond as a single bond. So it will attack on the same side, or this hydrogen will do a rotation and it will attack from this side? No sir. So on the same side attacking is known as syn addition. Understood the point? Yes sir. Now over here we know that कि alkene and alkyne cannot be formed by one carbon. So what you will say? कि in this reaction CH4 is still not formed. It means up to now which reaction is forming CH4? Only one reaction is forming CH4 and the name of the reaction is soda lime decarboxylation. Remaining Grignard reagent also forming. After that slowly you have already seen the previous part. So up to now you have understood what is the reagent we are using. What is the reactant we will use? Alkene or alkyne. And why it is known as syn addition? Because it is attacking it is attacking on the same position, and this process, hydrogenation process, is known as adsorption. What do you mean by adsorption? Suppose I will put water on the cloth. What it will do? It will absorb. Water will go inside the cloth. But if I will put surf on the cloth, what it will do? It will stick to the surface. So adsorption is this over here. What is happens? It is happening adsorption. Adsorption means sticking to the surface. Adsorption means sticking to surface, and it is doing syn addition. Which addition? Syn addition it is doing. So I hope everyone has understood up to now what I am trying to dictate. Once you will see this part, then we will proceed further. So we have seen hydrogenation is a syn addition, sticking of hydrogen to the surface of alkene and alkyne. Reagent used is nickel, platinum catalyst in presence of hydrogen with the help of alkene and alkyne. Now see, what I am going to do? First, I will take CH2 double bond CH2. And now I will react this with H2 in presence of nickel, either platinum or palladium catalyst. How many moles of H2 I have to take? Sir, only 1 mole, because 1 mole of H2 will give 2 hydrogen and they will need only 2 hydrogen. So what you will get? CH2 single bond CH2, 1 hydrogen will come here, 1 hydrogen will come here. This can also be written as CH3 CH3. This is known as hydrogenation process. Suppose I will take another example, CH triple bond CH, CH triple bond CH, and I will react with H2 in presence of nickel, platinum or palladium catalyst. Over there, how many moles we have to take? Sir, 2 moles. If it is given 2 moles also okay, not given also don't get panic. You will have to understood it is 2 mole. What will happen? CH single bond CH, 1 hydrogen here, 1 hydrogen here, 1 hydrogen here on the same side. It can be also written as CH3 CH3, and this is hydrogenation process. But someone will say, sir, I want to convert alkene into alkane. This is okay, but I don't want to convert alkyne into alkane. I want to convert alkyne into alkene. What I will do? So understood, means someone is asking me this question, sir, how to convert alkyne to just alkene. In every part, first part and second part, we are converting alkene. This is alkene, and after alkene it is converted to alkane. In the second part it is alkyne, and it is also converted to alkane. Someone will say, no, I want to convert alkyne into alkane. No, alkyne into alkene I want to convert, not alkane. What I will do? So we have to change the reagent little bit. What is the change in the reagent? We have to take reagent used over here for this process is called, either you will take PD in presence of BaSO4, and that will be poisoned by sulfur, or sulfur like that, a star written, or poisoned by quinoline. Quinoline has a structure like this. Nitrogen over here, this ring. Sir, what will happen if I will do this reagent? So whenever you will take alkyne, CH triple bond CH, and you will take hydrogen in presence of PD, BaSO4 poisoned by sulfur like that written, or quinoline structure given, so it will take only 1 hydrogen over here, and it will become alkene, that is CH2 double bond CH2. It means alkene to always converted into alkane, but alkyne is converted into alkene. Sir, what is the reason behind it? What is the use of this reagent? Whenever you are taking platinum or palladium catalyst, that plate, this is made up of platinum, palladium or nickel catalyst. In that situation, plate size does not any holes and all hydrogen is present over here. But whenever you are taking PD in presence of BaSO4, their plates has little bit holes. Their plates has little bit holes. This is made up of PD, BaSO4, and then whenever you are putting hydrogen over here, what happens? Some hydrogen will stuck in the holes. So whenever you are taking CH triple bond CH, only one hydrogen will come here. 2 hydrogen is not coming. So overall, you have to know hydrogenation is a syn process, syn addition of hydrogen into alkene and alkyne. Reagent used is H2 in presence of nickel, platinum or palladium catalyst. The rate will be more in platinum, then palladium, then nickel. Over here both are adsorption process sticking to the surface. Syn addition, CH4 is still not formed in this case. Alkene or alkyne both is converted into alkane, but if we will have to convert alkyne into alkene, then we have to use one reagent, and the name of that reagent is PDBS4 in presence of poisoned by sulfur or poisoned by quinoline, and the name of this reagent is known as Lindlar's reagent. The scientists, those who have given this reagent, their name is Lindlar's, and on his respect, this reagent is known as Lindlar's reagent. So I hope you understood hydrogenation of alkane. Over here also syn addition. Every place syn addition and every place adsorption. Adsorption means sticking to the surface. And as I have told you, if you have any confusion, you can ask me on 9267 9377 18 is my WhatsApp number, or don't call. Calling is not allowed. And when I will come to the college, over there also you can ask if you have a confusion. So I hope you understood this, all the things about this part. Now I am going to dictate to you one that important topic that you will write very important. What is very important? Something I am going to teach you, and that topic name is stereochemistry. And that topic is very important. What I am just see up to now, hydrogenation understood? Ha sir, understood. Whenever we will take H2, PT, PD, Ni in presence of alkene, alkyne, both will convert it into alkane. And whenever I will take PDBS4 poisoned by sulfur or quinoline, alkene converted to alkane, but alkyne converted to alkene only, not alkane. Okay sir, I understood this. Now one thing I am going to write, and that topic name is stereochemistry. And I have told you, whenever I am writing important point in chemistry, it is known as stereochemistry of whole hydrocarbon. Whole hydrocarbon. This is not for hydrogenation. Sir, what you are writing, I am not getting it. Just wait, I will make you understood. Now, whenever I will do any topic I will do, any chapter I will complete. Suppose I have completed over here, and the name of the chapter is called hydrogenation. In hydrogenation, what I have written? Hydrogenation is a process. That process will do syn addition. Syn addition. Like that, whenever I will teach you any topic, I will write before that it will do syn addition or anti addition. Syn addition means same side, anti addition means left side, means opposite side. For that I am going to give you stereochemistry of hydrocarbon. What do you mean by that? Just see once, you will understood it. Suppose I will write over here types of alkene. After writing types of alkene, I am going to write types of addition, and then I am going to write types of reaction. Means, suppose someone will always say, we know that there are two types of alkene. One is known as, this design is cis and this design is trans. Means C double bond C, same side CH3, H and H. This is known as cis. C double bond C, CH3, H and H is trans. This is their bond line structure upside. So what I am trying to say in this part, try to understand it very properly. Suppose alkene will be given either cis, or alkene will be given cis, or alkene will be given trans, or alkene will be given trans. Two times why I am writing, I will dictate that. Whenever cis given, consider cis as positive, trans as negative, and any addition, type of addition like that, hydrogenation is doing what? Hydrogenation is doing syn addition. Similarly, every reaction that is fixed. So similarly, some reaction will do syn, some reaction will do anti, some reaction will do syn, some reaction will do anti. Now, if cis and trans is not given, suppose for hydrogenation cis and trans is not given, then always do syn. But if cis given, so take syn as positive, anti as negative, syn as positive, anti as negative. Now positive and positive, what it will become? Positive. so it will become syn addition. Positive and negative, it will become what? Negative, so it will do anti addition. Negative and positive will become negative, it will do anti addition. And negative will become positive, it will do syn addition. Means for a reaction, syn and anti is fixed. Like for hydrogenation, syn is fixed. You can't change, it will become anti or this. But cis and trans you can change. Means again. Suppose I will say, I have taken one structure over here, alkene, and I am reacting that alkene in place of hydrogen. We know that hydrogen has three isotopes. One is called hydrogen, protium, deuterium and tritium. These are the isotopes of hydrogen. Isotopes of hydrogen. So in place of hydrogen, I will take D2. And I am saying it will nickel, platinum or palladium catalyst. And same situation, I have taken another example of trans. This is our trans. And I am reacting that trans also with D2. In presence of H2, I have taken D2. So you are able to visualize कि syn anti happens, how happens. Palladium. Now what you will say, once you will see it, you are 100% sure कि sir, this is hydrogenation, it will do syn. This is hydrogenation, it will do syn. Because for hydrogenation, syn is fixed, syn is fixed. But this structure is cis. Cis will become positive. This structure is trans. Trans will become negative. It means in the first case, this is CS3. The first I am writing over here CS3. Then over here we have one carbon. After that another carbon. This carbon and this carbon. After that again we have CS3. Now see over here. In this carbon and in this carbon, three hydrogen I have put. In this carbon only one hydrogen, so I will put one hydrogen. In this carbon only one hydrogen, so I will put hydrogen. D2 will come either both this side and hydrogen will come here, or CS3, understood what I am saying? CS3, H will come here and D will come here. Means again understood the point. Both are same, identical structure. Both are identical structure. How, sir? I have dictated you what is identical in a structure. Identical structure are those structure which will form a mirror image, but they will not show optical isomerism. It has a plane of symmetry, and because of plane of symmetry, it has this chiral center, this chiral center. So this is a meso compound. Meso compound is those compound those who have two chiral center and plane of symmetry. So this is this is optically inactive compound, and mirror image of optically inactive compound. Mirror image of optically inactive compound is always a identical compound, and that can also written as homomers. Don't worry, if I have not completed GOC, I will complete that. Means what I am trying to say, either you will draw this or you will draw this. No need to draw all. So I am cutting this. I am not cutting here, but I am just cutting it. No need to draw this part. Only one you will draw. This is called syn addition. Why syn addition? Because plus and plus will become plus. But if you will see the second question, I am erasing it because space has been filled, and I am writing again. If you will see the second question, what you are seeing in the second question? Sir, in the second question, this is trans. And then you are taking on the arrow D2 in presence of nickel, platinum or platinum catalyst. You know that this is the fixed, sir. This is hydrogenation. Hydrogenation is always fixed, positive, syn addition. Similarly, other reaction will be anti, that is fixed. But over here, syn is fixed. But this is trans, and trans is negative. And negative and positive will form negative. It means this is CS3, this is CS3, right? Upside CS3, downside CS3. One place you will add hydrogen and deuterium this side, so one place this side. It means one time deuterium will come this side, the other time deuterium will come on the opposite side. This is known as anti-addition. Two deuterium has been added on the two different sides. Now, if you will make their mirror image is coming CH3 over here also CH3, over here D will become H, over here D, over here H, over here D. What you will say in this case? You will say in this case that this compound is also optically active. No plane of symmetry, no center of symmetry, nothing is there. It means this compound is also optically active and this compound is also optically active. So these two are optically active compound. Mirror image are optically active compound. Mirror image are enantiomers. Enantiomers, and enantiomers pair will form racemic mixture. So both racemic mixture, combination of both the two compound is optically inactive compound. It means whenever they will give you this question, their answer will be only one, and whenever they will give you this question, their answer will be two. One answer will be this and another answer will be the mirror image. But over here you can't draw the mirror image. Understood the stereochemistry what I am trying to say? It means hydrogenation is fixed sin, but cis and trans to change na. So according to that, sin will also become anti like that. Understood? Similarly, some reaction I will write over there, I will show it will do anti. So according to that, you will cis and trans, you will transfer it. I hope you understand this. Seriously say. Any confusion? No sir? Okay. So this is our part 2. I hope you understood up to now. Please see it very properly. Now I am going to dictate you the next part, and don't worry about JEE mains questions. I will do in the class or I will upload on the video, but first I will do in the class also. Those who need, I will upload on the video also. So I hope everyone has understood this part very clearly and very importantly, and this topic is known as hydrogenation. After hydrogenation, I have dictated you sin anti-hydrogenation is always sin addition, always and always. So only cis and trans will be changed. Hydrogenation will not change. Similarly, I will write other reaction. I will say it is anti. So according to that, you will judge. Understood? Ha sir. Now it is coming. Okay. This video I will stop over here. Why? Because next video it will be 1.5 hour, 2 hour. Next topic is big topic. Okay. Slow. I will complete it so you will not get panic. Yes, very good morning, very good evening, very good afternoon, whenever you are watching this. So first we have completed hydrocarbon part 1 and hydrocarbon part 2. And I hope up to that you have understood each and everything. Now we are going to see hydrocarbon part 3, and the topic name is reaction of alkane. And this topic is one of the big topic that I have to cover. But again I am saying, without completing all this hydrocarbon, don't leave, because time is very less we will have. Now, reaction of alkane. In this, first of all, we have to know the first topic. And the name of the first topic is called substitution reaction. Substitution reaction. In that substitution reaction, first we have to study halogenation reaction. After halogenation, we have to study nitration. After nitration, we have to study sulfonation. And after sulfonation, we have to study Reed's reaction. So this is the first and foremost topic of alkane, that is substitution. After completing substitution, we will go with the next part of the topic in alkane only. Substitution has that subtopic. And the second topic I will teach you, isomerization. After completing isomerization, third topic I will teach you, and the name of the topic is aromatization. After completing aromatization, fourth topic I will complete, and the name of the topic is combustion. After completing combustion, I will teach you fifth topic, that is called pyrolysis. And these are the total topic present in the reaction of alkane, in which halogenation is most important topic. If you will understood this, then remaining topic is one line, not that much big, but halogenation is one of the biggest topic in all of the topic, and halogenation belongs to substitution. Where it will belongs? Substitution. So now in this video I will try to complete all the reaction of alkane. You have seen it? Yes sir. Then next topic I will, next video, next topic, like that we will see. First we are going to start substitution reaction. In that substitution I am going to start halogenation. It means first important topic is substitution. And again I am saying, just read out and see the things very properly. Don't get nervous and confusion. Now, the reaction of alkane, substitution, halogenation we have started. These are the topic that we have to cover. In that, first I am going to start substitution. Just listen it very properly. Don't get nervous and confused. In substitution, first topic I will start halogenation. Now, halogenation, first of all, it is a substitution reaction. Halogenation is a substitution reaction. Halogenation means what? Halogenation. Hydrogenation means addition of hydrogen. Halogenation means addition of halogen. What is halogen, sir? Halogens are fluorine, F2, chlorine, Br2, bromine, I2, iodine. These are the halogen. So we are going to see the addition of halogen in halogenation of substitution method. Now, over here, what is the reagent we will use? First of all, so the reagent that we will use is X2. X2 means either F2 or Br2 or Cl2 or I2 in presence of H mu or photon or sunlight. The light of sun is known as sunlight. They will release one energy, the particle, that is called photon, and it is also denoted by H mu. So all three have the same meaning. Over here, in place of X2, you will take Cl2 in presence of H mu, photon or sunlight, or you will take Br2 in presence of H mu, photon or sunlight, or you will take I2 in presence of H mu, photon or sunlight, or you will take F2 in presence of H mu, photon or sunlight. This we have to do. Now, first reaction we are going to do. Suppose we have taken CH4 and I am trying to react with Cl2. Understood this part? Whenever any question coming, Cl2 is given excess or not given excess. Suppose Cl2 is not given excess, simply they have given Cl2 in presence of H mu. Or instead of Cl2, I will write directly X2. Any problem? When I will write X2, you are able to understand what I am trying to say. So I am writing over here X2. In X2 means Cl2, Br2, F2, I2. In presence of H mu or photon or sunlight. What is the product coming? The product is coming CH3X plus HX. But the problem is that this reaction will not stop here. It will go on continuing. Means again some X2 will be left. That X2 again react and it will become CH2 X2 plus HX. Again it will react with X2. It will form CH X3 plus HX. Again it will react with X2 and it will form CX4 plus HX. Means problem is that this reaction will do substitution. This reaction will do substitution until and unless all hydrogen will be replaced by halogen. All hydrogen will not replace by halogen. Up to that this will do the reaction. But someone will say, no sir, I have to stop the reaction over here. What I will do in that? So sir, in this case, what you have to do? You have to do this reaction in industries. This you are understood, don't get confused. First I have dictated reagent is this. Whenever you are reacting with X2 na, what happens if you will going to do this reaction in laboratory, what is the problem coming? Each and every halogen will remove all hydrogen until and unless all hydrogen will not go and all halogen will not added, this reaction is going on continuing. So from here you will write it is not an laboratorical method. It is not a laboratorical method. It is not a laboratorical method. This reaction you can't do in laboratory. It is an industrial process. It is an industrial process. What will happen in the case of industry? We have lots of machine. That machine will stop the reaction. Whenever you are doing X2 in presence of photon or sunlight, this will stop the reaction up to CS3X plus HX. Further reaction they will not allow to do. So it is an industrial process. It is not a laboratory process. If you will do laboratory, what happens? All the hydrogen will go and all the halogen will come up to this. So we will need up to this only product. So we will have to use industry. Now this reaction of halogenation, follow free radical mechanism. Which reaction it will follow? Free radical mechanism. Sir, how you know that it is free radical mechanism? So understood, whenever they will write help or helper, these all will follow free radical, means high temperature, like any place written 500 degrees Celsius, 200 degrees Celsius, some high temperature is given, you have to understood this is a free radical mechanism. If any place written electricity, so you will say it is free radical mechanism. Any place written light, like H mu, photon or sunlight, so previously it is written what? H mu, photon or sunlight, then again you will say it is a free radical mechanism. Any place written peroxide, like either it should be H2O2 or it should be C6H5CO whole twice O2 and O or O2, or any place written Kheras effect. These all are known as peroxide, or any place direct radical written. Radical written means CS3 dot, CF3 dot, any dot type of things is there, then it will do also free radical mechanism. It means these are the process by which you can judge it is doing free radical mechanism. Understood up to this? What I am dictating, nothing extra. These are the topic I am going to cover. Substitution, addition of halogen, halogenation. X2 if you will do in laboratory, it will remove all hydrogen and try to produce up to which all the halogen will not go and hydrogen will not go, halogen will not come. Up to that reaction is going on. Over here, if you have to stop this reaction, you have to go into the industry. So it is the industrial method. This reaction, how you will know that the previous reaction is doing free radical mechanism? So if this condition coming, then you will say it is the free radical mechanism. Now I am going to dictate you what is happening in free radical mechanism. How we will understood what is free radical mechanism. Understood point? Everyone understanding? Don't get confused. So I am saying na, watch once. Any confusion, I am giving each video, I am giving this number. Those who are watching this video from the beginning, 9269377718, you can WhatsApp me on this number. I will try to dictate you if any confusion is there. I am not here to become the superstar on YouTube. I am here to become the superstar in the eyes of some student, those who are studying and trying to get the marks over here. Okay, so try to see the things very properly. Any confusion you can ask on this number. Now, free radical mechanism happens in 3 steps. First step is known as chain initiation. What happens in the case of chain initiation? You have to take any x2. X2 will be like X and X, and that you have to show them the sunlight, H mu, photon or sunlight. When you will show them sunlight, H mu or photon, means it is not like that you have to do all this reaction in sunlight only. You have to just see one light to chlorine, bromine or iodine. It will do hemolytic cleavage. You know that this types of cleavage is homolytic cleavage. Due to homolytic cleavage, what you will get? X dot and X dot. This X dot is free radical, and I have already told you free radical is what? 7 electron, that is odd electron species. 1 degree, 2 degree will do combination, 3 degree will do disproportion for alkyl group. First step is chain initiation. Second step is chain propagation. Chain propagation. Chain propagation. Chain propagation, you have to understood this chain propagation is a exothermic reaction. Which types of reaction the chain propagation is? Exothermic. 3 steps this reaction will happen. What happen in the chain propagation? Suppose we have CH4 and free radical I have got X dot. What will happen? The hydrogen from here, CH, one hydrogen will do free radical, because hydrogen is more stable with chlorine or bromine or iodine instead of carbon, and because of that you will get CH3 dot, and halogen dot and hydrogen dot will form HX. Now CH3 dot is getting angry. You have taken my girlfriend, I will destroy it. It will take another X molecules, they will do their homolytic cleavage, and dot dot, one dot will coming here, CH3X plus X dot. Now this process will be in the continuous way, coming like that it will happen until and unless all the CH4 and all the X, that is chlorine, bromine, iodine, not converted to CH3X. Once it will be converted, then we have to go with the third step, and that step is known as chain termination. This is the fixed step that you have to know what is happening. Understood? Na? Chain termination means you have to check. In the first step I got X dot, in the second step X dot, and one more dot is CH3 dot. It means how many dot we have got? One dot is CH3 dot, one dot is X dot. Any confusion in that? Now what will, over here we will take CH3 dot, X dot is there. What will happen? It may be that X dot react with X dot and it is forming X2. It may be that CH3 dot react with X dot and it will form CH3X, or it may be CH3 dot react with CH3 dot and it will form CH3, that is C2H6. I've understood the point. Whenever I have written this reaction over here, whenever I have written this reaction over there, in that reaction CH4 is there, X2 is there, CH3X is there, HX is there. Any place CH3 is there? No. But whenever, understood what I am trying to say? Means I am saying that whenever you have done over here this, what you are getting? X2. Over here X2 is present in this reaction. CH3X. Over here CH3X is present. But CH3 any place present over here? Because I am doing the mechanism for this reaction only. No sir, not present. It means this CH3 is the intermediate product. That product will come in the intermediate and going outside. Sir, didn't understood it, don't worry. Now on this basis, two types of question will come. One question has been asked in NEET 2024. This question is, which of the following is the step of free radical mechanism? Which of the following is the step of free radical mechanism? First option given, chain initiation. Second option given, chain propagation. Third option given, chain termination. And fourth option given, all of the above. Which option you will take? Sir, just now we have seen chain initiation, chain propagation and chain termination. All three steps are the steps of free radical. This is the answer. Second type of question they will ask, that is JEE mains question. In that JEE mains question, what they will ask, ki suppose they will give you C4H10 plus Cl2 in presence of H mu or photon or sunlight, it is forming C4H9 Cl plus HCl. What is the intermediate of this? What is the intermediate of this reaction? So do one thing, C4H10 is there, make C4H9 another C4H9. It will become C8H18. Suppose they have given C10H22 in presence of X2H mu and they are saying C10H21X plus HX. What is the intermediate? What you will do? C10H21 bond C10H21, that is C20H42. It means if they will ask intermediate, whatever with the things over here given, over here always they will give alkane CnH2n plus 2. Over here always they will give alkane. So what you will have to do? First you have to make this alkyl plus 1 and another alkyl you have to add CnH2n plus 1. Understood the point, everyone? It means double you have to do with that after removing one hydrogen. So I hope you understood the part that is called free radical mechanism. And again I am saying, not understanding, see it the part very properly, which types of question is coming, what I am trying to dictate. Understood? See it once again. If confusion, then I will go the further and I will dictate some reactions on this basis. Now if I will write one example, suppose I have written CH4. Over here I am taking CH4, you can take anything, C2H6, C3H7, C3H8, C4H10, C5H12, anything, and I am reacting it with chlorine in presence of H mu or photon or sunlight. What you will say? Sir, it is coming CH3Cl plus HCl without any doubt. Suppose you have taken CH4 in presence of Br2, H mu, photon or sunlight. What you will say? Sir, it will come CH3Br plus HBr. Suppose I am saying I have written CH4 plus F2 in presence of H mu, photon or sunlight. Then over there you can't say ki CH3F plus HF. Nah. If you will try to do, it will become explosion. Bomb blast will happen. It means fluorine will not do free radical mechanism with alkane. It will do bomb blast. Next, if I will say ki I am taking iodine CH4 plus I2 in presence of H mu, photon or sunlight, what will happen? It will form CH3I plus HI. But in this case there is a biggest problem. What is the biggest problem? HI is very good reducing agent. What is reducing agent? If I will say LIC agent, LIC agent means those who will do the LIC of other person. The reducing agent means those who will reduce other and oxidized itself. Reducing agent means reduced other and oxidized itself. And we know that reduction is removal of hydrogen and addition of hydrogen, and oxidation is removal of hydrogen. So what it will do? It wants to return back the reaction. So I will get I2 again, I will remove the hydrogen from myself and I will reduce it. It means problem is that this reaction can't proceed forward. This reaction cannot go forward. So we are not able to produce CH3I. So what I will do over here? So what I am doing? I have taken CH4. Okay. I have taken I2. I have taken H mu, photon and sunlight. But along with that, I will take HNO3 or HiO4 in the case of H iodine, in the case of iodine, because these two are very good oxidizing agent. They will say, Acha bhaiya, you want to reduce other and I want to oxidize other. Do one thing, don't reduce this reaction back. You will reduce with me. And after reduction, what happens? CH4, CH3, I to coming. But HI converted into I2 plus H2O plus NO2. This is not important, but important is that HI is disturbing the problem. Now it will not disturb. So they will ask the question, what will happen whenever CH4 react with iodine in presence of sunlight? Does this reaction will go forward? You will say no. We have to use some strong oxidizing agent like HNO3 or HiO4. So it will oxidize Hi into I2 plus H2O and NO2. So the reaction will go forward. Any problem in that? Sure, short? Yes, sir. Now understood everything. Now come to the next part. Over here, you are getting F dot. You are getting Cl dot whenever you are reacting F2, Cl2, Br2, I2. You are getting Br dot and you are getting I dot. Over here you will say this is the stability of free radical. This is the stability of free radical. Why the stability of free radical? Due to size. Iodine is very bigger size, so they can easily handle free radical on them. Now try to understand. Up to now any confusion? No confusion, sir. Now try to understand something about F dot, I dot, Cl dot and Br dot. This topic is very important. So I am saying, if you are not getting anything, try to see it once again from the beginning. Trust me, it will become very easy for you, because halogenation is bigger topic. After that the topic is very smaller. Now suppose you will see one place F dot, another place I dot, another place Cl dot, another place Br dot. These are the dots. Now F dot is very less stable because of size. If it is less stable, so it is highly reactive, means more reactive. As it is more reactive, so it is highly exothermic. More reactive, so it is highly exothermic. And it is highly exothermic, so not done by free radical. So you will see na, explosion is coming. I have written you ki in case of fluorine, explosion will come. Second part, I dot. I dot is highly stable. And it is highly stable, so it is very less reactive. It is very less reactive, so we have to use, what we are using? HNO3 or HiO4 as oxidizing agent to reduced Hi. Understood the point? To oxidize Hi, sorry. To oxidizing agent to oxidized Hi. Oxidized Hi. This important point. Now Cl is less stable, not that much stable, not more stable, not less stable, intermediate stable. Less stable means more reactive. If more reactive is there, then it is less selective. And for that, we have to know their selectivity ratio. What do you mean by that? Just wait, I will dictate. For that, we have to know their selectivity ratio. What is selectivity ratio? For 1 degree, the selectivity ratio for 1 degree is 1. For 2 degree, it is 3.8. And for 3 degree, it is 4.5. What you have written over here, sir? We didn't understood. Just wait. I will dictate you by writing the example. Now bromine. What you will call about bromine? Bromine is more stable. And due to more stability, it is less reactive. As well as it is less selective also. So selective also. So their selectivity ratio is coming something like that. 1 degree 1, 2 degree 81, 3 degree 1600. Sir, what you have written, we didn't understood it. Just wait. Patience. You will just see it. What do you mean by that? Suppose whenever I am writing like this, CH4 plus, or in place of CH4 I will take something different. Suppose I will write C4H10 plus Cl2 in presence of H mu, photon or sunlight. What you are saying, sir? It will form C4H9Cl plus HCl. Intermediate is C4H9 dot C4H9. So intermediate I am not going to write again and again. Suppose I have taken the same thing. Over here I have taken Br2. So what you are getting the product? You are getting the product over here as C4H9Br plus HCl. Same C4H10, F2 and sunlight photon. You are saying, sir, it will do explosion. And whenever I have taken same thing and over here I2, then you are saying sunlight, so we will take, as well as HNO3, HiO4 we will take, and it will form C4H9I plus I2 plus NO2 plus H2. Like that you are doing the reaction. But in place of that, I have written something like this: 1, 2, 3, 4. Not C4H10. I have drawn the structure. And then I will say, react with F2 in presence of H mu, photon or sunlight. So what you will say? Sir, it will do explosion. Same I will say, okay, here explosion, react with I2. What you will say? I will take H mu, photon or sunlight, plus I will take HNO3, HiO4. Now over here, don't say only one product. This is 1 degree. This is 2 degree. This is 2 degree. This is 1 degree. At 1 degree, any one place, you will put 1 iodine. Plus, at 2 degree, at any one place, you will put iodine. So whenever different structure bond line given, then only one product will not come. If 3 degree is there, 3 degree product will also come. So now in this case, they will ask which one is the major product. So if iodine is written and bromine is written, always you will say that 3 degree is major, then 2 degree, then 1 degree. This is the decision for major product. So over here it is 2 degree. Major means which one is coming in more quantity, and this is the minor product. But in the same reaction, suppose anyone has written bromine, what you will say? Acha sir, H mu, photon or sunlight, it will also form the product like iodine, bromine here and over here bromine, and I will say, sir, this will be our minor product and this will be our major product. But when they will write, sir, no, do in the case of chlorine in presence of H mu, photon or sunlight, then you can't say कि 2 degrees measured, 3 degrees measured, 1 degree is measured. No. First you will make the product 1, 2, 3, 4. Here Cl, 1, 2, 3, 4. Here Cl, and then you have to use the selectivity ratio. The selectivity ratio of chlorine for 1 degree, 2 degree and 3 degree is 1. Over here 3.8 and over here 4.5. Means what you have to do, you have to check the original structure. In the original structure, how many 1 degree carbon is there? Sir, 2 1 degree carbon. In that 1 degree carbon, how many hydrogen is there? Sir, 6 hydrogen is there. So 1 degree carbon has 6 hydrogen. So 1 degree carbon has 6 hydrogen. So 6 into selectivity ratio is 1, coming 6. And 2 degree carbon has how many hydrogen? Sir, here 2 hydrogen, here 2 hydrogen, 4 hydrogen, and selectivity ratio is 3.8. So 4 8 ja 32, 3 is the carry, 4 3 ja 12, 13, 14, 15. So 15.2, which one is coming more? 15.2. So here 2 degree will be the major and 1 degree will be the minor. Acha sir, so always to coming 2 degree major na. See, I am writing another example. O, Re, P, Ya, and here I have put here. Now I will say I am going to react this compound with F2 in presence of H mu, photon or sunlight. What you will say? It will do explosion. I am going to react with Br2 in presence of H mu photon or sunlight. What you will say? Sir, this is 1 degree, this is 1 degree, this is 1 degree, this is 2 degree, this is 2 degree. Any one place 1 degree, you will put 1 chlorine. Don't say that this to 1 degree is different. No. In this reaction, just put any one place. Suppose 1, 2, 3, 4, 5. Here you will put bromine, one possibility. Another 1, 2, 3, 4, 5. Here you will put bromine on 2 degree. And one possibility that another product you will make 1, 2, 3, 4, 5. Here you will put bromine. If anybody is asking what is the major, so 3 degree will be major in case of bromine and 1 degree will be the minor. What about 2 degree? No one will ask the 2 degree about. They will only ask how many product. You will say these are the product. But if they have written iodine in presence of H mu, so you have to add over here HNO3, HiO4, same product you will get 1, 2, 3, 4, 5, iodine over here, 1, 2, 3, 4, 5, iodine over here, 1, 2, 3, 4, 5, iodine over here. This will coming as the major product 3 degree. This is coming as a minor product 2 degree. But if they have given chlorine in presence of H mu, the first you will make the product 1, 2, 3, 4. Over here chlorine, another product 1, 2, 3, 4, 5. Over here chlorine, 1, 2, 3, 4, 5. Over here chlorine. Now in the original structure check, how many 1 degree, sir? 1, 2, 3. 3 1 degree carbon. In that 1 degree, how many hydrogen? Sir, 3, 3, 6, 3, 9 hydrogen is there. So 9 into 1 degree selectivity value is 1. Here written selectivity ratio for 1 degree is 1, 2 degree is 3.8 and 3 degree is 4.1. So 9 into 1 is 9. How many 2 degree hydrogen, sir? Over here only one place and 2 hydrogen is there. So 2 into 3.8, that is 7.6. How many 3 degree hydrogen, sir? Only one 3 degree and only one hydrogen is there. So 1 into 5. In this case, which one is major? Now previously 3 degree is major for chlorine, but now 1 degree is coming major because it is the major value, and 3 degree is coming minor. So for chlorine, you can't say directly 1 degree, 2 degree, 3 degree major or minor, something like that. Understood? Everyone? Sure, short? Ha, sir. Understood. So see it very properly. If any confusion, you can ask me. So this is all about selectivity ratio that I have written the point. Over here, you are getting 2 problem. One problem you are getting in the preparation of 2 problem, and I am teaching organic chemistry in that way that whenever the problem is coming, first I will sort out that problem. One problem for the preparation of alkyl fluoride. Alkyl fluoride. You are not able to do. What happens? Explosion happen. What happen? Explosion. So to overcome this problem, we will use one reaction, and that is called Finkel-Stein reaction. That is called Finkel-Stein reaction. Detailing we will have to do in alkyl and aryl halide. Over here, just I am writing Finkel-Stein reaction is also known as halogen Finkel-Stein, not Schwarz reaction. Finkel-Stein for iodide. Over here you are getting the problem in the case of producing the alkyl fluoride, explosion coming, and this problem has been sorted out by Schwarz reaction. This problem has been sorted out by Schwarz reaction, and what he is saying, this method is also known as halogen exchange method. This method is also known as halogen exchange method. Halogen exchange method is saying कि first you will prepare either alkyl chloride or you will prepare either alkyl bromide by free radical mechanism. Once you will prepare alkyl chloride or alkyl bromide, so in place of that I will write directly Rx. X will be either chlorine or bromine. What you will do? You will react this with either AgF or you will react this with either Hg2F2 or you will react this either COF2 or you will react with SbF3. After reacting, what you will get? RF. Here also RF. here also RF, here also RF. Over here you will get AgX, over here you will get Hg2x2 because Hg2F2 is there. So Hg2F2. Over here also you will get COX2. Over here you will get XbX3. So fluorine is not prepared. Two problem is coming. One problem is coming. That problem is we have to use HNO3, HiO3 for that. So I am just dictating one problem only over here. Second problem I will dictate in alkyl and aryl halide. Not that much important, and you have to understood each and everything. This chapter is already very big, so I will add all this over here. Now the preparation of alkyl fluoride is the problem. Who has sorted out that problem? Schwarzer. And these things you have to learn as it is. As it is. Why? Because there is a NEET question. In that NEET question they have asked which of the following is not used in Schwarz reaction. Which of the following is not used in Schwarz reaction? First option they have given COF2. Second option they have given AgF. Third option they have given Hg2F2. Fourth option they have given SbF5. Now looking all same, but SbF3 is there, not SbF5. So exact reagent you have to learn. So I hope halogenation you have understood very properly. If not, then you will see it again. Halogenation part done. Then remaining part is isomerization, aromatization, pyrolysis. What are the topic? I have dictated na halogenation only I have dictated. After nitration, sulfonation, Reed's reaction, isomerization, aromatization, combustion, pyrolysis, everything I will cover here. It is required to cover in one video. It is good instead of 2 to 3 video. Now over here, suppose some different type of question is coming in the exam. They will ask find the, some questions I will write, find the number of monochlorination product including inducting not including a stereoisomerism, including stereoisomerism. So what you will do, you will first suppose first question, Orepia reacting with Cl2 in presence of H mu. What you will say? Sir, this all are 1 degree, this is 3 degree. So all 1 degree looking like same. So any one place I will put Cl and another product Orepia, here I will put Cl, including stereoisomers. Is there any chiral center? No sir, this is CH3, this is H and H. No chiral center is present. No chiral center is present over here. So no chiral center, it has 1. It has also no chiral center 1. The total stereoisomerism including is 2. Acha, second question, don't worry. I will write lots of questions to complete it. 1, 2, 3, 4 in presence of Cl H mu. What you will say? This is 1 degree. This is 1 degree. This is 2 degree. This is 2 degree. So 1, 2, 3. Over here you will put Cl and another option 1, 2, 3. Any one place you will put Cl. Now in this part you will say it does not have any chiral center, but this is the chiral center. So now chiral center means 2 product. 1 chiral center, 2 product, 2 chiral center, 4 product. The total including stereoisomerism, how much coming? 3 coming. GOC, mirror image. Those who have not seen, see it. I will not dictate GOC here. Now third question. Suppose I have given like this 1, 2, 3, 4 and like this, and chlorine in presence of H mu. What you will say? Sir, this is 1 degree and but this 1 degree and this 1 degree is different from this. So over here you will say 1, 2, 3, 4. Here 1 Cl. Another part 1, 2, 3, 4, 5. Here 1 Cl. Any one place you will put. Then you will say another product 1, 2, 3, 4, 5. Here on 2 degree you will put 1 Cl. Then 1, 2, 3, 4, 5. Here on 3 degree you will put 1 Cl. Is there any chiral center over here? No sir. Over here CS3, over here CS3. No chiral center is present. Over here any chiral center? This carbon has chlorine. This carbon has hydrogen. हाँ sir, this is तो not chiral center, but if you will see here, it is coming chiral center. So it is giving only one, but after coming Cl, it is coming one chiral center, the two product. Over here, any one chiral center is there, sir? Sir, here to no chiral center, CS3 is coming, but here it is the chiral center. So it will also give two product. Here any chiral center, sir? No, sir. Here no any chiral center. So only one product. Understanding what I am trying to say, or not understanding? हाँ sir, understanding it. So see it very properly. So how many total coming? Sir, 2, 2, 4, 1, 5, 1, 6. The total monochlorination product including stereoisomers is 6. And this is all about the completion of the topic called halogenation. Now lots of student has messaged me कि sir, I have completed all the videos, please can you upload the next one. So halogenation I will upload. After that aromatization, aromatization, combustion, isomerization, pyrolysis, nitration, sulfonation and Reed's reaction I will upload in the next part, because already you are waiting for the video, so why I will leave it. Understood the point? Okay, up to this, bye, have a nice evening. Fourth part I will do like that. No problem. Any part will come, no any problem in that. Bye. Very good evening, good morning, good afternoon, girls and boys, my dear friends, whenever you are watching this video. Now we are going to see the hydrocarbon part number 4. In part number 3, we have seen some questions of monochlorination. I will continue that question. Over here double bond is there. And now I will react with chlorine in presence of H mu. And I will ask how many monochlorination product including stereoisomers. So what you will say? Sir, first important point you will write कि radical, and those who have seen the last part, they will understand this. Not seen, don't no need to see this video. Radical won't be formed. Radical won't be formed on double bond. Free radical will not form on double bond. So what will happen? Here it will form, here it will form. So one product will be here Cl, one product will be here Cl. Two product. Over here, any chiral center is there, sir? हाँ sir, here chiral center. It is showing geometrical isomerism? No. 2 here. Here any chiral center? No sir, 1. But it will do resonance, over here if free radical is there, then after resonance what it will do? Oh re pia, and those who are watching this video from the beginning, for them easy. Now this double bond will shifted over here, and once this double bond will be shifted over here, now there is a possibility you can form free radical here and here, both are the same design. So over here if you will add the Cl group, what you will get? Ki sir, no chiral center, but it will show geometrical isomerism, means one is cis, one is trans. The total structure stereoisomerism, total monochlorination including stereoisomerism is 2, 2, 4, 1, 5. And those who are watching continuously this hydrocarbon, for them only this question will be understandable. Not watching, I am also suggesting no need to see this. You are just wasting your time over here. Go on YouTube, lots of videos are there, much better than me, you can watch it from there. Now next topic is aromatization. First we have completed the topic, and the name of the topic is called substitution. In that substitution I have completed halogenation. Now we are going to see aromatization, then Reed's reaction, sulfonation, each and everything I will complete. And this is the last for today class. Tomorrow I will dictate you carbocation, other things of the part. Now over here, aromatization is the reaction of hexane, means not pentane, starting from 6 carbon, hexane, heptane. Due to making that much video, my sound is stucking, so I will not make next one. Octane with, up to octane they will ask, hexane, heptane, octane with either Al2O3 or Cr2O3 or anyone you will take, molybdenum oxide MeO2O3 or vanadium oxide V2O5, everything in presence of heat. What do you mean by that? Suppose you have taken 1, 2, 3, 4, 5, 6 and any reagent you have taken, either Al2O3 or Cr2O3 or MO2O3 or V2O5, and you have taken heat, any one. It is not compulsory to take all. So it will do aromatization and it will form benzene ring. Direct you have to learn. If you have taken heptane, this is hexane. In place of hexane, 1, 2, 3, 4, 5, 6, 7, and you have taken all this reagent in presence of heat, then it will form toluene. What it will form? Toluene. And if you have taken octane, this is heptane. And suppose you have taken octane, 1, 2, 3, 4, 5, 6, 7, 8 in presence of Al2O3, Cr2O3, MO2O3, V2O5 and heat, it will form the product like this. Either the product will be like this, or the product will be like this, or the product will be, because 2 carbon is extra, na? So that 2 carbon will be arranged in any way. So I am arranging all the possible ways. So over here. So like that the product will come. 6 will give benzene, 7 1 extra CS3, 8 2 extra CS3. I am arranging that 2 extra CS3. One more reaction to convert, to do aromatization, and that is with alkyne. This is also known as acetylene. So if they have written acetylene, don't get confused. Ethylene or acetylene, ethyne or acetylene. You will take a red hot tube. RHT means red hot tube. When you will pass this with red hot tube, it will convert it into benzene ring. If over here CH and over here we will have triple bond CH. One side you have attached something. What is you have attached? Red hot tube will attach 3 places, here, here and here. If you have attached over here ethyl, so 3 places ethyl will come. If you have attached over here propyl, 3 places propyl will come. Similarly, if you have attached both side C, triple bond C, here you have attached something, here you have attached something, and red hot tube, then each and every places of benzene ring, 1, 2, 3, 4, 5, 6, it will come. So this is the second part of aromatization. Next part, you have to understood this reaction, how I am doing it. Understood, na? Over here, what is there? That will come every place. Over here, C2H5, to C2H5. C3H7, to C3H7. Understood? What it is there, according to that, you have to arrange it. Now, next part is the aromatization part, is reaction with palladium and carbon. And it is basically applicable for alkene. And for this fixed example, first, suppose I have taken cycloalkene and reacting with PD, palladium in presence of carbon, it will convert into benzene. Whatever with the reaction I am writing, that is fixed. No extra will come rather than this. Suppose over here benzene ring, and over here you will use palladium and carbon. One benzene ring to already there, another part will also convert into benzene ring. Suppose over here third part is there, and in that third part you have pyridine, not pyridine exactly, this over here no double bond, and you are taking palladium in presence of carbon, every place double bond will come, here, here and here, and pyridine will form. And this is all about the completion of the topic that is called aromatization. These are the fixed reaction for aromatization. You will see, and once you will learn it. Aromatization done. Now, and these are the fixed reaction. No extra things. So don't worry it. Just you have to learn. Now we are going to see isomerization. Next part is I told you na ki halogenation is very big. Everything is very easy. Isomerization. What is isomerization? Isomerization means I will take anything 1 2 3 4, and whenever you will take the reagent AlCl3 plus HCl, now you have to convert all the isomeric form. What you will say? One isomeric form is this, two isomers is possible for C4H10 2. How many possible isomers? Draw it without seeing it if you will see this reagent. Suppose second question 1 2 3 4 5. How many isomers is possible for this? Sir, 3 isomers. 1 2 3 4 5. Another one 1 2 3 4. Here another one 1 2 3. All the possible isomers you will draw it. That's it. What is the product? Simple. All possible isomers. That's it. Isomerism done. Reagent is AlCl3 plus HCl. That part you have to remind it. Next part of the topic. That's it, huh? I'm saying the halogenation is the biggest one. After that, everything is very small. Now we have to know combustion reaction. This reaction is very important. Some reaction I will write 3 reaction over there. That we will by heart. Everything is there. They are asking in the exam every time. Now, if 2 types of combustion. If incomplete combustion is there, incomplete combustion is there, so in the case of incomplete combustion, suppose methane will burn in presence of oxygen, so it will give carbon plus water, incomplete combustion. And best part is that methane will only go incomplete combustion, remaining other thing will not. Methane only does incomplete combustion. Other things is not doing the incomplete combustion. Now, other things other than methane, propane, butane, hexane will not do. Next one is complete combustion. Complete combustion. Everyone knows already what is the reaction for combustion. I have told you CX. Everyone, CX HY plus X plus Y by 4 O2 will give X CO2 plus Y by 2 H2O. This is the reaction for combustion reaction to balance the equation. Over there, I am going to write 3 reaction. Everyone will learn it very properly. That is called controlled oxidation in the case of combustion. And that reaction is very important, sir, very important. Everyone will learn it. Now, what is control oxidation? Control oxidation, if they have given CH4 and burning in presence of oxygen, and they have taken copper also. Understood what they will take? CH4, if they will take copper in presence of temperature, that is 573 Kelvin approx, so you will get alcohol. If CH4, the CH3OH. If C2H6, then C2H5OH, like that. Any alkane, alcohol will come. Second one, if I will take CH4 in presence of O2 and in place of copper I will take molybdenum oxide. If I will take MO2O3, then it will convert into aldehyde, SCHO. And if I will take CH3 in presence of O2 and I have taken manganese salt of carboxylic acid, CH3COO whole twice, in presence of heat, over here also heat, it will converted into carboxylic acid, CH3 C double bond OH. It will converted into carboxylic acid. I have taken CH4. If they will take CH4, anything other, OH you have to attach, remaining whatever be the alkane, CHO you have to make, remaining whatever be the alkene, C double OH you have to make, remaining whatever be the alkene. Understood? This is also completion of combustion. It means, sir, what you are teaching in this video all are for learning. Yes, everything you have to see once you are able to understood it. Now, sometime they will give you 3-degree alkyne and they are saying react it with KMnO4 and heat, you are getting alcohol. It means KMnO4 and heat will only react with 3-degree alkane, only 3-degree alkane, and that will form 3-degree alcohol. Now, after that, suppose you have taken CH4 and reacting with water, but this time water is steam water, so So it will convert into carbon monoxide and 3 mole of hydrogen. That is called carbon monoxides. And these reactions you have to write as it is to know this. Now we have completed 100% of combustion. Next part is pyrolysis. Pyrolysis. It means this total video is 90% is about to learn. But if you will see one time, you are not getting confused in that. Okay, understood this point? Okay, sir. Now, pyrolysis is also known as cracking. Pyrolysis is also known as cracking. Cracking means, suppose they have given C6H14 and they are saying break down into 713 Kelvin, which means pyrolysis will happen at very high temperature. What will happen? You can break anyway. 1, 2, 3, 4, 5, 6, 7 carbon. Break it. Either you will make 1, 2, 3, 4 carbon, 1, 2, 3 carbon. Or you will say 1, 2, 3 carbon, 1, 2, 3 carbon and 1 carbon. Your choice. You can break from here. You can break from here. You can break from here, 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 here. Any place. You will break this total compound in how many parts you want. That is simple pyrolysis. That's it. Nothing extra is that. Pyrolysis means breaking of compound. In how many parts you want to break? You break. Choice is yours. Next is nitration. Next is nitration. What will happen in the case of nitration? First of all, you have to know that the reagent used is concentrated HNO3 plus heat, or you will take concentrated HNO3 plus concentrated H2SO4. Anything you will take in the case of nitration. In the case of nitration, anything you will take, these things will give a electrophile as NO2 plus. What is the electrophile coming? NO2 plus. Now what will happen? Suppose I have taken this and I am doing nitration by using any one of the reagent that I have written. So your choice again. What you will do here, either you will put NO2 here, or you will say, nah sir, I break it from here and I want to make another product of this. So one NO2 you will put here and then CS3NO2. Means any part you can break, total anywhere you have to attach. It means 1, 2, 3, 4 is there. So either you can directly attach NO2 here, or after breaking from here, 1 NO2 here, 1 NO2 here, or after breaking from here, 1 NO2 here, 1 NO2 here. Any place you can attach NO2. Like pyrolysis you can break and you can attach NO2, or without breaking you can attach NO2. Understood the point? Means for this, suppose I will say this is the compound 1, 2, 3, 4 and I will take one more part. Suppose I have taken 1, 5 and I am doing nitration. What I will say, sir, I can make 1, 2, 3, 4, 5 NO2. But I don't want to do like that. I will do 1, 2, 3, 4 over here NO2 and remaining CS3 NO2. Someone will say, no sir, I want to do 1, 2, 3 NO2 over here and 1, 2 NO2 over here. So like that, how many product you can want, you can make it. Understood? Arey sir, it is so easy sir. Yes, very easy. Just you have to understood. Next, but these are the things you have to learn. See it very properly. Direct question coming in the exam. Like that, next part is sulfonation. Over here, in sulfonation, 3 degree alkyl will be the major one, then 2 degree alkyl, then 1 degree alkyl. This is the major product. Major product alkyl. Now, sulfonation, what is the reagent we will use? So, previously, we are using, what we are using? We are using concentrated H2SO4. See, over here HNO3 or heat, or HNO3 plus H2SO4. But over here, only H2SO4 plus heat. No HNO3. HNO3 coming, then nitration. What will happen? Suppose I have given this and I am saying I am using the reagent concentrated H2SO4 plus heat. What is the product coming? You will say 1, 2, 3 either. Acha, over here what is the electrophile? SO3. If anybody is asking what is electrophile? SO3. But what is attacking? What is attacking over here? So attacking is SO3H. How sir? So alkane. Haloalkanes, haloarenes. So over here SO3H. Something you are not understanding here. Na? Suppose I am saying to learn haloalkanes, haloarenes, that is alkyl aryl. Over there you will understood. Or this is 1 degree, this is 1 degree. This is 2 degree. Two product will come. Either SO3H will attack on 1 degree or 2 degree. Which one is the major one? Sir, 2 degree is major, 1 degree is the minor. Because 3, 2, 1 is the rule. Understood? Suppose I have taken 1, 2, 3, 4 here. And I am saying concentrated H2SO4 and heat. What you will do? Sir, 1 degree here, 1 degree here, 1 degree here. So 1, 2, 3, 4, 5. Over here SO3H. Another one. 1, 2, 3, 4, 5. Over here SO3H. Another one. 1, 2, 3, 4, 5. Over here SO3H. What is the major? This is the major. What is the minor? This is the minor. Now, over here don't say I have written wrong. SO3 is the electrophile. But attacking will be SO3H. Anything I am writing that is not wrong. Understood? That also done. Sulfonation also done. Now, next part is Reed's reaction. Reed's reaction. I have written now all aromatization, isomerization, sulfonation, nitration, halogenation, Reed's reaction. So we are able to complete this part. Reed's reaction. Over there we will use the reagent as SO2Cl2 plus H mu sunlight. What will happen? Suppose you will make in this part also 3 degree greater than 2 degree greater than 1 degree. Previously what is attacking? SO3H. This part Cl will attack. What will attack? Cl. Suppose I have taken this example. SO2Cl2 in presence of H mu, what will come? Sir, this is 1 degree, this is 1 degree, 1 degree, 1 degree. This is 3 degree. So over here at 1 degree Cl will come. And over here 1, 2, 3, here 1, 2, here Cl will come. Which one is the major one? Sir, this is the major one and this is the minor one. Same as sulfonation, but in sulfonation we are using SO3H and over here we are using what we are using? Reed's reaction, that is Cl. What is the byproduct? HCl plus SO2. What is the byproduct? HCl plus SO2. So this is all about the completion of the topic, and the name of the topic is called reaction of alkane. Understood? Now after that I will dictate you the physical property, boiling point, then rearrangement of carbocation. I will not make this topic that much big. Just up to this it is the completion. Remaining 1 video, 2 video, 3 to 4 more video I will dictate. If possible then in 2 I will try, 3 I will try, but 4 max to max I will complete hydrocarbon. And tomorrow we will have the total completion of hydrocarbon. After that we will go with the next part of the topic. So I hope you all have enjoyed hydrocarbon. Trust me, I am trying to make this topic very easy for you all. So don't get confused and nervous and try to see 1 or 2 times. This whole page is about to learn, but see it once. You will be understood what I am trying to say. Understood na? Bye. Have a nice evening. Very good evening, good afternoon, good morning, whenever you are watching this lecture. In the last class, we have seen the part 1, part 2, part 3 and part 4 of hydrocarbon. Next part of the topic, we are going to start rearrangement of carbocation. Why there is a rearrangement? Now, anyone will do rearrangement. What is mean by rearrangement? Why the rearrangement will happen? Don't worry. Each and everything I will dictate you. If anyone will do rearrangement, they will do just to gain stability, they are doing rearrangement. What is the condition for having rearrangement? Why anyone will do rearrangement? First try, don't worry. Don't get panic. After that, you will understood each and everything. From now onwards, you didn't find any difficulty in ring expansion, rearrangement, everything. Now, rearrangement, any carbocation. Rearrangement will happen in our syllabus, carbocation only. Only for carbocation. Only for carbocation. Other rearrangement we didn't have to study. Free radical will also do, but free radical rearrangement we didn't have to study. Only we have to study the rearrangement of carbocation. First of all, it will do rearrangement to gain the stability. What are the conditions to do the rearrangement? The conditions so that any carbocation we do rearrangement, first condition is back bonding stability. Everything, don't worry, just write it. I will start doing it, you will understood it. Second one is to get resonance. Third one, more number of alpha hydrogen than before. Means either after doing rearrangement they will achieve back bonding stability. If back bonding not coming, then check कि does they are getting resonance or not. If resonance not getting, then check does after doing rearrangement they have more number of alpha hydrogen coming or not. If these three conditions will satisfied, they will do rearrangement. If this condition will not satisfied, they will never do rearrangement. While having this rearrangement, we have to check कि which things will shift. So shifting priority. Sir, what you are writing, we are not getting it. Just wait. Shifting priority. What are the shifting priority? Either H plus will shift or H minus will shift or pH minus will shift or 3 degree will shift or 2 degree or 1 degree. What is 3 degree, 2 degree, 1 degree? Methyl. Methyl means alkyl shifting. Sir, we didn't understood anything up to now. No problem. Just see now. First you must just see these points what I have written. Now I am going to do rearrangement. Okay sir, do it. Suppose I have taken first example, first question. In that question I have taken CH3, CH2, CH2 plus. Now see, this carbocation initially present at 1 degree. Is there any possibility nearby that this is 2 degree? So they will try to do rearrangement. How the rearrangement will happen? Just understood it. Over here CH3, don't touch it. Just nearby you have to check. Over here we have CH1H I am writing on the bottom. And over here CH2 plus. What happens? Up to now H plus is going. First time H will take the both electron and became minus. This minus will come here to justify it. As this is taking the electron, so there is a plus sign coming. So what you will write? There is a H minus shift. And H minus, H plus shift is known as hydrogen shift. And H minus shift is known as hydride shift. Means what will happen after that? This minus will come here. So you will get CH3. CH2 became CH plus CH3. Up now still rearrangement is possible? No sir, now rearrangement is not possible because after that again 1 degree coming. So over here first you will check what is the situation. Back bonding stability, no back bonding stability. Resonance, no resonance. More number of alpha hydrogen, yes sir. Here you have, previously here we have 2 alpha hydrogen, but after doing rearrangement here we have 2 alpha hydrogen, but after doing rearrangement it has 6 alpha hydrogen. So it will do rearrangement. It means 1 degree will come to the 2 degree carbocation. This is the rearrangement things. Now lots of example. Don't worry, don't panic, don't worry what I am doing, what I am not doing. Question next. Suppose I have taken kabhi, 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 kabhi. Now here is the plus. Now does it will do rearrangement? What you will say? Yes sir. Problem is that this plus is on 1 degree and just adjacent to that is 3 degree. So what will happen? Check. What are the shift needed? First H minus shift. So over here H minus is present, I have done. Then phenyl minus. Then 3 degree, 2 degree, 1 degree. Now over here does we will have H minus? No sir. This carbon has how many carbon? 1 here, 1 here, 1 here, 1 here. Means it does not have any hydrogen. Before doing the shifting, I will write this structure very properly. CH3, CH3, CH3 CH2 plus. This structure is something like that. Now there is no hydrogen, so what they will do, from here methyl will go like this. So it will become CH2 3 minus, it will become plus, and this will come here. So what you will say, this time CH3 minus is shifting. If hydrogen is there, then CH3 minus will not shift. But hydrogen is not there, so CH3 minus will shift. So it will become CH3 CH2, and here CH3 coming. So either you will write this side or you will write bottom side, and plus will come here. Similarly, understood na how I have done the shifting? But if I will do in this structure, so I will directly write this, here plus, and here one more CH3 coming, and plus shifting here. Both are the same thing. Don't get panic. But if I will write like a bond line structure, so you will get confused, sir, what you have done. So I have written first in breakdown of the structure. Suppose some more example I am going to take. I have taken kabhi. Here I have taken plus, and here Acha, what is the use of shifting, sir? Whenever you have done the shifting over here, in the first case, how many alpha hydrogen? Sir, 0 alpha hydrogen, because nearby carbon does not have alpha hydrogen. But once you will de-shifting, 3, 3, 6 to 8 alpha hydrogen. So only 3 conditions, either back bonding, resonance, or more number of alpha hydrogen. The more number of alpha hydrogen coming, so it will do shifting. Understanding? Yes, sir. Now, if you will see this part, plus, how many alpha hydrogen? 2 here, 1 here, 3 alpha hydrogen. But anyhow, if this plus will come here, then how many alpha hydrogen? 3 to 5 to 7 alpha hydrogen is going to be increased. So what I will do? I will do shifting. While doing the shifting, I will check, does it has hydrogen? Yes, sir, one hidden hydrogen. This hydrogen will become minus, this will become plus. Hydrogen will come here, and shifting will happen, and we will get the structure plus over here. Over here, this time, what is the shift? H minus shift. Acha, suppose I will write this structure. Suppose I will write this structure. Here plus. Now, after shifting, this plus will come here. Here, one only alpha hydrogen. Sir, 2 to 4. After it will shift, how many alpha hydrogen? Sir, 1. No. Alpha hydrogen decreases, na? Check if the plus will go there, where I have cross-checked it. This plus will get only 3 alpha hydrogen. But before that, it has 4 alpha hydrogen, as well as neither resonance, neither back bonding. Don't say, ki, sir, this plus will directly come here, alpha hydrogen increases. No. Step by step. If nearby shifting is possible, do. After that second shifting you will do, no problem. Over here, no shifting is possible. You will say, sir, no rearrangement. Understood the point? Previous 3 alpha hydrogen to 7 alpha hydrogen, so it will do shifting. But over here, alpha hydrogen not increases, so it will not do shifting. समझ रहे हो बात को? Understanding what I am trying to say? Yes, sir. Not that much tough. Okay. Suppose I will take this structure, and over here I have put plus. Now, how many alpha hydrogen it has, sir? Sir, 7 alpha hydrogen. Now, if it will go here, nearby, or here, nearby any place it will go. So, resonance not happening, back bonding is not there, but alpha hydrogen also not increased. Check it. Hyperconjugation alpha hydrogen checking I have already dictated. So, after checking you will say, sir, not good to do rearrangement. So, no rearrangement. Acha. Suppose I will give one more example like this. Kabhi. And over here plus. Does it will do rearrangement? Sir, previously it has only 2 alpha hydrogen. This side to no alpha hydrogen, only 2 alpha hydrogen. This side to no alpha hydrogen. If it will come here, the alpha hydrogen will increase. Over here, first we have 2 alpha hydrogen. Now it has to do shifting. While doing the shifting, does this carbon has hydrogen? No. So this is CH3, this is CH3. So what will shift over here? Methyl. Methyl will take the electron as a minus, it will become plus, and this minus will come here, and over here we will do CH3 minus shift. After doing shifting, what I will get? O-P-A. Okay. Here plus coming, and here CH3 coming. Now, how many alpha hydrogen, sir? So it has 3 to 5, 1, 6 alpha hydrogen. Sir, alpha hydrogen increases, so we will do shifting. So I hope you understood it. Suppose I will write like this, kabhi plus, and over here OH. Now I will do, it will do rearrangement. First you will say, yes sir, it is 1 degree, it is 2 degree, automatically 2 degree will be more stable than 1 degree. So over here written, 3 degree, 2 degree, 1 degree, like that. So what I will say, yes sir, it will do rearrangement. This has hydrogen, yes sir, hydrogen it has. It will take minus, it will become plus. This minus will come here. So O, Re, P, A, here plus will come. Okay sir. Now does it still it will do rearrangement? How many times it is possible it will do? Why? Because just nearby that, if the plus will come here, back bonding. Back bonding means just adjacent to the plus, any element is there, they have lone pair. So back bonding coming sir. So it will also do rearrangement. First it has 1, 2, 3, 1 alpha hydrogen. Now after doing rearrangement, first it has 1 alpha hydrogen, but after doing rearrangement, it will get 3, 3, 6, 1, 7 alpha hydrogen. But before alpha hydrogen, back bonding and resonance is required. So back bonding coming, it will do again rearrangement. From here hydrogen will go as a minus, it will come here, and this plus will come here. So what you will get, kabhi over here OH, and plus is coming here, and this plus is stable by the lone pair of electron, lone pair sigma positive, and this situation of resonance is known as back bonding stability, BBS, and BB is very much required in the life. BB means bife. So I hope everyone has understood how to do the rearrangement. So check this fast. After that I will dictate you the rearrangement whenever the number of rings increases. Whenever the number of rings increases. So if I will do too much small, you are getting confused. Everyone will see this, how I have done, and just see once more please. So you will understood how to do rearrangement. Those who understood, no need to check it. Just try to do it once more time. If okay, then okay. Suppose now, one more example can I take, because I have taken the back bonding alpha hydrogen. Suppose I will take this example. Kabhi plus. Over here this, and over here this. Now I am saying कि first it will do rearrangement. Yes sir, 1 degree. 1 degree has over here only 1 alpha hydrogen. If the plus will come here, from here hydrogen will go as a minus, plus will come, it will do rearrangement. Kabhi here plus will come, here hydrogen will come, but we are not showing hydrogen. Understood na? CS3 something is there, then we will show, but hydrogen we are not showing. This rearrangement, still it will do rearrangement. Yes sir, if from here hydrogen will come here as a minus and plus will come, it will be pi sigma positive. First back bonding coming, do it. Resonance coming, do it. After that alpha hydrogen, the first from here to here, how many alpha hydrogen we have achieved? First of all, we have achieved how many alpha hydrogen? First we have 1 alpha hydrogen. From here 3, 3, 6 and 1, 2, 8 alpha hydrogen. After achieving 8 alpha hydrogen, again we will do rearrangement, and after doing rearrangement, kabhi plus here, and this is resonance stabilized. So up to this you will do rearrangement. Means if anyhow you will get back bonding, first achieve up to back bonding, but line by line. Suppose I will write like this, kabhi, and here plus, here double bond. Now don't do rearrangement, because after coming, suppose I will write like this. One second, I will do, otherwise you will get confused. Here, suppose, here I will do, here. And now I will put plus here double bond. What you will say, sir, first so it will do rearrangement, because 1 degree, from here, hydrogen will go like this. Hydrogen will go like this as a minus, it will become plus. So here double bond, here, plus will come, this. Okay. So it will become 2 degree. Here first it has 2 alpha hydrogen, then it will become 5 alpha hydrogen. Now resonance coming, but before coming resonance, if the plus will come here, still it has 4 alpha hydrogen. So it will not do rearrangement. After that, further rearrangement will not happen. Either after coming here, it will become resonance, but before that, it has to reach here. And here reaching is not benefited for him. Here reaching is not benefited. So it will not do. After that, no further rearrangement. Understood na? No further rearrangement. Sir, what bakwas you are trying to say? I am trying to say line by line check. First back bonding coming? No. Resonance coming? No. More number of alpha hydrogen coming? Yes, do it. Then again check here. Don't check directly after seeing 2 to 3 points. Understood? Now those who understood, very good. Not understood, already giving the number 9, 2, 6, 7, 9, 3, 7718. Sir, every video you are giving your number because anyhow I don't want to become superstar on YouTube. Very frank. When I have to become superstar, I will buy a smart board, then I will become superstar. With this video lecture, only those students will study, those who know me. Those who didn't know, they will not reach up to there to see my number. And in the beginning, I am not giving number. After 16 minutes, 20 minutes, I am giving my number. So those who will reach up to that, they are my student. So they will ask me any questions. Understood? Now, okay, sir, after having this bakbas, we understood the rearrangement process in normal cases. Now, we are going to see the ring expansion rearrangement. Ring, and lots of student has this confusion. Ring expansion rearrangement, 90% student is getting confused in that I know. Okay, so ring expansion rearrangement, we will do rearrangement. Spelling I will make it correct, otherwise you all will see sir spelling errors. Rearrangement, sir, still looking like wrong. Okay, do it. Understood it. Now we have ring expansion rearrangement. What will happen for ring expansion rearrangement? First again I am going to write some point and you will see, you will understood it. Now first try to achieve a ring of 6 carbon, otherwise 5 carbon, otherwise 4 carbon. 3, 7 is very highly unstable. See, I will tell you one thing. If you have to understand organic chemistry fully and easily, one request my side. Those who are watching my video, those who already have studied with me still, GOC, isomerism, hydrocarbon, haloalkanes, each and everything you will check. Once I will complete it, you will get a package of organic chemistry, because in one chapter I can't dictate each and everything. Where the carbocation form, how the form, this I will dictate in haloalkanes, haloarenes, SN1 mechanism will do. If I will start doing on the hydrocarbon only, it will become 20 part and you will not study. Understanding? So don't get nervous and confused. After completing hydrocarbon, check haloalkanes, haloarenes. After taking haloalkanes, haloarenes, that is aryl halide. After that, see alcohol, phenol. Whole package I will complete and then you will enjoy it. If not enjoyed, then you will tell, sir, what you have taught, we have not enjoyed. If already, means first try to achieve 6-member ring, 5-member ring and 4-member ring. 6 coming, then it is very good. If already 6 carbon is there in the ring, so no expansion. No expansion. Ring expansion will not happen. But if already 6 carbon, but after doing expansion, it is having back bonding, then do expansion. Means ring is already 6-member, but after making it 7-member ring, we are getting back bonding stability, do it. This is the main point regarding ring expansion. Now see each and every one. I am going to write questions line by line and I will tell you how to do expansion. First question. Kabhi. Condition is that. Acha. Condition is that for ring expansion, ki ring will coming like this. Either after ring, there is a plus charge. Suppose this is the ring, after that 1 carbon here. This is the special condition. Only then ring expansion will happen. Here. Then only ring expansion happen. Here. Then only means ring is there. After that ring 1 carbon, on that carbon there is a positive sign. Suppose I will do like this. And I will say here plus. Then we will go with ring expansion. Nah. This is not the condition for ring expansion. Ring expansion means ring after that 1 carbon, after that ring expansion. First question. Question is kabhi. Here plus. Does it will do ring expansion? Yes sir, it will do. Either this side or this side, just adjacent to the plus charge. Break it. After breaking, this carbon that is attached with plus charge, give him the plus sign. And this carbon give minus. And this plus will come here. So this carbon will go inside. The 4-member will be in ring, 5-member. Where the plus will come? Where that you have started. This is to joining here, na? The plus will come here. Sir, not understood. Don't worry. I will take lots of examples. Suppose I have taken 1 2 3 4 5, and over here plus. Now do it. You will say, sir, this side I will break, minus plus. This will go here, 5 member will become 6 member, 1 2 3 4 5 6, plus will come here. Now suppose another question. Suppose I have taken K O R P, yeah, here plus. Now first it will do ring expansion. First it will try to do the rearrangement, and here it has 1 alpha hydrogen, but it will reach here, it will become 1 here, 3 here, 4 alpha hydrogen. So first it will do H minus shift. Before rearrangement it will do H minus shift. This hydrogen will take the electron as a minus, it will become plus. Then it will become kabhi here plus. Previously it has 2 alpha hydrogen, now it will become 3 1 4 alpha hydrogen. Now it will be created the condition for ring expansion. It has created the condition for ring expansion, but ring expansion will happen? No, it is already 6 carbon, and after doing ring expansion it will not increase the back bonding stability. After 6 carbon, if back bonding is coming, then do expansion. Not coming, leave it. The not coming, not do rearrangement. But not doing rearrangement, can we do the alpha hydrogen increasing? Sir, here the plus will come, the 2 to 4 to 6 alpha hydrogen, first 4 alpha hydrogen. So it will again do hydride shift, means from here hydrogen will go as a minus, it will become plus. So here plus will come here, and it has 2 to 4 to 6 alpha hydrogen. Acha sir, how, which condition it will do rearrangement? Do it. Suppose I have taken 5 member here, don't worry about it. 5 member here plus. The first this plus will come here. Sir, that we understood, no need to do all the time. Okay sir, here it will come. After coming here plus, what will happen? There is a chance of ring expansion, because 5 member ring will become 6 member ring. It will become minus, it will become plus. This will come here. What you will get? 1 2 3 4 5 6 here plus, and while this carbon is coming here, 1 carbon is left, so this carbon will attach here. Now still see, does it will do again rearrangement? Sir, it has 1 and 2 3 alpha hydrogen. If this is plus will come here, it has more alpha hydrogen. Now from here H minus shift will happen, minus coming, and sorry, from here H minus shift will happen. This hydrogen will go as a minus, and this plus will go, and this minus will come here. So it will become kabhi here plus. Now this plus has 2 3 5 2 3 2 5 2 7 alpha hydrogen. Understanding? Expansion plus rearrangement, both can do. If expansion possible, do expansion, then do rearrangement. So I hope you are understanding line by line. Again I am saying na, if you will understood it, very good. Not understood, number is there, you can message and you can ask. Next question. Suppose I have taken over here different type of example I will take, with expansion, with normal, and one question also I will do on that basis. Now over here it has a chance कि either it will go here and it will increase the alpha hydrogen. Here alpha hydrogen is how much? 2 and 2 4 alpha hydrogen, and here it will come to become 3 to 5 to 7 alpha hydrogen. One possibility this plus will come here and will get back bonding lone pair. So which it will choose? It will choose the back bonding stability, because back bonding is more stable than hyperconjugation, and first back bonding, then resonance, then hyperconjugation. So back bonding it is coming. So from here it will shift, H minus shifting will happen from here, plus will come here, ringa chinga pinga hinga linga bhatinga here, and plus will come here. This plus is stable by back bonding stability. So whenever you will get the chance of hyperconjugation, more alpha hydrogen, as well as back bonding, so do back bonding. If you will get the chance of hyperconjugation, more alpha hydrogen, or resonance, so do resonance. I hope you are understanding what I am trying to say. Now after this we are going to see lots of example. Don't worry about it, we will do each and every example as much as possible. Now next part of the question we have, means lots of question I will do. Most of the student has very much confusion regarding this. Now over here ring expansion happen, yes, criteria coming, it will be this side or this side, minus it will become plus, this will go here, 4 member will become 5 member, plus will come here, that's it. Suppose I will take another example. 1 2 3 4 5 6 here plus and this. Now it will do ring expansion. Already 6 carbon, so don't do ring expansion. Sir, when it will do? I will write example also. 6 carbon there, don't do because it is not achieving back bonding, not achieving resonance, but just only for hyperconjugation, don't do. Only back bonding you can do more than 6. Now over here what happened? It will not do ring expansion, but it will go here to achieve the back bonding stability. But when it will go here, it does have a hydrogen. No. So what will happen? This CH3 will break as minus, this will become plus, this will come here. So 6 member will be as it is, 6 member here, plus is coming. Now this carbon already there and this carbon minus will go here, it will become like this. So does alpha hydrogen increases? Yes sir, increases. 6 sir, over here it has 0 alpha hydrogen, but it will come here 2 to 4 to 6 alpha hydrogen. So alpha hydrogen increasing. So ring expansion we are not doing because back bonding not stable, not coming. Suppose I will do like this, here OH, here plus. Now either it is 6 member ring, but if the plus will come here, it will do, sir, here not back bonding, na carbon, third number carbon, no back bonding, just adjacent it is the carbon, just adjacent this carbon is there, this carbon is not adjacent, don't see like this, see 1 2 3 carbon not adjacent, so it will not do back bonding here, but after doing ring expansion it will do expansion, minus will come here, plus will come here, 6 member will become 7 member, 1 2 3 4 5 6 7 member it will become, 7 member it will become. So resonance back bonding will be there. So over here OH and plus will come here, and this rearrange expansion of ring not happen just to get alpha hydrogen, it will happen because of getting back bonding stability. Understood the point? Everyone? Any confusion? No sir. Suppose I will take another example. I have taken the another example of this kabhi kabhi kabhi. Now if you will see na, this plus is the most stable carbocation. It is the most stable carbocation. Why? 90% of the teacher writing, so I am also going to write because of dancing resonance. But don't ask me what is dancing resonance. When I will teach you alkyl aryl, over there I will teach. Don't worry about it. Okay na? Just don't get confused. It will do resonance. Sorry, it will do ring expansion. No sir, it is already most stable. So no ring expansion. Understood? Now why I am not teaching all the things at one place now? You are getting total confused. What is happening? The ring expansion, to only just see ring expansion. It will do ring expansion. No, why not sir? It is the going from 4 carbon. You have just written over here ki 6, after that 5, after that 4 coming. So 3 is going to be the 4, but no, it is the 3, but still it is the most stable carbocation. So it not want to become 4 due to dancing resonance. What is dancing resonance in alkyl aryl, or in this video also, if it is required any place, I will dictate you. Don't worry about it. Achha. In the same situation, 3 membered ring is there, but over here plus and over here OH is there. Then it will do, sir, either dancing resonance, but back bonding coming after coming here. So back bonding is the powerhouse of anyone. Back bonding means wife is required for everyone in the life. So plus over here ring expansion will happen. This plus will come here. The 3 member ring will become 4 membered ring. Plus is here, and on the same plus OH is there, and back bonding stability. So dancing resonance is there, still back bonding is the more powerful than dancing resonance. Suppose I have taken one example, kabhi kabhi kabhi. Over here I have taken CH2 plus, and over here I have taken OH. Does it will do resonance? Yes sir. Does it will do shifting? Yes sir. Why? Everything coming, alpha hydrogen increasing, back bonding coming. What will happen? From this one CH3 will go, this will break as minus, plus, this minus is coming here. So what you will get? This plus here, and this CH3 coming with this. So this is there, and this is also stable with back bonding stability. How I have done it? Understood now? This I have breaked it also one time. So don't get confused. So this is all about ring expansion. Now on this ring expansion topic, I will dictate you one example also, one reaction also, and the name of the reaction is called dehydration of alcohol. Dehydration means whenever you are getting loose motion, doctor is saying dehydration. Dehydration means removal of water. Removal of water from alcohol. Alcohol you already know कि they have a general formula CnH2n plus 2 and O. So there is a removal of water from alcohol, and this process is also formed carbocation. Also formed carbocation. So especially I am dictating this topic. So carbocation rearrangement in the different way we are able to also see it. So I hope you are understanding it what I am trying to say, and try to see one time, two time, don't get nervous and confused, and don't see ki sir this not coming, message fastly. Okay. In this part, reagent we are going to use, the reagent we are going to use over here is H2SO4 or H3PO4 or KHSO4. तो KHSO4 also written, everyone knows कि acid coming, okay sir, acid coming, okay sir. KHSO4 is also acid. These three rearrange can be rearrangement. These three reagent can be used. What happen? You will take alcohol as a lone pair. You will react this alcohol with H2SO4 or H3PO4 or KHSO4. Especially they will mention temperature also, 443 Kelvin. If temperature mentioned or not mentioned, you will try to do dehydration of alcohol, but mentioned, so it is very good. Sometime in place of that they will write also H plus heat, so don't get confused. What happened? First of all, this all reagent is giving what? H plus, and this H plus is attacking here. So what happened? Lone pair is there na, so it will become ROH and H, oxygen getting plus. Now this is water, and water is very good living group. Water is very good living group. So this will leave and it will become carbocation. H2O will go, so water will, R will become carbocation. On that carbocation, water will come again or leave it. Simple, water will go, leave all this bakwas what we are studying, that we will know only. Over here, this carbocation will form, and now we have to see how this carbocation, after that what happened na, it will form alkene. I will dictate you with example. Dehydration na, water will go, plus will be there, then it will form alkene. But carbocation forming means rearrangement will happen. Understood na? First of all, dehydration of alcohol, removal of water from alcohol, formed carbocation. Rearrangement uses this, and over here there is a product coming, and that product is coming alkene. What is the product coming? Alkene. How it is happening? I will dictate you, don't worry about it. Now with example I will dictate, but before dictating it, first I will write important points. First important point is that there is a formation of, see, this is organic chemistry, but still I am trying to dictate you like a child student, so time will go too much, 34 1 hour like that. Don't get panic, you will watch in 1.5x speed if you know already all the things. First of all, there is a formation of carbocation. Second one, the rate is directly proportional to stability of carbocation. Rate is directly proportional to stability of carbocation, and this reaction is known as elimination reaction. This reaction is known as elimination reaction, and it is even mechanism. What is even mechanism? That we also see later, but formation of carbocation is there, even mechanism is there. Now as carbocation formed, so we will say, so there is a chance of rearrangement. If any back bonding coming, or any resonance stabilized coming, or if any hyperconjugation structure increasing, then it will do rearrangement. And last possible point is most stable alkene formed. Alkene formed, most stable alkyl is formed. So these are the important point regarding dehydration of alcohol. Now with one example, two example, three example, four example, as much as possible I will try to complete this dehydration of alcohol. First example, suppose I have taken here, over here OH, over here we have OH. Now I am saying कि we are going to react with H plus and heat. So what will happen? First of all, this OH minus will take H plus. After taking H plus, lone pair is there. This will become something like this, OH and H. Then you will say water is a very good leaving group. It will oxygen getting plus because they have given their lone pair of electron. So water is a very good leaving group. It will leave, and over here there is a formation of carbocation happen. Now this carbocation is less stable than this carbocation because over here 2 1 3 alpha hydrogen. Then you will do rearrangement. This hydrogen will go as a H minus. So 1 2 3. Over here plus will come. This plus has 1 3 3 6 2 8 alpha hydrogen. The first we have done rearrangement to find the alpha hydrogen. Then whatever be the position plus coming, just nearby that carbon is known as beta carbon, beta carbon and beta carbon. So this reaction is also known as beta H plus elimination. Sir, nearby plus, so up to now we are saying alpha carbon. No, in this part we will say beta carbon. That's it. So beta H plus elimination reaction. What happens? This beta is 1 degree, this beta is 1 degree, this beta is 2 degree. So one time you will remove the alpha hydrogen. From here you will remove the hydrogen as H plus. This will become minus. This minus is coming here. So that bakwas you will not see that much. Just understood it. How many beta carbon is there? On that position you will make double bond. So either this position or this position, any one place you will make double bond. One product and another product you will get here double bond. This double bond has 3 and 2, 5 alpha hydrogen, but this double bond has 3 3 6 3 9 alpha hydrogen. So which has more alpha hydrogen is known as major product, and which has less alpha hydrogen is known as minor product. Understanding what I am trying to say? So this is major product, this is minor product. Now if you want to write, the major alkene is also known as Sat-Zif or Z-Siv product, and minor product is also known as Hoffman product. Understanding? Suppose lots of example I will take, don't worry. Suppose I have taken another example, my favorite example, put a star over here. Suppose they have given the example like this. Over here we will have this, and over here we have OH. Now what happened? H plus and heat will attack on this oxygen will become water. After becoming water, I will do each and everything not to make you confused. Over here this will become OH and H. Oxygen is giving lone pair, so it will become minus. After that this water will leave from here, and after leaving what will happen? Sir, this will become like this, plus will come here, but rearrangement of expansion of ring condition is plus will be here, not here. So expansion to not happen, sir. Okay, sir, not happen. What happen? Rearrangement happen. If this plus will come here, then it will get more number of alpha hydrogen. How, sir? Check over here. How many alpha hydrogen it has? Sir, 2, 2, 4, 1. 5 alpha hydrogen. Now from here, if it will come here, this carbon has hydrogen, this hydrogen will go as a minus, this will become plus, this minus is coming here, so we will get 1 2 3 4 5. Over here plus will come, and hydrogen will justify. No need to see here hydrogen showing, no need. Automatically you will see it कि hydrogen is coming. Now first it is not in a situation to do ring expansion because plus is here, but after why I have done the rearrangement? 5 alpha hydrogen it has, 3 3 6 and 1 7 alpha hydrogen. So I have done rearrangement, but after just doing the rearrangement it will achieve the situation of doing ring expansion. So it will break from here, it will get negative, it will get positive. This total positive will attack over here. 5 carbon will become 6 carbon. Now as this positive is attacking, this 2 part is also coming here, and just nearby that part there is a plus sign, but again it will do rearrangement. Don't get panic. Why? Because here it will come, it will get over here how many alpha hydrogen? Sir, 2, and over here 0, 2 alpha hydrogen. Now again it will do rearrangement, it will do methyl shift, CS3 minus, this will come here, it will become cup alpha hydrogen 3 1 4 2 5 6 alpha hydrogen. So 6 alpha hydrogen. Understood this question? Very good question, very good question, very good question. What I have done, see it once again. First I have done alpha hydrogen increasing, after that ring expansion coming, again alpha hydrogen increasing. Now this is the final thing coming. In that final thing, this is beta, this is beta, this is beta. This beta is 2 degree, this beta is 1 2 3 degree, this beta is 1 degree. So we got 3 places double bond. Where and where? Sir, 1 you will get the double bond here, this and here double bond. 1 place you will get double bond here, sir. 3 places beta na here, and 1 you will get double bond here, sir. Here and here. Now check which double bond is more stable. This has 3 to 5 to 7. After double bond we have to check na alpha hydrogen. So 3 to 5 to 7 alpha hydrogen. This double bond has 2 1, and after that this 2 and 1 3 alpha hydrogen, and this double bond has 3 1 4 and 2 6 alpha hydrogen. So minor will become Hoffman, this is minor, and major will become, this is major, 2 2 4 3 7. This is minor, that is became Set-Zif product or Z-Zif, Set-Zif or Z-Zif. This is our major alkene, this is our minor alkene. It has 2 3 5 1 6. What about this, sir? No need to say anything. Understanding. So this much things you have to do for rearrangement. If you understood it, very important part it is. Now suppose next question, again very important question from my side. Suppose they have taken this over here OH, over here OH, over here this. What you will do now in this case? They have given, we have H plus and heat. What you will do? You will say, sir, there is a chance that we can remove any one of the hydrogen, any one of the water I will attack. Where I will attack? This place. Why I am not attacking this place, sir? This place why not attacking? Because this place attacking na will go and become 2 degree carbocation, but this place will become 3 degree carbocation. So I have removed from that place, means I am attacking this OH I am not touching, and this OH I am attaching 1 hydrogen. Because of that it will get plus sign. Now this water is a very good living group, it will leave and it will become plus here, and over here OH. Now it will do rearrangement. Why it will do rearrangement, sir? Because after doing rearrangement over here plus na, over here plus na, after doing rearrangement here back bonding stability coming, sir, back bonding. So how it will do rearrangement? From here hydrogen will go, this hydrogen will go as a minus, it will become plus, this minus will come here and become ringa chinga pinga, over here OH, and then it will become plus. Understanding? Because this plus is back bonding stability. After doing rearrangement we will check ki, sir, this is beta according to that and this is beta according to that. We will make 2 structure, 1 double bond here and OH here, and 1 double bond here and OH here. This has 3 3 6 and 3 9 alpha hydrogen. This has 1 alpha hydrogen. So this is the major product, this is the minor product, and major product is known as Set-Zif product or Z-Zif product. Minor product is known as Hoffman product. Now I hope you are understanding what I am trying to say, each and every part regarding this. Everyone, sir, say, sir, say, sir. Understanding or not understanding? Now some time, see what they will do. Same example. Now which types of answer they will give? Here plus will come first. After doing it, here OH. Now what it will do? Over here double bond to coming. Acha, see, leave it. From here I will dictate, otherwise you will get confused. Over here double bond will come, sir. Over here also double bond will come. You know that this is, this is also enol form. This is also enol form. So it will do tautomerism, and after doing tautomerism, it will become double bond O. And over here, it will also do tautomerism. After doing tautomerism, it will become double bond O. And how tautomerism will happen, that I have already taught you in tautomeric structure. So I will not dictate it over here ki how tautomerism will happen over here. Understanding the point, everyone? It means both are getting the same tautomeric structure. Both are getting the same tautomeric structure in tautomerism. But over here it is more enol content. Over here it is less. In the enol form, it is the minor, it is the major. But keto form, both are the same situation. Understanding the point? I hope you have understood it. Now I don't want to disturb you too much. 46 minutes already done. So I am going to upload this lecture. If you didn't understood it, check it and see it once again. Very important lecture, trust me. If you understood this, this will be the most important lecture for you all. Because from this lots of question is coming. Bye. Have a nice evening. Have a nice morning. Have a nice afternoon. Enjoy. Take care. Bye. Hello students. Very good afternoon, good evening, good morning whenever you are watching this lecture. Now, up to the last class, we have seen hydrocarbon part 5, and up to that I have completed you the rearrangement of carbocation and dehydration of alcohol, that is follow E1 mechanism. Now we are going to proceed the part number 6, and again I am suggesting you all, those who have not watched part 1 to part 3, part 4, part 5, part like that, don't see part 6. Don't increase my view of the lecture. Just see line by line. Trust me, if you will complete each and every part of organic chemistry, what I am teaching, not a single question will be going to be left from advance also. But practice needed. And after that, we will do lots of questions. Now, next part of the topic in part 6 is known as bimolecular elimination reaction. Bimolecular elimination reaction. Now bimolecular elimination reaction is also denoted as E2. It means we are going to see E2 mechanism. What we are going to see? E2, very important, and trust me, I will dictate you in such a way that totally new you will get. E2 means bimolecular elimination reaction. Now, first of all, we have to know what is the reagent can be used in this reaction. The first reagent used. The reagent used over here is base. Base is used. Which type of base? I will show you. Don't worry. Either example. Suppose they have written like this. MEO minus. Some place directly minus written. RO minus or PHO minus. Like that. Some place there is a minus on oxygen. Or they will write alcoholic KOH. Alcoholic means C2H5OH ethanol plus KOH. Or they will write alcoholic NaOH, like that written. Or some place written sodium. These are all reagent. Sodium alkoxide. Sodium alkoxide. Sodium alkoxide, like that. If they will write MEONA, sodium methoxide, or they will write MEO minus also, both have the same meaning. Sodium alkoxide, sodium methoxide, sodium ethoxide, like MEOK, potassium ethoxide, or MEO minus, because salt is always present in the charge, na, minus plus, so K plus will remove and MEO minus, like that written. Or some place they will write NaNH2, or some place they will write NH2 minus, or some place they will write like this, kabhi ONA. This can be also written as tertiary butyl BuONA or TBuOK. Like that they will write reagent, means these are the reagent used. This is tertiary group, na, to T I have written. And Bu means butyl, 1, 2, 3, 4 carbon to butyl, O, K or Na. Like that these are the reagent can be used in this cases. What happens after using this reagent? And trust me, totally new I will dictate over here. Have you never seen this part like this before? What happens? Suppose I will take kabhi, 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 kabhi. Now over here I have taken some base as a minus and heat. What will happen? This will go. And over here, just nearby that, it is beta, it is beta. Over here, no rearrangement. In this part, previously we are doing alcoholic dehydration of alcohol. We are doing rearrangement, ring expansion, because they will follow even mechanism. Over here, no rearrangement. Only one thing, over here, no rearrangement. It will also known as beta H plus elimination. Like that, beta H plus elimination. It is also known for even mechanism, and this is also known as beta H plus elimination. You will those who have watched it already, they know that from here or from here you will remove hydrogen. So one alkene will coming like this and one alkene will come like this. These two product will come. Understood? Now question arises. Ki sir, we got two product. Which one is major and which one is minor? So previously what you are saying, कि sir more number of alpha hydrogen, 6 alpha hydrogen, 2 alpha hydrogen, so this will be minor and this will be major. Now in this part you can't say like that. I will dictate you the trick how to find major and minor. Don't say with more number of alpha hydrogen. There is some different rules. What is that rule? I will tell you. Now for this, before going to know how to judge major or minor, first of all, I will dictate you some this is the most important point. First important point coming, ki how we are going to judge which one is minor and which one is minor. First question arises this. I will clear that question. Second part of the important thing is that one important points regarding E2 mechanism. One important point regarding E2 mechanism is that ki suppose I have given over here, I will write the point that elimination is done is anti-elimination. Which elimination? Anti-elimination. What do you mean by that? We didn't understood. Again, understood. This is the reagent. If you will take reagent, two types of product you will get at 1 degree and at 2 degree. First question I have arises that which one is the major product, that I will dictate later. But before that, some important point, elimination is done, but that elimination is anti-elimination. Means suppose I have taken one example. In that example, over here I have taken Cl on the base dash and CS3 on the base, and over here also I have taken one CS3 on the base. Now I will say ki react this with some base negative. I am reacting this. Now you will remove this Cl from here. Now this will be beta, this will be beta. Now check, you have to remove what? Hydrogen from here. Hydrogen is also on the dash, and here hydrogen is also on the dash because CS3 already present on the base. So once you are removing the Cl from dash, so another part you have to remove hydrogen from base, but both hydrogen is present on the dash, so no reaction. No alkene will form. Means sir, suppose some other example, sir. Suppose I will say this example. Over here Cl is here, and over here CS3 like this, and over here CS3 like this. I will take lots of example, don't worry. CS3 like this. Now you will remove this Cl. According to this beta, this beta. Here hydrogen is on the dash, so this hydrogen will not remove because Cl has been removed from dash. But over here CS3 on the base, on the dash, so hydrogen will be on the base, so this hydrogen will go. Yani if I will take base minus, only one side double bond will come. This CS3 will be as it is, this CS3 will be as it is, and double bond will come here because this hydrogen you are able to remove, this hydrogen you can't remove, so double bond will not come here. Understood the point? Suppose I will take another example. Sir, acha, base dash not given, sir. Something given like this. Ki over here we will have Cl, and over here we have CS3, and over here we have CS3. If base dash not given, then you didn't have to worry. Remove this Cl, and this is beta, this is beta. Base dash not given, then you will directly do ki over here CS3, over here CS3, one possibility double bond here, and another possibility CS3, over here CS3, over here one double bond. You didn't have to worry about ki which one is base, which one is dash, because base dash not mentioned. Not mentioned, then do normally. then no checking of anti or syn addition. Over here anti elimination, no need to check, but wage dash especially mentioned. Suppose I will take another example over here, and here I have given this CH3 and over there I have given Cl, and then I am doing with base minus. Over here nothing given. What you will say? Ki sir, this Cl will go, this hydrogen will go? No. Why? Because this hydrogen is on the dash. Over here nothing is given. So consider कि this hydrogen will go. It means one hydrogen over here is on the base, one hydrogen is over here on the dash. This hydrogen you will remove and you will get the product over here, CH3, Cl will go, double bond coming here. If not mentioned, then remove it. If especially mentioned, then check. If Cl is going from dash, then the hydrogen will go from base. If Cl is going from base, the hydrogen will go from dash. So I hope up to this you have understood what I am trying to dictate. Now this point I am going to justify how we will judge which one is the major one and which one is the minor one. Now major, minor. Acha sir, write this point what you have said about anti-elimination, that when Cl or any living group, Cl, Br, OH, any living group is dash position, then hydrogen base position, then only happen, and vice versa, If base dash not mentioned, then no problem, just do elimination, without seeing it, because they have not mentioned base and dash. If it is mentioned, then only we will check the anti-elimination. Now the next part of the topic, how to judge, what is the major product or what is the minor product. How we will judge it, कि which one is major and which one is minor. So before judging it, you have to know one chart I am going to draw, flow chart, and with that flow chart you are able to judge which one is major, and I will give example also, don't worry. It flow chart is that कि some place, this visible sir? हाँ sir, visible. Some place they will give you base. Now this base will be moderate base. What are the moderate base? Moderate base are like alcoholic KOH, like alcoholic NaOH, or like RONA. Or this base will be a strong base. What are the strong base? Like this bulky group type ONA or NaNH2. These two design, ONA or over here OKA, or tertiary butyl sodium alkoxide or potassium alkoxide, like that written, they are strong bases and they are weak moderate bases. Now if moderate base is there, so it has two things, either very good living group or that moderate base plus poor living group. How we will know that sir, कि which one is very good living group, which one is poor living group? So I am going to write poor living group. Poor living group are fluorine, OH, OR, NR3 plus and SR2 plus. If this group will be there, then you will say कि these are poor living group. Rather than that, anything coming, that is good living group. So 4 to 5 F, OH, OR, NR2, SR2. We will learn remaining everyone is very good living group. Now if moderate base given, not a bulky base, and over here two situations, either very good living group. What are very good living group? We didn't know sir, but poor living group we know that. If it is not there, then very good living group. Now over here, if very good living group coming, then except this, then in this situation the major product will be the major alkene. Major alkene means which has more number of alpha hydrogen. means more number of alpha hydrogen. That will be the major product. But if poor leaving group coming, or strong base coming, if poor leaving group coming as well as strong base coming, in this situation the major product will be decided by most stable. I will write that again. Understood? I have written one flow chart. In that flow chart I have told you how to judge major product and minor product. First of all, you have to check base. The base is moderate base like alcoholic KOH, alcoholic NO. Means not like this. Strong base are fixed. This or this. This I have only designed like this, na, K, tertiary butyl. If this is not there, then moderate base. In moderate base, check ki the attached over here group is not fluorine or not OH or not OR, like that. If these groups are not there, then it will be very good leaving group. If it is very good leaving group, then major alkene will be the major product will be the major alkene which has more number of alpha hydrogen. That will be the major product. But if F, OH, OR, NR2, SR2 or a strong base coming, in a strong base we didn't have to check poor leaving group. If any situation either poor leaving group or this will come, then means this moderate base plus poor leaving group or direct strong base, if it is coming, then in this situation we will say ki the major product will decided by negative. Means I will tell you what is negative. Means most stable negative after removing H plus. What do you mean by that? We didn't understood it. Just wait. I will write example and you are able to understood it. Suppose I will take one example. Just see it. This flow chart is very important. Over here Cl and over here I have taken alcoholic KOH. Check. Alcoholic KOH is a moderate base and Cl is not a poor leaving group. Then you will remove this Cl. This will become beta. This will become beta. Kabhi 1 and kabhi 2. This has 6 alpha hydrogen. This has 2 alpha hydrogen. This is simple major. This is simple minor. Any problem? No, sir. Acha. Next example. Suppose next example I have taken this Ore Pia Cl. In place of alcoholic KOH I have taken this ONA. Now again you will remove this Cl. After removing this Cl, here is the beta, here is the beta. What you are doing? From beta position you are removing hydrogen. Hydrogen removing, na, minus coming. Over here how it will happen? Beta position hydrogen is there. They will remove, minus will come. This minus is only forming double bond, na. Then only double bond here coming, na. Here minus will form after removing, double bond coming, then only double bond coming here, na. So here you will get negative. Here beta position you have to put negative. Simple logic. Now check which negative is more stable, sir. Means before getting the product, after removing Cl you will get negative here, you will get negative here. We know that negative charge over here plus I from both side, over here plus I from only one side. So this negative is most stable. It means you will get two product like this again, this and this, but this negative is most stable. So this will become major product and this will become minor product. Means on the beta position you have to put negative and check which negative is more stable. I mean, do you know that negative is not good for hyperconjugation. So now this time coming major, this time coming minor. But in this situation someone will ask what is the SETGIF product? So major product is SETGIF. If then anybody is asked what is the Hoffman product? Minor product is Hoffman. But major or minor product is not Hoffman or SETGIF. Major alkene, either this is minor product but still it is SETGIF product. Because over here minor product but alkene is most stable. Alkene most stable. Matlab which one is coming in more quantity? That is major, and which one coming in less quantity? But after having bulky group, most stable alkene coming less quantity, but less stable alkene coming more quantity. So more stable alkene is always SETGIF and less stable alkene is always Hoffman. Means Hoffman and SETGIF is not decided by major or minor. It will be decided by most stable alkene. Now understood what I am trying to say. Sir, now something coming means whenever bulky group is there, after putting minus you have to check which one is the most stable minus. Their alkene will be the major product and least stable minus is minor product. But whenever normal moderate group without poor living group or bulky group, then more alpha hydrogen you have to check. Not understood, sir. Some more example. Okay, don't worry. Suppose I have taken one example, kabhi OH over here, and then I have taken alcoholic KOH. Sir, alcoholic KOH plus poor living group OH is there. Acha. So in this part, first you will remove this. In this part, first you will remove this. Here beta, here minus coming, here minus coming. Which minus is more stable? This minus. So one product you will get alkene here, one product you will get alkene here. This is the minor product. This is the major product, major alkene. Major product means more quantity coming. But if then you are asking which is the set G product, the most stable is this one. Alkene is stable over here. It is least stable, but least stable is coming in more product. What I will do? More number coming, I can't do anything. Means still it is the ZG product or ZC product, and still it is the Hoffman product without any doubt. But if they will ask what is the major product in this case, you will write this. Understood? Means suppose I will take one more example. Kabhi Cl, and I am reacting with AgF in presence of RO minus. What you will say? First reagent is AgF, second reagent is ROF. AgF is Schwarz reaction. And Schwarz reaction will do halogen exchange method, and once it will do halogen exchange method, what you will get? First Cl will remove and F will come. Then second reagent is RO minus. Acha sir, poor living group and alcoholic moderate base, minus here. So which minus is more stable? This minus. So this is the major alkene, major product. This is the minor product. This is the major product. This is the minor product. But most stable is this one. Least stable is this one. So most stable is ZGF and least stable is Hoffman. Yani major minor can be decided by different way, but ZGF and Hoffman can be decided by only with the most stable alkene. Understood this part? Lots of example I will take, but I am going to write one more example, that ZGF or ZCF product, ZGF or ZCF product. Understood this part? Not understanding, again message me. These won't be affected either major or minor product. This will always most stable alkene. Either most stable alkene is produced in a minor quantity, no problem. Same for Hoffman. It is always least stable alkene. Now problem is that least stable alkene coming, major product, more quantity coming, that is not the problem. But Hoffman and ZG will be decided like this. Now suppose I will take some more example. I have taken one example like this, and over here I will take this bulky group, or I will take this I have taken. What you will say over here? Suppose Cl, bulky group minus. This minus is more stable. So over here we will get the ringa chinga pinga, one double bond, and ringa chinga pinga. This is the major product. This is the minor product, but still it is Hoffman. Either major is there Hoffman, but because least stable, and it is ZCF. Understood? So I hope you all are able to understood what I am trying to dictate, but still I will take from my convenience some more example. Suppose I have taken one example over here, and here H, here CS3, here H, here dash, suppose dash Cl, and I am giving ETO minus. Acha sir, over here moderate base plus not a poor living group, it will go. Now over here you will get negative here and you will get negative here, because over here base dash not given. So you will draw two structure. One structure will be CS3 here, because anti na, so base and dash anti coming na. So over here one double bond here, and another possibility one double bond here. Now check which one has more alpha hydrogen, that is the major product. and which has less alpha hydrogen, that is the minor product, it has 3 to 5 to 7 alpha hydrogen. It has 1 and 2 3 alpha hydrogen. Over here, because it is, we are not going to judge according to the basis of negative charge, so we will say it is the major product and it is the minor product. This time major product is also Setjif and minor product is also Hoffman, because minor product is least stable alkene and major product is most stable alkene. So I am not judging the Hoffman and Setjif according to major and minor. I am judging according to most stable alkene and least stable alkene. Understanding. Haan sir, we are understanding it. Suppose I will take some more example writing, I will write and we will see what is going to be happen over here. Some more question I have written over here. See, now anti-elimination. This Cl will go. Acha sir. This is dash. This is also dash. Over here nothing written. No waste dash. You can remove this H. From here what you will get? Upside not be touched, because this is not coming anti-elimination. Over here double bond will come. Understood na? Where not written anything, no need to check. Acha. Over here hydrogen is on H dash dash. From dash Cl is going. No reaction. Because hydrogen has to remove from anti. Cl is also going from dash and both side hydrogen not present. But CH3 on waste means hydrogen is remaining other place, that is dash. Over here, if only alcoholic KOH given, so any one Cl will go and it will become CH3. It will become CH2 double bond CH2 Cl. Only this. But hydrogen is more, to remove it. CH Cl 1 2 3 4, only one Cl, but alcoholic KOH plus high temperature given, both Cl you will remove and you will get CH triple bond CH. If alcoholic KOH given, one will remove one Cl, one will remove one Cl, CH2 double bond CH and Cl, and this will remove another Cl. So overall you will get CH triple bond CH. But same NaNH2 given over here with Cl, but over here alkyne, so it will do acid base reaction. Why? Na plus, so one hydrogen will go from here, it will become minus, Na will attack, it will become Sc triple bond C and A. Then CH3I, it will break as minus plus, it is already plus minus, then this will come here Sc triple bond C CH3. So NaNH2 has two parts. Either it will do acid base reaction or it will remove Cl. If it is only one Cl is there, then it will do elimination type. If Cl is not there, some alkyne group is there, then it will do acid base reaction. Na will come, salt will form. Then CH3I will break like this, minus plus. Plus will attack over here because it is already minus. So plus will attack here, minus will attack here. So outside you will get NaI, but byproduct is not that much important. This is all about E2 by molecular elimination reaction. Now I am going to see E1CB, then electrophilic, aromatic, substitution, like that I will tell you, and slowly more one part after that. I will hope that this chapter will be completed. Very important chapter and very big. Those who will understood this chapter very properly, for them very interesting part. Now E1CB, E2 mechanism done. Everyone will see it very properly. Not getting, again see, if you have watched up to that, then you will take my number 9267937718. Those who have seen up to that, for them WhatsApp number. Any doubt you can ask, please ask. I have already told lots of time that I am not here to become superstar. I am just here to teach to known students. Some places I have already taught, but there I am not right now. So a student is not able to get me and they are getting confused. Sir, new teacher is not teaching good, like that. So I just want, and those who I am teaching, for them revision will be there. So please ask any doubt. Now, sir, okay sir, we understood. Every video you are saying that. I know that every video I am saying, but I didn't know na ki which video you are watching. If you are watching every, for you it is a boring, but not watching, it is a new for you. Okay sir, understood. Don't do bakwas. Now teach. Okay. Now E1CB is unimolecular conjugate base. Unimolecular conjugate base elimination reaction. Elimination reaction means, sir, E means elimination, 1 means unimolecular, CB means conjugate base. First important point, used while aldol condensation. Sir, what is aldol condensation? When I will teach you aldehyde, ketone and carboxylic acid, over there I will dictate you what do you mean by aldol condensation, and over there we are using this mechanism. Second important point, it will happen in the presence of poor living group. Acha, what are the poor living group I have written? Sir, fluorine, OH, OR, NR3 plus, SR2 plus. These are the poor living group. It will happen in the presence of poor living group, SR2 plus, as well as, and electron withdrawing group. Electron withdrawing group means minus I effect. What do you mean by that? Sir, give some example. Suppose I will take kabhi over here double bond O. This over here OH, over here this. Now you will take alcoholic KOH. Reagent is same as E2. Now you will say, sir, alcoholic KOH, either it will do E2 or it will do E1CB. OH will go, this will become beta, this will become beta, and this is electron withdrawing group. Okay. It will not do E1CB, E2, it will do E1CB. One minus will come here, one minus will come here. This minus is normal, but this minus is stable by minus I effect. C double bond O will show minus I effect. I have already dictated. So this minus is more stable. So what you will say, sir, two product is coming. One product, double bond O, here, and double bond will be this place on this beta. So double bond will coming here because of the most stable negative charge. Another product we can form, yes, but that is the minor product. Over here you will get double bond, but this is very minor. In E1CB only you have to form major. If you want to form minor, you can form it also. Understood? And not major, it has 3 alpha hydrogen, it has 2 alpha hydrogen, it has 3 alpha hydrogen, 2 alpha hydrogen, more stable. SETGIF and ZSIF will be same, and it is Hoffman. Over there no confusion, but this time E1CB. Understood? This is simple, but when there is no poor living group, then no E1CB. Suppose electron withdrawing group is there, but poor living group is not there, still no E1CB. Understood? So this is all about E1CB mechanism. More example no need to check because very less type of question coming. Only one place it is going to be used, that is aldol condensation. Now after this, everyone, I have already dictated, but still I am going to dictate. I have dictated you Finkel-Stein reaction. I have told you that Finkel-Stein reaction is also known as halogen exchange method. Halogen exchange method. What I will do in that? First I am taking some Rx, X will be Cl or Br. We are forming it by using free radical mechanism. Then I will take NaI in presence of acetone. This is acetone. Or you will say NaI in presence of dry ether. Anything you will take, what will happen? Ri will form and NaX will form. Any problem is that? Yes. Now on this same basis, why I have dictated it, this will come in alkyl aryl also, detail I will do there, but what I have dictated is like this same one more reaction is there, that is known as dehalogenation reaction. Simple like Finkel-Stein reaction, dehalogenation reaction. Now what is dehalogenation reaction? And on this basis, on Saturday exam, those who know that to whom I am talking about, on Saturday there is a test. On that test question is also coming. Suppose I will give like that. Acha, one more thing you will write about dehalogenation. Like that I have told you na, whenever you are doing the E2 mechanism over there, anti-elimination, it is also anti-elimination, not sin. Anti place you have to remove, means suppose sin anti not given, no problem. Suppose Cl is there. Suppose you will take NaI in presence of acetone, or you can take Zn and heat. Anything you will take. What will happen? This both, first understood, not or, don't take. Suppose you have taken NaI plus heat. What will happen? NaI plus heat will convert that into I and I. Then Zn and heat will take both the I and making double bond. So first it will do, sorry, by mistake I have written one, correct. Both double bond, and over here means first it will do Finkelstein. After doing Finkelstein, it will remove both the I. No need to do Finkelstein directly, you can remove it if Z and I given heat or not, or you can means suppose I will give C, over here Cl, over here CS3, over here Cl, over here CS3. What you will do? You will remove this two. Anything given, either given NaI plus acetone, double bond, or given Zn plus heat. Sir, what is the difference between the bottom one and top one? Sir, top one, only one X is there. Over here, 2X is there. So you will remove all the two. What you will get? C, double bond C, CS3. Remaining place, hydrogen you will put. What is the required hydrogen? Don't see. Acha. Suppose someone will give C, Br, and H is there. Now, they will give NaI in presence of acetone or Zn in presence of heat. What you will do? All Br you will remove. 2 Br is giving one bond. Another 2 Br will give another bond. So what you will get? CH, triple bond CH. Means only one halogen is there. Then it will do, you will do halogen exchange method. Means I will come and Cl will go. But more than one halogen is there. Both halogen will go. If 2 going, 1 double bond. 4 going, 1 triple bond. Like that it will come. Acha sir, you have written anti-elimination. What do you mean by that? Suppose I will take one example over here. What is that example? Kabhi. Over here 1 Cl. Over here 1 Cl. Suppose I have taken like this. Over here 1 Cl. Like that I have taken. And I am taking NaI in presence of I, in presence of acetone or Zn in presence of heat. Thus it will form double bond? No sir. Cl over here. That it will form double bond? No. It will do only halogen exchange method. I will come and over here I will come. After that double bond will not form because anti both are present on the Veg position. One will be Veg, one will be dash. Suppose I will take this example. Over here Cl and over here suppose Br in presence of NaI and acetone or Zn plus heat. First I will come. Over here also I and over here also I. Now these two I will go outside and it is forming double bond. Because one is Veg, one is dash. One is Veg, one is dash. Understood the point? Suppose I will take one more example. If Veg dash not given, then no need to check. Simple you will do. Previous example I have done like that only. Suppose over here Cl. 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 And I am giving NaI in presence of acetone or Zn and heat. What you will say? This Cl and this Cl will go one double bond. This Cl will go one double bond. This Cl and this Cl will go one double bond, and you will get a aromatic compound, that is benzene ring. If Veg and dash not given, no need to see anti-elimination. If Veg dash is given, then you will see anti-elimination, and this is all about elimination reaction. After that I will teach you electrophilic addition reaction. If it will take more 2 part, no problem, but I will try to complete it slowly, so you will not get nervous and confused. Too much big video I don't want to give. Okay, so bye, have a nice afternoon, have a nice evening, have a nice morning whenever you are watching this lecture, and I hope you are understanding. Not understanding, as usual you can ask the question on the WhatsApp number. Bye. Hello, very good afternoon, good evening, good morning whenever you are watching this lecture. Now up to the last lecture we have seen hydrocarbon number part 6. Now we are going to start the next part of the hydrocarbon, part number 7, that is called electrophilic addition reaction. That is called electrophilic addition reaction. Now after this, not in this lecture, one topic I will teach, where I will teach you what is electrophilic aromatic substitution, EAS. That is also very important, but I will not have to discuss that part here. Now I have written electrophilic addition reaction. Before starting this topic, first of all, we have to be aware कि what is electrophile. What is electrophile? Electrophile is also always denoted as E plus. E plus means those have vacant orbital. And those have vacant orbital, they want what? Electron, means electron deficient. Vacant orbital or electron deficient species. Those are electron deficient species is known as electrophile. Electrophile is denoted by E plus. Those who are electron deficient, what they want? They want some electron. So electrophile is a electron lover. Like suppose I will write CH4 plus, it has vacant orbital, it acts as an electrophile. BF3, it also has a vacant orbital, acts as an electrophile. CCl3, it also has a vacant orbital, acts as an electrophile. AlCl3, vacant orbital, acts as an electrophile. So these all are electrophile. Electrophile means those who have vacant orbital or those who have less number of electron deficient, they wants to take the electron, so it is electron lover. Now we are going to see electrophilic addition reaction. Now there are two types of electrophile. There are two types of electrophile. Now two types of electrophile means sometime you will get H plus as an electrophile and sometime you will get Cl plus as an electrophile. Whenever H plus is coming electrophile, does it has any lone pair present in that? No. But chlorine has 1, 2, 3, 4, 5, 6. One electron gone. Chlorine has 7. 1, 2, 3, 4, 5, 6, 7. This electron going outside, then only plus will come. Means one electrophile has no lone pair. And one electrophile has lone pair. Lone pair is there, but vacant orbital is also there. So has lone pair. Whenever no lone pair, they will form carbocation. Arey sir, what you are saying, we are not getting it. Just listen it. And those who didn't have lone pair, those who didn't have lone pair, carbocation. And those who have lone pair, they will form non-classical carbocation. What is that, sir? We didn't understood anything. Just understood it. Hydrocarbon part number 7. In that, first of all, I am going to dictate you electrophilic addition reaction. It means some electrophile will be there. They are going to be added to some reaction. That is called electrophilic addition reaction. In that, there are two types of electrophile. One electrophile, H plus, means it also has less number of electrons. Cl plus, it also has some electron less. It is also electrophile. It is also electrophile. These electrophile, those have no lone pair. Whenever they will go on attacking, they will form carbocation, and those have lone pair, they will form non-classical carbocation, is denoted by NCC. What do you mean by that? Just understood it very, very properly. Suppose I have taken alkene, C double bond C, something is attached over there, and I am attacking one electrophile over here which does not have lone pair. Suppose I am attacking, first what happened? It will break as a heterolytic cleavage. It will become minus, it will become plus. This electrophile will attack over here after seeing the minus. What you will get? C single bond, over here a plus, C this, and over here some electrophile is coming. Acha. After attacking of electrophile, what is the things formed? Minus to justify the electrophile. But what is left? Plus. Plus on carbon. It means we can write whenever no lone pair is there, so there is a formation of carbocation. And if carbocation formed, so in the part number 5 I have dictated you कि carbocation will do rearrangement. So there is a rearrangement may occur. If there is a possibility of rearrangement, it will do rearrangement, as well as these types of things will do syn as well as anti, both addition. Either it will do syn addition or it will do anti addition, both. It is not only one. Either it will attack from the same side or from the opposite side. Not either, both side. it will attack as well as from the same side as well as from the opposite side. It means no lone pair, electrophile coming, attacking, and the remaining compound left is carbocation. Rearrangement happens, everything happens. That I have already dictated you how the rearrangement happened. But when electrophile has lone pair of electrons, then what happens? See, over here, suppose we have C double bond, C ringa chinga pinga hinga, and they are attacking with electrophile, and they has lone pair of electron. Now again it will do heterolytic cleavage. It will get plus, it will get minus. Sorry, it will get minus, it will get plus. Now over here C over here plus, single bond over here minus, and minus will be attracted by electrophile, and this electrophile has lone pair. It will say कि भैया don't get worried about the plus, and it will give the support to the plus also. Means sir, electrophile attacking, and this electrophile has lone pair. This lone pair will form one coordinate bond over here to justify the electrophile. It will form something like this: C over here electrophile, lone pair, it is forming here, and this types of formation is known as non-classical carbocation. Now anything has to attack this side, so already electrophile is giving support, so anything will attack from this side, then only this electrophile will go. So whenever non-electrophile has lone pair, it will always do anti-addition. It will always do anti-addition. Whenever electrophile does not have a lone pair, it will do syn and both addition. Whenever electrophile has a lone pair, it will do anti-addition, and as well as it will form non-classical carbocation, because carbocation is forming, but this electron pair is giving the support to remove the plus sign and saying take my support. Whenever any nucleophile will come, I will again go from here and I will allow the nucleophile to attack. Understood? It means here I can write the point that this formed cation is non-classical carbocation, and if non-classical carbocation, then no rearrangement, because rearrangement is not possible, as well as anti-addition is to be done. Which addition I will do? Anti-addition. So I hope you understood about the non-classical carbocation and classical carbocation. Now I will show you some questions regarding this. Once you will revise, not understood, don't panic. Suppose I will write HBr, it will break. What you will get? H plus. You have to check only electrophile. Br coming minus. So H plus is the electrophile. And this electrophile has lone pair. No sir, no lone pair. So what it will form? Carbocation or non-classical carbocation. So it will form carbocation. Acha. Suppose I have taken HCl. What is the electrophile over here? H plus is the electrophile. It also has no lone pair. It will also form carbocation. Acha. Suppose I have taken Br2. Br2 means Br. It will do heterolytic. One will get minus, one will get plus. Now Br plus coming. Br has lone pair. And as it has lone pair, it will form non-classical carbocation. Understood the point? And in this two part, carbocation coming, to rearrangement. If possible. Over here, no rearrangement. If possible also, I will give lots of questions. Don't worry about it. Suppose I have taken Cl2. It will become Cl. It will break minus plus. What is the electrophile? Cl plus. It also has lone pair. It will also form non-classical. It also has no rearrangement. Understanding the point? Suppose I have taken NaCl. It will break Na plus Cl minus. Na plus. It does not have lone pair. If no lone pair, then carbocation. And carbocation means rearrangement. Suppose I have taken Hg, or this I have taken H plus H2O. It has H plus. It does not have lone pair. Then carbocation. Then rearrangement. Suppose I have taken HgOAc, OAc. That is HgOAc whole twice. Now it will break from here. And what you will get? Hg plus. And mercury has lone pair. It has lone pair. If lone pair, then non-classical carbocation. Non-classical carbocation means no rearrangement. Understanding what I am trying to say? According to the reagent, we have to judge. Now, I am going to give some question, and line by line we will solve that question what I am going to give regarding classical carbocation rearrangement and non-classical carbocation. Now some question is there. We are going to solve that question over here. What is the electrophile? Br will break like this. It will become minus and plus. This electrophile has lone pair. Yes, it will break minus and plus. It will form non-classical carbocation. Over here first Br will attack on the minus. This plus will attack and they will give the support over here as a coordinate bond. Then Br minus will come and it will try to attract from this side. So what we will get? C over here Br, then single bond C over here Br. So it will do anti-addition. Don't get confused and nervous. Understood this part? Yes sir, we understood it. Now next part. It will break minus plus. It will break plus minus. This time electrophile does not have lone pair. No lone pair. No lone pair means first H will attack over here. Ringa, chinga, pinga, hinga. Here H. Now this plus is here. This plus will do rearrangement. Means rearrangement. H will go from here as a minus. It will go here and it will become plus. Means ringa, chinga, pinga, hinga. Plus will come here. And on this plus, this Br will attack. So we will get the product Orepia. And over here Br. Hydrogen I am not showing. If your choice, you can show it or not, because in bond line structure hydrogen showing is not important. Automatically hydrogen will be seen. So I understood. I hope you understood. Non-classical carbocation, no rearrangement. Classical carbocation means normal without lone pair. No rearrangement with lone pair. No rearrangement. So over here don't see Br, see electrophile. Now next question. It will be H plus OH minus. हाँ sir, that we understood. यानी H plus OH minus electrophile has no lone pair. No lone pair means carbocation. Carbocation means rearrangement. It will break like this. It will get minus. It will get plus. On this minus, hydrogen will attack like this, like this, like this. Here hydrogen will attack. No need to show the hydrogen. Okay. Hydrogen bond line structure automatically connected. Now this is the situation that is created for ring expansion. So it will break ring expansion. I have dictated a very good part. Over here plus and minus. This will come here. So it will become 6-member ring. 1, 2, 3, 4, 5. 6-member ring. Plus is here. And this total is coming nearby that plus. Again it will do any rearrangement? No sir, it will not do any rearrangement. So what is the product coming? Over here, how many alpha hydrogens? Sir, 2 and 3, 4 alpha. No, it will again do rearrangement. From here, hydrogen will go as a minus. So it will become ringa, chinga, pinga, hinga, linga. Plus will come here because it has 3 to 5 to 7 alpha hydrogen. More alpha number. I have already dictated very detailing. So why I will do it again? So over here, what will happen? This is there, and on this position OH will attach because OH minus is there. So I hope you are understanding what I am trying to say. Haan sir, we are understanding it. Now concentrated H2SO4 or simple H2SO4 is given. It will do sulfonation. Sulfonation means attack of SO3H. How sir? First it will break as H plus HSO4 1 minus. H plus HSO4 1 minus. After that it will break minus plus. Rearrangement is not possible. On this minus hydrogen will come. This is the plus. Now what will happen? This plus what will attach? Over here SO3H. One second. We have SO4. SO4H. means overall, what will attach? HSO4, 1 minus. From this, one oxygen is going outside. How will it will happen? That we will tell you in electrophilic aromatic substitution. Don't worry about it. This topic will come. I will dictate you. Just you have to understood. Lots of bakwas you will not do. Just you understood that it will do sulfonation and SO3H will attack. Just you will focus right now. Don't get confused. So it will attack SO3H. What it will attack? SO3H. And the color of SO3H is white precipitate. What is the color? White. Again, I will dictate this part again. Don't get confused. The color of this compound is white PPT. Means whenever concentrated H2SO4 given, it will always allow the SO4H to attack. Sorry, SO3H to attack. Okay. Now SO3H will attack, means it will always do sulfonation. In the case of sulfonation, SO3H will attack. What will attack? SO3H. So over here, first to hydrogen will attack over here, and there is no possibility of rearrangement, so it will do attack on the positive. If rearrangement is there, then only rearrangement, na? And in sulfonation, SO3 will attack. And concentrated will always give sulfonation, but dilute will not do sulfonation. It will do H plus H2O, means H plus OH minus. Understood this difference? It means in the case of sulfonation, SO3H will attach, concentrated H2SO4, SO3H will attack. And in the case of dilute H2SO4, OH minus will attach. So what will happen? It will go minus, it will go plus. There is no possibility of rearrangement. Here hydrogen will come, here OH will come, product will come. Understood the point? Means first of all, carbocation forming, that carbocation does not do rearrangement, and OH will attack. Means concentrated SO3 has to attack, SO3H, and dilute OH minus has to attack. Understood this point? I have dictated you one reaction over here for Br2. For this you will write one point that I am going to write on the bottom, because notes is not going to become good. That point is, whenever you are reacting Br2 in presence of CCl4, it has a brown color. Which color? It has a brown color. But when it will do electrophilic aromatic addition, electrophilic substitution, I will write total. Whenever, what is the heading I have written? See, na, don't get confused. Electrophilic addition reaction. Whenever it will do electrophilic addition reaction, then there is a fading of brown color. There is a fading of brown color. So when bromine brown color faded, you will say it is doing electrophilic addition reaction. Suppose I will take some more example, like we will have CH3 C triple bond CH, and I am reacting first with HCl and second with HI. What will happen? In the first case, it will break minus and plus, over here plus and minus. Again, no carbocation is there, no lone pair is there on the electrophile. The non-classical carbocation will not form. CH3 C triple bond will become double bond H. Over here hydrogen will come, and on this plus there Cl will come direct. Now again Hi is coming. What is coming? Hi. So Hi will break as H plus I minus. It will become minus and plus. Again there is no lone pair on the electrophile, so no non-classical, directly CH3 C Cl over here. I will attack because already Cl on the bottom, single bond CH HH2 and one more H will attack, and this is the final product. Understanding the point? Whenever electrophile has lone pair, then it will form non-classical carbocation. No lone pair, then it will form classical carbocation. Some more example, suppose I will take. The example is CH3 C triple bond CH, and I have written H plus H2O. It will give H plus OH minus. Now see over here very properly. It will become minus, it will become plus. On the minus hydrogen will attach, and on the plus CH3 C double bond CH, over here H, over here OH. But you will see this is enol, and enol is less stable than keto. Stability, only 3 situation is there whenever it is more stable. Already lecture is there, I have uploaded in isomerism. You will see over there. Now it will do tautomerism, and after doing tautomerism, what will happen? It will become CH3, C, over here single bond, CH3, over here double bond, AC, tone will come, and this topic is known as hydration of alkyne. Hydration of alkyne, H plus OH forming enol, but after doing tautomerism it will form keto. And how tautomerism happens already dictated. Suppose I will take some more example. Over here I have taken CH3, after that CH2, after that CH double bond CH2, and I am reacting with Cl2 in presence of CCl4, Cl2 in presence of CCl4. What will happen? Cl will break into two part, 1 plus, and this time electrophile has lone pair. This time electrophile has lone pair. What will happen? CH3, CH. It will break as minus plus, CH2, over here CH, single bond CH2, over here Cl will come, and this Cl will support, so minus will not come, and then after that Cl minus will attack, so this will break from here, CH3, CH2, CH, over here CH2, Cl, and over here Cl, it will do anti-addition. Which addition? Anti-addition. Why anti, sir? Because in the syn partner same side already chlorine is giving their lone pair to form the bond. Na? It will break. So someone will have to attack on the top side, then only it will break. Understanding the point? And in stereochemistry of hydrogenation, I have dictated you cis is positive, trans is negative, syn is positive, anti is negative. So that concept I am going to use the stereochemistry of hydrogenation, hydrocarbon. In that part, hydrocarbon I am saying na, everyone will see line by line, then only you are able to understand what I am going to teach. Otherwise total confusion will come. Okay, girls and boys? Suppose we are going to some example like this. Over here it is the structure of trans. Trans is negative. This will do anti-addition. Negative will become positive. Means this CH3 I will write on the top. Then bottom CH3 I am writing here. This side H and H, Br will attach on the same side. Why it will attack on the same side? Because minus will plus, and it will do syn addition, hydrogenation. Over here it is cis. Cis is positive. It is anti-addition. Anti-addition is negative. Again over here CH3 on the bottom CH3. This side H, so this side H. One time Br attach this side, so one time Br attach this side, and whenever anti-addition is coming, they are forming their mirror image. Remember? Yes sir, CH3. Over here H, Br, these two are enantiomers, and their pair is racemic mixture. This is optically active, this is optically active, and racemic mixture is optically inactive. Total detailing I have done every time, I will not do that. Now over here what will happen? First Br will break, and over here Br will break. This Br will break as a minus plus. Electrophile has a lone pair. It will break as minus plus. What will happen? CH3, C, double bond, CH. Over here Br will come. This Br will give the lone pair to form non-classical carbocation. Then Br minus has to attack. It will attack on the anti side. Over here no cis trans. So we will not see syn anti. We will just attack it. CH3, C, double bond, CH. Over here Br, over here Br. Someone will say, okay sir, take one thing, again attack Br2 in presence of CCl4. What you will do? Again you will break it from here, minus, plus. On the minus side Br will attack, so CH3, C, over here Br, over here CH. One Br is already there, another Br is coming. This plus they are protecting. Over here plus coming na, this plus they have protected. Then over here Br minus is also there, and Br plus is also there. Br plus already attacking. Now Br minus will attack over here. What you will get in this case? You will understanding now what I am doing. CH3, C, CH, this side Br, this side Br, this side Br, this side Br. Means this Br, anti. And this Br and this Br anti-addition. Like that we have done, but all Br, so not looking like that. So I hope you understood syn addition and anti-addition. Now we have to know three reaction. One is called acid catalyzed hydration. Acid catalyzed hydration. Their reagent is H plus H2O, or that is also called H3O plus. H3O plus. Now, second is called hydroboration oxidation. Hydroboration and oxidation. Short form it is written as ACH, and long form short form it is written as hydroboration oxidation. Their reagent is HBH2 whole twice plus THF. THF means tetrahydrofuran plus NaBH4 plus not NaBH4, sorry, plus H2O2 plus NaOH. This will do hydroboration, this will do oxidation. And third reagent is oxymercuration and demercuration. Short form OMDM. Oxymercuration, demercuration. Their reagent HgOAc whole twice plus H2O plus NaBH4 plus NaOH plus H2O2. These are the reagent we will use. You will say they will follow Markovnikov rule. They will follow anti-Markovnikov rule, and this will follow Markovnikov rule. Markovnikov rule means, you already know, I hope 90% those who are studying up to that, they already know Markovnikov rule means, suppose over here double bond CH3 CH double bond CH2. Suppose I will take H plus OH minus. Markovnikov rule means more hydrogen will get H and less hydrogen will get OH. Anti-opposite. But understood, Markovnikov rule, instead of knowing this bakbas, once understood कि Markovnikov rule will do SN1 mechanism. Anti will do free radical. And in hydrocarbon, I will dictate you कि what is SN1, what is free radical, each and everything regarding free radical, which free radical is more stable. But just understood it, what I am trying to say. Suppose I have taken one example like this. In that part, I have taken acid catalyzed hydration, or I have taken oxymercuration demercuration, or I have taken hydroboration oxidation. Now understood the point very properly. Over here, in case of acid catalyzed hydration, what is the electrophile? Electrophile is H plus. In this part, what is the electrophile? Hg plus. It means it will form carbocation. It will form carbocation, and it will form non-classical carbocation. In anti-Markovnikov rule, we didn't have to check that. Free radical, we didn't have to check that. Only in the case of SN1, we have to check that. It means over here, it will break minus plus, and this plus will do rearrangement. So over here, this minus will get hydrogen. After rearrangement, this will come here, and then hydrogen, no need to write, OH will come. This is the product. But oxymercuration, demercuration, first what happened? This minus will get Hg, and after getting Hg, it will form non-classical carbocation. Because of that, this plus will go, and then on the opposite side, OH minus will attach. It means in the case of over here Hg, and after some time this Hg will also go, and over here hydrogen, over here OH, and this coming means whole oxymercuration demercuration is also giving H plus OH minus. But before giving H plus OH minus, it is giving Hg plus, and Hg plus is non-classical carbocation. It means in this case no rearrangement. The basic motto of dictating this is this. In this case there is a rearrangement. Understanding the point or not understanding? Yes sir, understanding. It means oxymercuration demercuration no rearrangement, but acid catalyzed hydration rearrangement. Free radical to no problem. Anti-Markovnikov rule, it has CH2, it has CH. More hydrogen will get OH, less hydrogen will get H. Over there we didn't have to think about carbocation or all the things, because it is hydroboration oxidation, that is free radical mechanism. Suppose one more example I am going to take. ringa, chinga, pinga, here double bond, and I am taking B2S6 in presence of THF, H2O2 plus NaOH. What will say? Sir, anti-Marconi-Cops rule. Over there we didn't have to think. Over here it has CH2, it has CH, more hydrogen, double bond will break, more hydrogen will get OH and less hydrogen will get H. That's it. Understanding the point? Everyone? Sure short? Acha. Suppose I have taken like this, ringa double bond, and I have taken oxymercuration, demercuration. What you will do? Ki sir, oxymercuration, demercuration will do anti-addition because of non-classical carbocation. So what will happen? Over here double bond will break. It will also form a stable carbocation, but no rearrangement. So over here it will break, it will get plus and minus. This plus is more stable because of hyperconjugation. Why are not making plus? You understood this? That much so you know this. Up to this you are studying the chapter called hydrocarbon. Over here OH will come, over here H will come without any doubt. Understood? Everyone? Suppose they have given HBO, hydroboration oxidation. What you will get? This opposite. Where OH coming, over there H will come. Where H coming, over there OH will come. This is anti-Marconi-Cops rule, free radical mechanism. So I hope you all understood this electrophilic addition reaction. After that I will dictate you thermodynamically controlled product and kinetically controlled product, and then Kucherov's reaction, then hydroxylation and glycolization. After that free radical mechanism, then non-bromosuccinamide reaction. Like that I will try to complete as fast as possible, but I don't want to make the topic very big to make you confused. Understood the point? Yes sir, we understood it. Okay then, bye, have a nice day, enjoy, take care, stay home, stay safe. Yes, very good evening, good afternoon, good morning, whenever you are watching this lecture. Now we have proceed to the hydrocarbon number part 8, and today in this part either it will take 2 hour or 3 hour or 1 hour. How much time it will take? I don't want to make more part 8 headache will come na. So I will try to complete each and everything over here for hydrocarbon. Then I will dictate you electrophilic aromatic substitution. Next part of the topic, and again I am warning you all, those who have not seen my previous topic, please see it, then only you will watch this lecture. Other than that, you will go to some other lecturer and you will see there, because I can't change your taste na, ki where you will like the lecture to study. It is your personal choice. But if you are studying from my lecture, you have to see each and everything from the beginning of hydrocarbon, because you are not able to understand directly watching part number 8. Two types of things is there. One is called KCP, one is called TCP. What do you mean by KCP? KCP means kinetically controlled product, and TCP means thermodynamically controlled product. So we have two types of product. One is kinetically controlled product, one is thermodynamically controlled product. What do you mean by that? How we will know that? Where we have to apply this? Don't worry about anything. If Prabhat sir is here, why to worry? Sir, dialogue not suited. Okay, no problem. Now KCP, the product can be formed fastly. The product can be formed fastly. I will dictate question also how to understood it. And kinetic thermodynamically fastly, as well as over here you will use, over here you will get least stable. First write important points, don't get confused. Sir, what you are writing we didn't understood. You just write it. Alkene is kinetically controlled product. Least stable alkene is kinetically controlled product, as well as it operates at low temperature. What is the low temperature? Like minus 80 degrees Celsius. Very low temperature. Acha. Just important point write. Don't get nervous and confused. Thermodynamically product, the the product which there is most stable alkene. The product formed here is most stable alkene, and it will operate at high temperature. High temperature written or simple room temperature written. Sir, we didn't understood anything what you are saying. Just write it, the points I will dictate you. One important point you will write from my side, कि if temperature is not mentioned, if they have not mentioned any temperature in question, suppose in the question they have not mentioned temperature, it is high temperature or low temperature, then considered room temperature. Room temperature, and the product formed is thermodynamically controlled product will formed. Thermodynamically controlled product will form, but especially they have mentioned कि na bhaiya, when low temperature mentioned in the question, then kinetically controlled product will formed. Means what is the bakwas I have done, I am going to dictate you. The bakwas is simple. In thermodynamics part 8 we have seen electrophilic aromatic addition. Electrophilic aromatic addition we have seen. After that we have started not aromatic, electrophilic addition reaction, not aromatic, so addition not possible. Electrophilic addition reaction. Now we have started part number 8, kinetically controlled product and thermodynamically controlled product. Kinetically controlled product is the least stable alkene. Thermodynamically controlled product is the most stable alkene. Achha, second, it operates at less temperature, it operates at room temperature or high temperature. If temperature is not mentioned, then always form thermodynamically controlled product. If temperature is mentioned, then always form kinetically controlled product, ki minus 80 degrees Celsius, minus 90 degrees Celsius, like that. Means sir, make us understood by the question. Suppose over here I have given kabi and less. Now either they will give this reactant as excess or not given excess, you didn't have to worry. Excess is always worry about the reagent, not the reactant. Excess is always affected by the reagent. Reactant excess, not excess, is not any problem. Suppose you have taken over here HBr in presence of CCl4, one equivalent. Now reagent is not excess. Now over here I will say that this reaction will form carbocation. So which carbocation you will say? Sir, if you will break this over here positive, and if you will break this over here positive, this positive is 3 degree, this positive is 2 degree, and 3 degree positive is more stable. So what you will do? You will break this. It will get minus, it will get plus. It will get plus, it will get minus. This plus will attack here. What you will get? Ringa, chinga, pinga. Over here hydrogen coming. This hydrogen either you will represent or not. This is coming. And over here plus. Now see in this question, does they have mentioned any temperature? No sir, temperature is not mentioned. If temperature is not mentioned, then you will do resonance over here. What you will do? Resonance. Achha, someone will say, sir, if I will not do resonance and directly over here I want to attack the point over here without doing the resonance, I want to attack the Br over here directly, you can attack, no problem. What you will get? Ringa, chinga, pinga, hinga, Br over here. But without doing resonance you are attacking. This is kinetically controlled product. This is not thermodynamically controlled product. Understood the point? So over here temperature not mentioned, so you can't draw it. If temperature is mentioned, then after forming carbocation, just try to attack the Br. But over here temperature not mentioned, then do resonance. After doing resonance, pi sigma positive, what will happen? Over here double bond will come and plus charge is coming here. And on this plus charge, you will attack the Br. Over here Br will come, and this is known as thermodynamically controlled product. I hope you understood what I am trying to say. If temperature is not mentioned, then try to make the most stable alkene. See na, this alkene has only one alpha hydrogen, but this alkene has 3, 3, 6, to 8 alpha hydrogen. So this is most stable alkene. So whenever temperature not mentioned, try to draw, first make positive, and it is always happen whenever two double bond. One double bond, no, then the normal previous case. Two double bond is there, and that two double bond has a possibility of doing the resonance. So first break this compound in such a way that you will get the most stable alkene. After getting most stable alkene, if temperature mentioned minus 80 degrees Celsius, make this product. If temperature not mentioned like this, then do resonance and make this product. That's it. No more extra bakwas. Understood what I am trying to say or not understood? Acha sir, this is the only things. Yes, that's it. Okay. It means from here we will say it is the most stable alkene, and most stable alkene is thermodynamically controlled product, and it is least stable alkene, and least stable alkene is kinetically controlled product. I will draw it, otherwise you will think, sir, why you have cut it? I have not cut it, I will draw it again. To those who will understand, 80 degrees Celsius, where the plus will come, ringa, chinga, pinga, here plus coming, double bond, here we will attach Br. That's it. So this is kinetically controlled product. This is kinetically controlled product because temperature is minus 80, least stable alkene, and this is thermodynamically controlled product, most stable alkene. So I hope you understood this. Means from here I will again going to write some point. Point is just for bakwas to make you understood. If you are getting least stable, and this will happen only whenever two double bond, and that two double bond will do resonance with each other. Okay sir. Least stable alkene forming means kinetically controlled product, and this will happens at low temperature. And at high temperature or room temperature, what you will do? At high temperature or room temperature, what you will get? Thermodynamically controlled product. Over here, what you will get? Most stable alkene. Sir, this point you have already written. I want to write it again. Is there any problem? Acha, no sir. Understood? But don't say कि both will form kinetically and thermodynamically. No. That point I have drawn it over here. Both product, but right. But only one compound is formed. It is not like that you will form both kinetically controlled product and thermodynamically controlled product. Only one compound is formed. Why? According to temperature. If temperature is not mentioned, then you will draw thermodynamically. If temperature is mentioned, then kinetically. Don't try to tick both the answer. No. Moe will happen. Understood this? So this is all about thermodynamically controlled product and kinetically controlled product. Sir, take some more example. More example is not there. Only one fixed example is there, and that is more than enough. But if you want to take, I will take one more example. Kabhi. Over here, kabhi, and this, not here, here, and here I will make. Now, only two double bonds, sorry. Three double bond is not there by mistake. Over here double bond, and over here double bond, it is coming here. And now, if I will say, I will do this HBr in presence of CCl4. Temperature not mentioned, and HBr in presence of CCl4, either I have written low temperature or I have written minus 80 degrees Celsius. What you will do? First you will try to break the alkene in such a way that will form most stable carbocation. So plus, because this will breaking will give 2 degree, but this is giving 3 degree. So what will happen? It will minus. Over here it will break H plus minus. From here H plus will attack here, and you will get ringa, chinga, pinga, hinga, linga, double bond. Over here this, and over here hydrogen coming. Sorry. Over here hydrogen coming. Hydrogen no need to show, but I am showing just to not confused. Now over here temperature not mentioned. So this plus will do resonance? No sir, not possible. Pi, sigma. So over here you will attack Br, and same situation. Understood na? Means if resonance is not possible, then don't think that much. But if I will change this question, kabhi, here, and here. Now I will say draw it. Acha sir. Over here I have given 2 point. One I have given HBr in presence of CCl4 and HBr in presence of CCl4 minus 80 degrees Celsius or low temperature. You will break it plus, you will break it, how, what you will get, minus plus most stable carbocation. Over here H plus Br minus plus will attack there, ringa chinga pinga hinga linga double bond here, plus will come here. Over here you will get hydrogen. Now it is temperature not mentioned, it will do resonance. After doing resonance, what you will get, sir, pi sigma positive, positive will come here, double bond will come here. Now on this positive the Br will attack, ringa chinga pinga hinga linga here, and here Br will attack. Understood the point? But in this case don't see it. You got it? Just try to draw the Br over here. No need to do resonance. Hydrogen is already there. I am not showing it. Hydrogen has been attacked. That will be as it is. It's not here. Sorry. Hydrogen will be here. So I am not removing hydrogen because bond line structure we are not showing hydrogen. So kinetically controlled product. This is thermodynamically controlled product. Understood? But some cases what they will plan, acha, this they will give excess and this they will give only one equivalent. In this part this also they will give excess, this it will give one excess given or not, don't worry, but this always given one equivalent. But if they will change the question, what is the changing of question? They will say ki, sir, I will take this, and over here I am taking HBr in presence of CCl4 and this I am going to take excess. Then what you will do? Then product will change. First what you will do? First you will break it, minus plus. Now you will get one time hydrogen is attacking here, I am not showing it. On the minus hydrogen will go, plus hydrogen will go here without any doubt. Okay, so I am not going to show that bakwas. Okay sir, plus minus this will go here. Acha, one plus coming here. Acha, another you will do resonance. What will happen? Double bond coming here, plus coming here. Now in this situation all the possible product will form because HBr in excess, it will form kinetically controlled product. Over here temperature is not the matter and it will form thermodynamically controlled product. This is thermodynamically controlled product, this is kinetically controlled product. But if they will ask major one, you will write this major one, this minor one. Why? Because temperature is not mentioned. If they will mention temperature minus 80 degrees Celsius, so this will become major and this will become minor. But you have to draw all the possible product. Now I hope you understood what bakwas I am trying to do for thermodynamically controlled product and kinetically controlled product. Today I will go slow. I have to complete the whole hydrocarbon that I want to teach over here. Okay, just see it once. Now I am going to dictate you the another part of the topic. Now we are going to see the next part. So I hope thermodynamically controlled product and kinetically controlled product you have understood up to now. Then next part of the topic is called hydration of alkyne. Just listen it very properly. It is also one of the most important part. Hydration of alkyne. Now you already know कि hydration means what? Water. Hydration means addition of water. You are saying na कि we are getting hydrated, means we have drink water, and alkyne means CN H2N minus 2. Now we are going to attack the water on the alkyne group. Achha, over here no space, so I will go to start here. Now in hydration of alkyne, suppose I have taken CH3C triple bond CS. Too many things I have taught you already. In hydrocarbon, again I am saying, if you are not able to understand one time, please try to see second time. Those who will complete the topic called GOC, isomerism, hydrocarbon, electrophilic aromatic substitution and Grignard reagent, for them this whole organic chemistry is very easy. Now over here, suppose I have taken H2 plus H plus H2, hydration of alkyne. We know that it will follow Markovnikov's rule. It have a SN1 mechanism. What will happen? Sir, from here this triple bond will break. It will get negative, it will get positive, most stable carbocation. On this negative, H plus will attack. CH3, C double bond CH, over here H, and this H2O will break as H plus OH minus. This minus will attack over here, it will get OH minus. Means before attacking OH minus, I will write over here, it will get carbocation, and after that OH minus will attack and it will become CH3, C double bond CH, over here H, over here OH. After that, you know that this is enol form. Whenever we will have enol form, we will do tautomerism, and tautomerism I have already dictated in very detailing. With the help of tautomerism, we will get CH3, C double bond O, CH3. So in the hydration of alkyne of propine, we got acetone. Always we have to do tautomerism. But over here you will see, we have seen na, कि whenever we have triple bond plus or double bond plus or single bond plus, we know that triple bond plus and double bond plus is not good. These two are highly unstable. These two are highly unstable. This is stable. And over here in hydration of alkyne, what is the problem coming? There is a positive charge coming on the double bond. So over here, whatever be the product you are getting, na, it is a poor yield. Means over here, but this does give poor yield. This will give poor yield. Why it will give poor yield? Because it has carbon double bond as a plus. Carbon double bond as a plus is highly understood. What I am trying to say, my dear boys and girls, highly unstable. I am saying कि hydration on the notebook, so it is true. Whenever question will come, you will do it. But over here, what is the problem coming? कि on alkyne, there is a, after breaking it, minus plus coming, plus is coming on the double bond, and plus double bond is highly unstable. The carbocation on double bond and triple bond is highly unstable. So it will give poor yield. What it will give? Poor yield, not good yield. So to overcome this problem, to overcome this problem, we are using one reaction, and the name of the reaction is called Kucherov reaction. Answer will be same. Answer no changing. First H will attack, OH will attack, Markovnikov's rule, after that tautomerism. Each and everything will happen same, but something I will do so that plus charge will not come on the double bond. Means the name of this reaction is Kucherov's reaction. The name of this reaction is Kucherov's reaction. What is Kucherov's reaction? Kucherov reaction is saying that you are getting a problem of positive charge on double bond. Do one thing, you will change your reagent, and in place of reagent, what you will take? You are taking H plus H2O, that you will take, plus as well as 1% HgSO4 you will take. Once you will take HgSO4, what you will get over here? Hg plus, and this Hg plus is electrophile, and this electrophile has lone pair, and whenever electrophile has lone pair, it will form non-classical carbocation. Last to last class video you have seen that. Acha sir, what you will do with that? You will take, sir, CH3, C. Answer will same, but product will give good yield. First you will take 1% HgSO4 and H plus H2. Over here HgSO4, don't take H plus, directly take H2O. What will happen? First of all, it will break minus plus. Now plus is not stable. What it will do? CH3, C double bond CH. Hg plus is there. Hg is plus is there. Now Hg plus will take, Hg plus will go to minus. Once it will go to minus, Hg will come here. Means Hg plus, it will attack on minus sign. Hg has a lone pair. This lone pair will support over here, and because of this supporting, it will form non-classical carbocation. After that, you will use H2O. H2O will give H plus OH minus. Now Hg will go outside, CH3, C, double bond CH, over here H, over here OH, because plus is here, minus is here. Hg will go side. After that it will do tautomerism. After tautomerism we will again get CH3, C double bond O, CH3, that is acetone. Means previously also getting acetone, here also getting acetone, but after using 1% HgSO4 we are getting acetone in that non-classical carbocation, and because of that it will give very good yield. Understood what I am trying to say? So just to get a good yield I am trying to use the topic, and the name of the topic is called Kuch-Ropes reaction. So sometimes they will ask to hydration of alkyne, how I will make them good yield. So by using the reagent as HgSO4. What is the name of this reaction? Kuch-Ropes reaction, because Kuch-Rop is a scientist who has given the concept of this reaction. So this is all about hydration of alkyne. Now we are going to see the next part of the topic, and the name of the topic is called hydroxylation or glycolization. Hydroxylation or glycolization. Hydroxylation or glycolization. Hydroxylation or glycolization. Over here. Now, first, what you will take over here, you will take alkene. Suppose I will take one alkene as cis, or I can take one alkene as trans, or I can take normal alkene. Your choice. I have taken one alkene as cis, one alkene as trans, or I can do normal alkene, anything. That is my choice, what I want to do. Anything I will do. Over here, when you will take cis, cis is positive. Cis is positive. Trans is negative. Hydrogenation, stereochemistry. And over here, no positive, no negative. If I will take any one of the things from here, what I will do? I will react this alkene with first reagent is 1% KMNO4, and that is alkaline medium. Understood? This part I am going to dictate you very properly, and that is happens at 0 degree Celsius, that is at cold temperature. Now it will do syn. This process will do syn. So in the case of cis and syn, what is the product coming? Anti-product. Because syn product, because syn is also positive. Syn is also positive, cis is also positive. In case of trans, what is the product coming? Sir, anti coming, minus and plus. Plus, minus and plus. Minus means anti is the product. I will draw that answer also, just write it first. Now, after that, first reagent we have used 1% KMNO4 or alkaline medium at 0 degree Celsius. This reagent name is called Bayer's reagent. Bayer's reagent. The name of this reagent is Bayer's reagent. After that, I will take another reagent, and the name of the reagent, not name, the reagent is OSO4 in presence of Na2CO3. Now it will also do syn addition. It will also do syn addition. Acha, over here, for this part, in this reaction, simple product. Simple product. No any bakwas in that. Ki syn anti, no. Over here, no cis trans, no bakwas. It will also do syn. What you will say? Ki cis plus syn is positive. It will give positive, that is syn addition. Trans plus syn is negative. It will give anti-product. Over here, no bakwas. Simple product. Simple product. I will dictate the answer also. What do you mean by that? Third part we will have is the reagent, and the name of the reagent is metachloroperbenzoic acid plus H2O2 it will do anti-addition. It will do anti-addition. Anti-addition arrow I will not make. If cis is there, I will make arrow over here. If you are able to understood it, okay. Not, then see it properly. If cis is there, then it will form plus minus minus, that is anti. If trans is there, minus minus, anti is minus, so minus minus plus, that is syn is there. And over here in this case, simple product. In this case, simple product. I will write all the answer, don't worry, I am just making a flow chart. What is the structure of meta-perchlorobenzoic acid? Everything I will dictate. Everyone will write all this bakbas what I have written. After that I am going to draw line by line one product for each and everything. What is the product coming, what is the answer coming, what is the bakwas, like that. So this is all about hydroxylation or glycolization. Now see, suppose I will take cis and I am going to do Bayer's reagent. Bayer's reagent will do cis positive. Bayer's reagent, syn addition, that you have to learn, positive. So it will give CH3, this CH3 and this CH3 I have written. Over here, syn means all will give H and OH. All will give H and OH. So OH, OH, H and H. And this is meso compound. Meso compound has rule. What is the rule? 2 chiral center must be there, and that is optically inactive because of plane of symmetry. That's it. Done. No problem. Suppose same Bayer's reagent I have taken, and I have taken Bayer's reagent, but in that Bayer's reagent I have taken trans. Trans is negative, Bayer's reagent is positive. It will do anti-addition. So CH3. One place HOS this side, to another place HOS this side, and you can form their mirror image. What you will say? CH3, HOH, HOH. In this part you will say, sir, this is enantiomers pair, enantiomeric pair. This is also optically active, this is also optically active, but both combining to form racemic mixture, and racemic mixture is optically inactive compound. Understood? So now one I have dictated for Bayer's reagent every place. This will also give H and OH. This will also give H and OH. So you have to attack H and OH like cis and trans. So I hope you have studied up to now hydrocarbon. Sir, third part what I will do? Simple. It will break minus plus, over here H, over here OH, in all the cases without exception. Without exception, all the cases HOH, 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 HOH. That's it. You didn't have to think that much, because syn anti we will think whenever there is a cis and trans. So in this part if I have dictated you, you are able to do each and everything. One Bayer reagent I have dictated, remaining OSF4. If I will take OSO4, same product, because say both will give HOH, same coming, both are syn addition. But if I will take meta-perchlorobenzoic acid, opposite will happen. Trans will give this, cis will give this. So I hope, because anti-addition. So I hope you understood it. That much big example I didn't have to give to make you understood. Okay. This part written means those who are seeing the video clearly, they will able to understood it. Now, question arises, when 1% KMNO4 is used, it is very good oxidizing agent. OA means oxidizing agent. And this part, if you have any confusion in this part, what bakbais I have done, so you will message me on 9267937718, and this number is only for those students who has reached up to this. Those who have not reached, they will not know that. Acha, okay. Oxidizing agent, very good oxidizing agent. So to make it less oxidizing agent, use 1% KMNO4. If I will take too much KMNO4, then it may be OH will convert into something different. So 1% KMNO4 we have taken. Meta-chloroperbenzoic acid has a structure. Benzene is there. Over here C double bond O, 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 H. On the meta position there is a chlorine. तो मेटा क्लोरो पर बेंजोइक एसिड, मेटा क्लोरो पर बेंजोइक एसिड. नाउ understood na this part, sir? But bakwas, I have written this chart diagram. Understood everyone? See once. If you download directly the notes, it maybe you will get confused. But if you will see it, it is easy for you to understood. Now, over here, next. It is also used for taste of unsaturated hydrocarbon. What do you mean by that, sir? Hydrocarbon. Taste of unsaturated hydrocarbon means if you will use the reagent 1% KMNO4 plus alkaline cold, in cold condition, alkaline cold condition you will use, so this KMNO4 has purple color. What is the color? Purple color, and purple color will change to brown. So what you will say? Ki sir, yes sir, means suppose you have taken alkene and you are reacting with purple color. After reaction, the KMNO4 of purple color will change to brown. So what you will say? Yes sir, whatever with the reactant we have, they must be unsaturated hydrocarbon as reactant. Why? Because only unsaturated means double bond is reacting na KMNO4. So whatever with the reactant you have taken, unsaturated it is. Why? Because purple color is changes to brown color. But if purple color not changed means reaction not happen, then the reactant is not unsaturated, because it is not double bond or triple bond. It means the reactant is saturated, and reactant is saturated means the reactant is alkane. Understood the point? What the bakwas I have done, each and everything. Any confusion anyone have? No sir. So this is all about this hydroxylation or glycolization. Syn anti you have to learn, and in hydrogenation I have already dictated you all the part of syn anti. One example also I have taken to dictate you the things. So this is all about the part called hydroxylation or glycolization. Now we are going to see the next part of the topic, that is called Keras effect or peroxide effect. Just see it once, I will clear the remaining part. So I hope you have understood. First, kinetically and thermodynamically control product. After that, you have understood hydration of alkyne, then Kucherov's reaction, then hydroxylation and glycolization. After that, I will try to complete each and everything in this lecture only. It is good because too many parts came. Na? So either it will be 1.5 hours, don't worry about it. Okay. Now, next part of the topic, and please, I am requesting all the time, those who are studying hydrocarbon with me, please complete it very properly. Trust me, you will never ever find this much good lecture before. This is not challenge. I don't know. More talented teacher than me in this world. But from my side, I am trying to dictate you something very good so that you will get interest in organic chemistry. This chapter only you have to do hard work. Now, we have Keras effect or peroxide effect. I am saying na, you are studying in class, sir, anti-Markovnikov's rule, peroxide, that only I am going to dictate. Keras effect or peroxide effect. How the peroxide will look like? PH C double bond O whole twice, or it will be written as PH C double bond O whole twice O2, or it will be H2O2 peroxide, or it will be R2O2, R means alkyl, or it can be written as Keras effect, or it can be written as peroxide effect, or it can be written as PO. PO means peroxide effect. Anything written, they have the same meaning. Understood? Now see what will happen over here. See it very properly. Whenever I have dictated you one topic, just I am going to revise you. Ringa, chinga, pinga, and over here I have taken HBr in presence of CCl4. What you are saying, it will do Markovnikov's rule. Markovnikov's rule means SN1 mechanism. Acha, one more part you have to know, कि खेरास इफेक्ट, peroxide effect will always follow free radical mechanism. Which mechanism? Free radical mechanism. So sir, what is the example just now you have written is not free radical? So simple, you will break it from here, you will get minus, over here plus, plus, minus. If rearrangement possible, you will do rearrangement. No rearrangement, Br coming here, H will come here, product is coming. Now suppose in the same reactant I have taken over here the another reactant like HBr in presence of CCl4, and I have taken pH whole twice O, and now what you will say, it will follow anti-Markovnikov rule, and you are doing opposite. In Markovnikov rule, you are means Markovnikov rule means rich get richer, rich hydrogen gets richer. What do you mean by that? Rich hydrogen gets richer. Rich hydrogen gets richer. Rich hydrogen gets richer means over here with this carbon how many hydrogen? 2. With this carbon how many hydrogen? 1. So which has more hydrogen, they will get more hydrogen. Which has less hydrogen, they will get Br or Cl. Over here opposite will happen. Ringa, chinga, pinga. Here Br will come. Here H will come, opposite to Markovnikov's. Acha sir, how it is happening that I will dictate, don't worry. Acha. What is the reason behind it? I will give the mechanism. Suppose I have taken HCl in presence of CCl4. Acha. Over here, either peroxide C6H5CO whole twice, pH means C6H5CO whole twice, or without peroxide. In both the cases, it will do Markovnikov's only. It will not do anti-Markovnikov's. It means Markovnikov's rule is only and only applicable. Markovnikov's rule is only and only applicable whenever we have HBr and CCl4. If HCl is there, no anti-Markovnikov's is only and only applicable with HBr. Peroxide effect is only with HBr, not with HCl, not with HI. Over here what happens again? It will do Markovnikov's rule. Here H will come, here Cl will come. Our reason started why this cola very D. So see mechanism. Mechanism. Why only HBr is doing, why it is anti-Markovnikov's, why opposite, everything. In mechanism, what I have taken peroxide. Peroxide is what? PHCOO whole twice. That can be written as PH C double bond O, O C double bond O, PH. Now, what will happen first? It will break with any one place. Sorry, C double bond O na, 2 times O na. Over here, C double bond O, O like this. Over here, C double bond O, O like peroxide na, 2 times O na. Here 2 times O na. Haan sir, understood sir. Now, it will break from here. Same electronegativity. It will get dot, it will get dot. What you will get? 2 moles of PH C double bond O, O dot. I have the use of only 1 mole. From here, what will happen? This will come here. So this will break from here. It will do resonance and forming CO2. And from here you will get pH dot plus CO2. And you are able to produce the free radical. First you have produced the free radical. After producing free radical, what you are taking? You are taking pH dot plus HBr. HBr will also do free radical dot, because कहते हैं ना कि संगति के साथ, मतलब खरबूजे को देखकर खरबूजा रंग बदल लेता. आफ्टर सीइंग द वाटरमेलन, अदर विल आल्सो बिकेम वाटरमेलन. You have seen the chameleon, lizard will change their color. Similarly, after seeing the free radical, it will also make free radical. Now, in presence of CCl4, what will happen? pH will get the free radical of hydrogen and forming PHH plus Br dot will be left. Achha. These two process of mechanism of free radical is known as chain initiation. This process is known as chain initiation. It means in the initiation I have got Br dot. First I have got Br dot. After getting Br dot, we will go with the second step, and the name of the step is chain proposition. propagation. In chain propagation, what happens? Now alkene will come. And alkene will see Br dot. So it will also try to do free radical. Oh, homolytic cleavage already dictated. Here dot, here dot. Now you have two options. What is the option? Ringa, chinga, pinga. You will attach Br over here and dot you will leave. Or you will attach Br over here and dot you will leave. After leaving it, check which free radical is more stable. So this is this free radical more stable. Why? Because 2 degree free radical. It is most stable. It is least stable free radical. It is least stable free radical. So this will not form. So this will not form. This will not form. We have to make the most stable free radical. After that, what happened? This will form most stable free radical. Br is there. Then again another mole of HBr will come. And it will break from here as dot and dot. This dot will attach over here. So you will see it is happening like anti-Markovnikov's rule. Opposite to that, and Br dot will happen, and these two process will continue. These two process will continue until all product not converted. Until all product coming. Up to which all will not convert like the product. This process is going on, and this process is known as chain propagation. So understood the mechanism, sir. Now you understood one thing, that first important point understood. Propagation step, na? These are the very important for advanced purpose also. Propagation does require exothermic reaction. This propagation is exothermic reaction. This propagation is exothermic reaction. But in case of HI, you will break it, H dot, I dot, it will form I2. It will not form I dot. Why? Because I dot is stable without any doubt. But it will do I2. Question arises, why? Why? Because HI is very good reducing agent. It will reduce other and oxidize himself after removing the hydrogen, and it will form I2. So peroxide effect or Kheras effect is not possible with I. Means overall you have to know that peroxide effect is only applicable with HBr, but I am dictating what is the reason. With I, why it is not possible? Now check. Those who are talented student, those who wants to see it very, very properly, they will understood it. Not understood, again I have given the number, check that and try to do it. Now in case of HCl and peroxide, why it will not do anti-Markovnikov's rule? Means only HBr and peroxide will do Markovnikov's rule. HI is not doing, reason I have given. HCl is also not doing, and the reason is in case of HCl, when it will break dot dot, what you will get? Cl dot. Cl dot is formed, and once the Cl dot is formed, Cl dot is not stable at all. Not stable at all. And it is a endothermic process. It is a endothermic reaction. But what I have written? Propagation. Why endothermic? Because it is not want to break it. It is not stable. Not stable means not want to break it. So you have to give some heat to break it. So endothermic process. But propagation is exothermic. But it will do endothermic. So it will also not follow the peroxide effect, means anti-Markovnikov's rule. So I hope you understood about Kheras effect, Markovnikov's and anti-Markovnikov's rule. Some more topic is left. After that, chapter will be completed. I am also very happy with that. Now we are going to proceed the next part of our topic, and we are proceeding to complete this. This page I am leaving because I am going to start the next part, that is called bromosuccinamide and bromosuccinamide. Don't get confused in succinamide. I will dictate you three structure. Just understood it. First structure, this. Just see it very properly. Sir, we are seeing it. How many times we will say? Acha, okay. Double bond O, NH2, double bond O, NH2. This is known as succinamide. I have written the heading N-bromosuccinimide, but it is known as succinamide. Acha. Another structure. Ringa, chinga, pinga, hinga, linga, bhatinga, matinga, chatinga, double bond O. Over here N, over here H, over here double bond O. This structure is known as succinimide. And when you will remove hydrogen and attach double bond O, N, Br, over here double bond O, this is known as N-bromosuccinimide. So don't get confused. Whenever as a teacher I am taking the interview of a new teacher, I am asking what is the structure of N-bromosuccinimide, they will draw this structure, succinamide structure. They will not do it. Okay, I am not blaming any teacher. Everybody is very much talented. I am only less talented, but just saying. So succinamide, it is succinimide, succinimide and bromosuccinimide. Now what is this? N-bromosuccinamide or succinimide is also written as N-bromo, NBr, or sometimes it is written as NBS. Most commonly you will see NBS, N-bromosuccinimide. Whenever NBS is given, what is given? NBS. You have to write one important point, then I will write example, topic done. It follows free radical mechanism. It follows free radical mechanism. Acha, first important point. N-bromosuccinamide, succinimide, not succinamide. N-bromosuccinimide will follow free radical mechanism. Second important point, Br will be substituted on allylic or benzylic position. It means it is only applicable for, it means NBS and bromosuccinimide is only for allylic and benzylic. Other place, this will not valid. What do you mean by that? Sir, suppose I have taken ringa, chinga, pinga and I am writing NBS. Where is the allylic position? Sir, this free radical is allylic position. So what will happen? On this position, Br will come. That's it. Suppose I have taken another example. Benzene ring, over here CS3. What is the benzylic position? This is the benzylic position. What will happen? Benzene ring, CH2, Br will come. Suppose I have taken ringa, chinga, pinga, hinga. Over here double bond. What are the allylic position? This also, this also. So over here NBS will give two product. Ringa, chinga, pinga. Here Br will come, or ringa, chinga, pinga. Here Br will come. Both allylic position. But you already know that this free radical is more stable, this free radical is less stable. So this will become major product and this will become minor product, but it will attack on both the allylic position where it is found. It means for this we can write more stable free radical is most stable product, that is major product. More stable free radical is the most stable product, that is the major product. Acha sir, this also done. And bromosuccinamide is done. Okay sir. Now next part of the topic. I thought I have dictated too many things in this, so I will take one more part. That part I will dictate you ozonolysis, Birch reduction, and after that hydrolysis of carbide and aromatization. Okay, So one more part. I hope otherwise you will get too much nervous and confused. 1 hour already about to complete. So I don't want to make it 4 to 5 parts. Means more 1 hour I will do, so you will get bored. Too many things I have taught over there. Okay, sir. One last part. This is the part number 8. Well, last part. After that I will not dictate. 9th will be the last part. Okay, then bye. Have a nice evening, afternoon, morning, whenever you have seen this. Enjoy. Last part. After that I will complete it. Bye, bye, bye. Hello, very good evening, good afternoon, good morning, whenever you are watching this lecture. This is the last part of hydrocarbons, sir. From a long time you are saying last part, last part. No, seriously, this is the last part of hydrocarbon. And over here we are going to see the first part of the topic, and the name of the topic is called ozonolysis. What is ozonolysis? First we are going to see what is the reagent we will use in this case. There are two types of reagents. See, one thing, O3 plus ozone, CCl4 plus Zn and H2O. O3 plus CCl4 plus Zn and H2O. Again, don't get nervous and confused. Zn and H2O. Or in place of Zn and H2O, you can use PPH3 and H2O. PPH3 means triphenyl phosphate and H2O. PPH3 structure this: one benzene ring, phosphorus, another benzene ring, phosphorus, another benzene ring. This is PPH3 phenyl. Or you have SME2, Me matlab methyl, and H2. Either you can use this reagent. If this reagent will be used, then you will say that this reagent is the reagent of ozonolysis, and this ozonolysis is known as reductive ozonolysis. Ozonolysis. This reagent is reductive ozonolysis. Don't worry what is reductive, oxidative. I will dictate everything. If the reagent O3 plus CCl4 is there, after that Zn plus H2O or PPS3 plus H2O or SME2 plus H2O is there, then you will say this is reductive ozonolysis. Another part, if the reagent is only O3 plus CCl4, Zn is not there, PPS3 is not there, SME2 is not there, or H2O is there, or H2O2 is there, then this reagent is known as oxidative ozonolysis. Reductive means RO. Reductive ozonolysis. RO. Reductive ozonolysis. And this is known as oxidative ozonolysis. And this is denoted as OO. Means O3CCl4 is common. If Zn, PPS3, SME2 is there, then reductive. Not there, then oxidative ozonolysis. This is the reagent used in the case of ozonolysis. Now we are going to see line by line how the ozonolysis process will be happened. Now suppose first example, CH2 double bond CH2, and if I am saying it is reductive ozonolysis, what will happen? Where the double bond? Break it. Now check, this will contain hydrogen, this will contain hydrogen, so both will form aldehyde, SCHO, SCHO. Don't worry about it. Over here, oxidative ozonolysis means whenever you will break double bond, on that double bond you have to check कि before double bond and after double bond, whatever with the carbon is there, if that carbon has hydrogen, then it will become aldehyde. If that carbon does not have hydrogen, then it will become ketone. In reductive ozonolysis. In oxidative ozonolysis, what will happen? First it will convert SCHO, SCHO. After that, you have to check the compound that contain H, H. This is the structure. Over here, C double bond O, H, H. How many H is connected with C double bond O? That will converted into OH. Means C double bond O, OH, OH. H will converted into OH. C double bond O, OH, OH. And this total compound is converted into carbon dioxide. I will dictate, you don't worry about it. Carbon dioxide. So it means you will get 2 mole of carbon dioxide. This is not the product. SCHO, SCHO, these all are not the product. Product is 2 mole of carbon dioxide. Means in oxidative or reductive ozonolysis, simple. You will have to break the double bond, and if adjacent to the double bond carbon is there, that carbon contain hydrogen converted into aldehyde. That carbon does not contain hydrogen converted into ketone. In oxidative ozonolysis, how many number of H is there that is attached directly with C double bond O, that will convert it into OH. And if 2 OH is coming on the C double bond O, converted into carbon dioxide, 1 OH is coming, not converted. It means in oxidative ozonolysis, number of hydrogen connected to C double bond O will be converted to OH. If 2 OH, then carbon dioxide. If only 1 OH, as it is. Don't convert it as it is. That's it. Now, acha sir, do some more question. Okay sir, I am going to do. Suppose I will take another example. I have taken H3C double bond, H3C single bond, CH double bond, CHO, CH2. Over here, reductive ozonolysis, and reagent I have written. I am writing reductive, oxidative. It may be they will write reagent. So you have to judge which one is oxidative, which one is reductive. After writing this, I will say I will break this. It has hydrogen. Yes, it has hydrogen. Both will convert it into aldehyde. CH3, C double bond OH plus HC double bond OH. Now over here, reductive, answer done. Oxidative, HCH3C double bond O. How many H is there? 1. So OH. Plus how many H is there? 2. 2H. So 2OH. OH. Over here OH, and that will be converted into carbon dioxide. Over here no conversion, as it is. Understanding now? It means over here if I will write one thing, single carbon with 2 hydrogen converted to carbon dioxide, because only single carbon will be there, then only 2 hydrogen. If more than 1 carbon will be there, no 2 hydrogen. Acha, suppose I will take another example. Ringa, Chinga, double bond Hinga, C. Suppose I will do like this, not like this. Suppose CH3, CH double bond, C, CH3, CH3. I will do 2 things. One is reductive ozonolysis, one is oxidative ozonolysis. Now, reductive ozonolysis, break it. This contain hydrogen, yes, converted into aldehyde. This contain hydrogen, no sir, this carbon does not have a hydrogen. So this will converted into ketone. CH3, CH3. Reductive ozonolysis done. Oxidative ozonolysis, this will converted into CH3, C double bond O, OH. 1H, OH. Over here, this carbon, anyone has H? No sir, no any hydrogen is there with this carbon. So as it is, either oxidative or reductive, coming the same. Now I hope you understood what is oxidative and what is reductive. I am trying my best to make you understood. Suppose I will write like that, double bond, Ringa, Chinga, Pinga. Now break it. Over here, reductive ozonolysis. Over here, oxidative ozonolysis. I will break this bond from here. It has hydrogen, no sir. So one will convert into ketone. It has hydrogen, yes sir, one hidden hydrogen. So it will convert into double bond O, H, Ringa, Chinga, Pinga, aldehyde. Now over here, this carbon has any hydrogen? No sir. So oxidative also as it is. This carbon has 1 hydrogen, converted into OH. And 1 OH will not convert into carbon dioxide. If 2 OH is there, that will convert into carbon dioxide. This is oxidative ozonolysis and reductive ozonolysis. I hope you understood what do you mean by ozonolysis. Acha. Sometime they will say कि one product is propanol and one product is suppose butanol. What is the reactant? This is the product. Tell me what is reactant. What is the reactant in this case? Don't worry. Draw the structure of propanol. CH3, CH2, C, double bond OH. Put double bond this side. Butanol. Double bond OH, 1 carbon, 2 carbon, 3 carbon and 4 carbon. Remove this O. Oxygen remove and put the double bond in between that. CH3, CH2, CH, double bond. CH, CH2, CH2, CH3. Oxygen I have removed from here and double bond between the carbon. You will break this compound, again you will get the previous one. So like that you have to do. Understood? Oxidative reductive ozonolysis. Yes sir, we understood. And don't worry, any doubt? 9267937718. Sir, how many time you will give number? Now we are getting, after now your number we have learned it. That many time you have given the number. No, I am not giving the number for you only. Suppose any new one is started watching this lecture only and they didn't understood anything, they will ask me on WhatsApp number. This is my WhatsApp number. You will message, I will dictate over there. Okay? Acha sir. Now we are going to understood the mechanism of ozonolysis. Mechanism of ozonolysis. I hope you understood up to this. Now mechanism. Mechanism I am going to write CH2 double bond CH2 in place of O3 plus CCl4. O3 structure is O double bond O, O minus. What will happen? First see mechanism. Over here CH, over here double bond converted into single bond. Then O minus will attack over here. And over here O double bond O. And their lone pair will attack here. This is known as moloozonoid. Moloozonoid. After having the moloozonoid, it will form something like this. CH, O, CH, over here O, over here O. And this is known as monoozonoid. This is this is monoozonoid. The first moloozonoid, after that monoozonoid, after that this structure O, this structure I am writing again CH, O, O, CH, this. Now if you will take Zn or PPS3 or if you will take SME2, this will do what? Na? They all will trap this oxygen. They will trap. Now it means Zn or PPS3 or SME2 will do what? Trap the oxygen. And once it will trap the oxygen, so it is known as reductive ozonolysis. After that what will happen? HC double bond OH, one aldehyde, this part, and plus HC double bond OH. 2 moles of aldehyde will form. So I hope you understood this part. Acha sir. Suppose I will take another example. Acha, if the same thing is oxidative ozonolysis, suppose this is reductive ozonolysis, na? Acha, because it is trapping. Over here I have taken O, CH, O, O, CH, this. And over here I have not taken Zn, I have not taken PPS3, I have not taken SME2. Then it will no trapping oxygen. So you will get OH over here, C double bond O, OH over here, OH over here, C double bond O, OH over here, and this will convert into carbon dioxide, this will convert into carbon dioxide, 2 mole, 2 OH is there, 2 mole is there. Understood the point? Everyone? Any problem? Okay sir. Now, see it again. I am saying that if any problem coming, see the things once again, it maybe it is going to be easy, but I am doing it. Suppose one question is there, JEE means A equals to O3 in presence of Zn CCl4 and giving the product propanol plus acetone. Tell me what is A. What you will say? Acha sir, propanol 1, 2, 3, over here double bond O, H, acetone, ringa, chinga, double bond O. What I have told you, remove this double bond O and put the double bond in the carbon. 1, 2, 3, double bond, ringa, chinga. This is A answer. Understood? O oxygen remove, put double bond. That's it. Suppose they will give you another question. Ringa, chinga, pinga, hinga, linga, bhatinga. Double bond, double bond, double bond. And they are saying to do the reductive ozonolysis. What you will do? You will break this So it has hydrogen, yes, aldehyde, aldehyde. Break this, aldehyde. Break this, aldehyde, aldehyde. Means don't get confused. I will break line by line. Otherwise you will get confused. First I will break this. What you will get over here? CHO. After that double bond O. First you will get over here CHO, then this carbon, double bond, then this carbon, then this carbon, double bond, then this carbon, CHO. First, line by line. Then I will break this. This I will break. What will happen? After breaking this part will go outside. You will get CHO, CHO. This part I am writing. Then over here what you will get? CHO. After that double bond and here CHO. Then you will break it. What you will get? This CHO, CHO is there. Plus this CHO and here CHO. CHO, CHO. Plus this CHO, this CHO. CHO, CHO. Means this CHO. So these two CHO, this CHO and this CHO. So what you will get? 3 moles of CHO, CHO. That's it. Understood everyone what I am trying to say? Yes sir, we understood it. Now, suppose I will take some more example. Ringa, chinga, binga, inga, ingla, dingshu. Tringa, ding, dringa. Now I am saying do reductive ozonolysis. What you will say? Sir, this I will break. So what will happen? This carbon has hydrogen? No sir. 1, 2, 3 bond. And 4 double bond is there. The 4 bond. No hydrogen. So what you will get? Over here, double bond O ketone. Then here I am going this side. Here, then this, then this, then this, double bond. And then here CHO because it has hydrogen. After that you will break from here. What you will get? You will get ringa, chinga, double bond O, hinga, bhatinga. Over here CHO and this part is coming outside. It has this and this. So CHO, CHO. 2 product you will get. Answer is completed. Understood? Acha sir. Suppose I will take another question. O re pia ringa. Double bond O this. Double bond O over here also. Now I am saying O3 in presence of Zn CCl4. Opposite arrow. Means what I am saying. I will make the opposite over here A. And over here O3 CCl4 in presence of Zn. Tell me what is A. Tell me what is A. What you will say, sir, we are not getting it. But you know, understood, whenever only one compound is coming with 2, it means definitely it has double bond. How many carbon is there? 1, 2, 3, 4, 5, 6, 7 carbon. But you will see over here, this is ketone, this is ketone. It means if I will make 7-member ring, understood? If I will make 7-member ring, what will happen? Everyone has hydrogen, hydrogen, hydrogen. So ketone possibility is not coming. We have to draw the structure of CC, how I am judging it. I will draw 1, 2, 3, 4, 5-member ring. Here I will put double bond and here I will put this. What I will get? I will get over here, this brocage, 1, 5, 6, 7, this. So over here one ketone I will get, over here one ketone I will get. Outside and this remaining is a ketone. Understood the point? So whenever only one structure is there, with that structure it's something asking to think about ring. But more than 2 structure or 3 structure is there, then slowly you will do. Understood the point? Everyone? Sure short? No sir, we didn't understood this. No problem. Do like this. Start from here. Carbon, then double bond oxygen, then this carbon, then this carbon, then this carbon, then this carbon, double bond oxygen, then this carbon. Remove this oxygen and see 1, 2, 3, 4, 5. 5-membered ring. Over here double bond, this. What I have told you the logic, same logic na, and same I utilizing over here na. Oxygen remove, double bond put in between that. Done. Like that also you can do. So I hope you understood the part of the topic, and the name of the topic is called ozonolysis. Now I am going to start next after that last topic, and this chapter will be 100% completed. How much you are happy, I am also happy today. That much. Now second last part of the topic, after that last part of the topic. Okay sir. Next part of the topic directly you have to learn. And what is the topic? Topic is called hydrolysis of carbide. And trust me, from this topic, direct question coming, direct, without any confusion. 4 reaction, learn it, question will come. First reaction, whenever CaC2 react with 2 mole of H2O will, calcium will give CaOH whole twice plus C2H2. C2H2 is known as acetylene. And important is this, कि hydrolysis of calcium carbide will give acetylene. Acetylene means CH triple bond CH. Second, that is important, CaOH whole twice, that bakwas is not important. Similarly, magnesium carbide in presence of H2O, HOH, 2 mole of MgOH whole twice is not important. Important is it will give C3H4. Directly you have to learn C3H4, C2H2. These are very important. Third, Be2C, H2O, HOH. It will give 2 mole of BeOH whole twice plus CH4. That is important, CH4. Fourth one, Al4C3 in presence of 12 H2O. Over here we have to take 4 H2O. 12 H2O, we will get 4 AlOH whole thrice and 3 mole of CH4. That is also written as C3H12. Sir, don't get confused. Nothing to worry. Simple question. Hydrolysis of calcium carbide, acetylene. Hydrolysis of magnesium carbide, C3H4. Hydrolysis of beryllium carbide, CH4. Hydrolysis of aluminum carbide, this remaining reaction you didn't have to learn. This part, and only 4 is there. Only 4. Remaining not there. Understood? Yes, sir. Understood. Now, last part of the topic, and the name of the topic is called Birch reduction. Name of the topic is Birch reduction. And Birch reduction is used to do anti-addition. What anti-addition? Sir, just wait. Anti-addition. Now, over here, what we will do to get trans alkyne from alkyne. What is the reagent we will use? We will use the reagent. What you have written, meaning, sir, we didn't understood. Just see it. Reagent used over here is Na in presence of liquid ammonia, NH3, and that reagent is also called NaNH2. But especially NaNH2 I have never seen, so don't write it. Otherwise you will get confused, because this reagent I have used in E2 mechanism also. Sir, if they will write, so E2 you will do, don't worry. Na plus liquid ammonia. Over here, Na plus liquid ammonia does like to do acid base reaction if possible. Sir, what you are writing, not getting. Arey sir, Birch reduction, anti-addition, reagent used is liquid ammonia in presence of sodium. It always first try to do acid base reaction. After that only anti-elimination. Means, suppose I have taken CH triple bond CH in presence of Na and liquid NH3. What you will say? Ki, sir, this C has acidic hydrogen, this will break and it will form CH triple bond C plus and C minus Na plus. If acid base reaction, it will do acid base reaction. H2 is there, half mole of hydrogen gas will come. Suppose I have taken CH3 C triple bond CH Na in presence of liquid NH3, it will give CH3 C triple bond C Na plus half mole of H2. Means, if terminal alkyne is there, then always do acid base reaction. Why? Terminal alkyne has acidic hydrogen. So if the side part alkyne is there, then it will do acid base reaction. But suppose I will write C triple bond C and R, and then I have written Na in presence of liquid NH3. Tell me, does this triple bond has hydrogen? No hydrogen, sir. Then what will happen? Just listen it very properly. The things is that Na will give electron and it will form R, C. What happens? This will break like this. It will get negative any one side. It will get positive. This electron will given to the positive. What you will get? R, C. It has one electron. Double bond. Negative means it has two electron and R. Now, after that, it will behave like a trans. So I have written it always give to get transalkyne. To get transalkyne from alkyne only. First normal alkyne, I will go transalkyne. What I will write? C. One lone pair coming here, one electron. Over here R. Double bond. C. One lone pair coming here and over here R. On this side H dot will come. On this side H plus will come and they will react. And after reacting, they will form C double bond C, over here H, over here R, over here R, over here H. So you didn't have to worry that much. You have to simply know कि CS3, C, triple bond C, CS2, CS3 is there. Don't worry about it. Simple write कि if Na and liquid NH3 is there, first write C double bond in place of triple bond. If you are writing CS3 this side, so one hydrogen you will add this side, double bond. Over here you are writing H because trans you have to make, remaining all the things one side, CS2, CS3. This I have written, this I have written. Hydrogen I have to add, I have added in the opposite side. That's it. No need to mechanism. Understood this part? Sure short? Yes. So always it will give transalkene if no acidic hydrogen. If I will write CS3, this part suppose Ringa, Chinga, Pinga, Hinga, Linga, Batinga, Singa, here, here and here, here. From this part, advanced question, from this part, you will get transalkene. But from this part, you will get acid-base reaction. Understood? So they will ask how many acid-base reaction? 1. How many transalkene? 1. Understood? I will write questions also, don't worry about it. So this is acid-base reaction. They are asking how many acid-base reaction. How many transalkene will form? So don't form over here. This is acid-base reaction. Only one place transalkene will form. It means in the middle, no hydrogen is there, transalkene. On the terminal, hydrogen is there, acid-base reaction. Some more is there. That is reaction with benzene. Suppose I have taken benzene ring and I am using Na in presence of liquid NH3. So you have to make benzene ring and break the double bond in such a way that double bond will go parallelly, either like this or like this or like this. Anyhow, double bond will be parallel side, opposite side. Acha. Suppose anyhow another question. Over here benzene ring and some electron withdrawing group attach like NO2, like CN, like COOH attach, and then you are reacting with Na and liquid NH3. Then first electron withdrawing group you will not remove. You will write electron withdrawing group. Then try to put the double bond. Not here, not here. Opposite. It means in this case, double bond you can't make like this, non-electron withdrawing group. You can't make like this, non-electron withdrawing group. Always try to go little bit farther. So always double bond will come here and here. Understood? Acha. If opposite, ki electron donating group is over here. Electron donating group is over here. Like OH, like OCS3, like NH2, donating group. And you are reacting with Na and liquid NH3. What you will get? Ringa, Chinga, Pinga, electron donating group. Now double bond will come like this or double bond will come like this. On the same side, on the place of electron donating group here and in withdrawing group little bit farther away. Understood? Any confusion? No sir. So I hope you all understood this Birch reduction. After that, this is the completion of this chapter and I am very happy that I have completed the most important chapter of organic chemistry, that is hydrocarbon. If you have watched up to till this from the beginning, then I request you all to give one good comment if you will enjoy this lecture. Bye. Have a nice evening. Enjoy. Take care. Stay home. Stay safe.